Hello and hi everyone. Welcome to the second day of Blockchain Bootcamp for Women organized by Kerala Blockchain Academy in collaboration with Kerala University of Digital Sciences, Innovation and Technology. The two-day free Blockchain Bootcamp is a novel initiative of the KBA Women Connect, seeking the empowerment of women to get into the blockchain technology and become leaders. Myself, Anju from Kerala Blockchain Academy, and it's my privilege to host a two-day free blockchain bootcamp for women. To kickstart the day energetic, we have with us a blockchain athlete who has applied her craft in multiple positions and has donned different roles in blockchain sector. We have with us today none other than Gnana Lakshmi, who's a leadership fellow in blockchain at Women Who Code, an international nonprofit organization that provides services for women who are pursuing the technology careers and also acting as a job board for companies seeking the coding professionals. She has over 7 years of experience as being a software developer in corporate industry. Gyan is extremely passionate about the women in technology and has been leading the Bangalore network of Women Who Code initiative. She has conducted several meetups and tech talks on various topics, including blockchain and machine learning. She's also a very hands-on coder and loves working on emerging technologies. It's a great privilege to have Ms. Gyan on free blockchain bootcamp for women organized by KBA. On behalf of KBA and KBA Women Connect, I extend my warm greeting to you. Thank you for joining us live, Gyan.
Thank you, Anju. My video seems disabled. Could you just give me
Yeah,
a
I'll have a look. I'll have one sec.
pop in and say hi, and then we can get started. Oh, okay, awesome. Hello, everyone. A very good morning. I hope you're all able to see me. Thank you so much for joining me today, and thank you for this beautiful introduction, Anju. Coincidentally, I was having a conversation with a group of women in another group just very recently, I think yesterday or day before. And, we were discussing about how women generally shy away from switching on their video, right? And this is not just got to do with how they look or whatever. And there are a lot of factors associated with it. Probably they are not in the right place at the right time, etc. But that's why I always like to switch on my video and pop in and say hi, even though I can just share my screen and go ahead. Just want to share this tidbit with you, on Women's Day, that if you do want to contribute and you feel like in any meeting, if you feel like you want to make your presence felt, and because it's an online and remote world, in whatever situation you are, in whatever condition you are, feel free to just switch on your video, drop in and say hi, so people on the other side know who are you, and that you're there, you're participating, you're actively participating. So yeah. So now that we have a pro tip, let's get started. I hope that we are able to, everybody's able to switch on the videos at least for a minute or so. So I can just click a picture, right? Let me see. It, I don't see how I can see the I'm only able to see the speaker view. Okay, maybe we'll do this at the end of the talk. Maybe we'll like take like 5 minutes or so, and then while we're doing the Q&A, if possible, please switch on your videos just for like a minute, and I'll take like a nice picture of everybody, right? As Anju already mentioned, my name is Gyan, and I'm currently working as a product manager for emerging technologies with Wiley Next. I'm quite passionate about blockchain. I have done two talks with Kerala Blockchain Academy, so I'm really excited that I was invited for the Women's Day talk today, and I'm going to be talking about a very interesting topic today, which is taking the world by buzz, that is NFTs, right? Non fungible tokens. I'm going to be giving a brief introduction about NFTs, and I'll also show you a little bit of code. Maybe we'll not go too deep into it because of the time constraint, but I'll just show you how easy it is at the back end, right, to work with NFTs from a code perspective. So, without further ado, let's get started. Uh, because this is the first talk of the day, And since it's a little early in the morning, I mean, at least it's a little early for me. So I prepared a PPT which is a little more, funky. So I hope you enjoy it. So yeah, let's get started with NFTs. So before we actually talk about NFTs, right? Let's talk a little bit about what are assets, right? So we do an assets 101. So people are aware as to where we stand today in terms of digitization of assets, right? So what is an asset? An asset is simply something that is useful or valuable, right? It could be an object, an expertise, a cryptocurrency, a dollar bill, right? So it could be anything. So anything that is of importance, that is useful, that is valuable, it's an asset. Where can assets be traded? Wherever we have a marketplace or a market, that's where we can trade, exchange these assets, right? Now let's come to asset digitization, right? What is asset digitization? Asset digitization is creating a digital version of physical analog assets. For example, if you have a mobile phone, right, and you want to say ensure that you are able to enable like the lost my phone and find my phone, sorry, find my phone property, you can digitize this assets by generating a unique barcode that will be present on your phone. We already have something for every device, right? So that is nothing but digitization of this particular asset, right? Now this digitization, as we are going, as we are expanding, as we are becoming more and more remote, more online, as the economies are becoming more digital, most of the assets that we have, we are trying to move to a digital form. So it could be documents, it could be tradable goods in the supply chain, or it could be art, it could be digital land, in fact, right? So there are a lot of these assets that are now becoming digital, right? Let's see the process of asset digitization and understand it a little bit before we go into what are tokens. So, what happens in asset digitization in a blockchain context, right? So, every asset is owned by someone, right? It's either it could be the creator of the asset, or it could be somebody who sold the asset, exchanged it for something else in return, right? So, the rights to an asset are converted into a digital token on a blockchain. The ownership rights can be transmitted and traded on a digital platform now. That is the idea of converting an asset into a digital token, right? The real world assets on the, say, whatever real world assets we have, like this phone or anything else for that matter, are represented by digital tokens on blockchain, right? So, your physical assets, a digital footprint is created for them. Using that digital footprint, the ownership rights can be transferred digitally without having to go in person, physically, sign documents, etc. The real world assets can be represented by digital tokens. So, this is how your tokenization came about in an asset context. So, what is asset tokenization, right? So it is the now is when we come into what is tokenization and in the context of assets. So tokenization is the method to convert the ownership rights in an asset to a digital token, because you have an asset, but how do you represent the value of that asset on blockchain? You use the process of tokenization. For example, if you have an asset worth $200,000, it can be converted into 200,000 tokens, where each token is equal to 0.005% share of the asset, right? So one of the things is that, and this is I won't get too much into it, but assets that can be owned fractionally, right? This is also a new concept that is coming in. So when you're able to tokenize, and if you own particular x amount of tokens, you can own some percentage of that asset. So for example, imagine and this was a use case that came to me about a couple of years ago actually. Imagine being able to own a house in US, just part of the house, right? So it is like investing in something, a bigger asset, but you can own a part of it. And this is possible through asset digitization and tokenization, right? Once your asset is converted into tokens, the tokens can be issued on any blockchain platform that can support smart contracts. For example, Near is one of the blockchain platforms I just chose as an example here, right? Now, what happens when these assets are converted into tokens? When a user buys a token, that means, so now when a user buys one token, they are buying 0.0005% of the asset's ownership. Now, if you are able to buy 80,000 tokens, then you can own 40% of the asset, right? And whoever is able to buy all the 200,000 tokens, they become 100% owners of that property, right? This is just an example. You don't have to take this literally. Not all assets can be owned fractionally, right? Some of the assets only can be owned as a whole. So, this is just an example of how assets can be tokenized on a blockchain digital world. Now, one of the things that is happening now is this movement, right? Where assets are being digitized, assets are being tokenized. So, how do we digitize the assets, right? The first thing that we need to do is identify why do we need to digitize this asset, right? It could be trace the different customers who own the asset, the quality of the product, or if you want to derive insights from the data about that asset, right? There are various reasons. Of course, one of the primary reasons is the asset is completely physical right now, and it is becoming difficult to exchange it in a physical context. That is, there's a lot of fraudulent documents available. There's a lot of fraud, or ownership is not being clear. For example, land ownership, right, in India has always been one of the top issues, if you see. So think about this as, why do you want to first is identify why do you want to digitize this asset, right? Then second is, how do you want to digitize, right? How can you attach a physical entity to this product? So if you have a product like a big product, say I don't know, like a bag of coffee beans, right? How will you actually digitize that asset, right? It's a bag of coffee beans. So what will you attach to that? What will you use to ensure that that bag of coffee beans, which is a physical asset, becomes a digital asset? What is the process that you can follow? So, first is why, and second is how, right? And third is, once you digitally register and activate the ID for that asset, ensure that the kind of data that you're collecting from that asset can be used to derive valuable insights, right? Because that is your whole additional point of having a digital asset. You can always have a physical asset, and you can exchange it and then you can forget about it. But think about moving assets. What is the value in digitizing them? The value is being able to derive some valuable insights from the movement, or from how the asset is behaving in the market. So ensure that whatever data you associate with the asset, you're able to derive some insights from it. Why tokenization? Well, it's because you can get increased liquidity in the market, right? Your cost to kind of work with that asset is reduced, right? You don't have the overhead of signing digital documents, or paying extra bribes, or ensuring that ownership is transferred to your name, right? Everything is happening digitally. And then faster settlement. This is something we have seen as well, right? Suppose you want to own a piece of something that is digital, a piece of digital art, right? Once the smart contract executes, the ownership is immediately moved from person A to person B, right? So the settlement is extremely fast when it comes to blockchain. And this is why people started preferring tokenization. Here are some more advantages of having blockchain and tokenization. You get an immutable record of what is happening, right? It's If you use a public blockchain, then it's available in the public distributed ledger. There are no territorial barriers, right? You don't have to in person go and just buy from somebody who's your neighbor or who's living like at a 5 kilometer radius from you. You can always buy stuff that is in, Africa, that is in US, because it's all now digital ownership, right? Fractional ownership, again, this is something interesting that I mentioned. It's very interesting in a real estate use case, right? Imagine being able to be a part owner of a chateau in France, right? How cool is that? And quick and cheaper transactions, of course, right? Because we are using an underlying blockchain. Now, let's go to NFTs. We're finally here. What is the difference between, so now that we know about tokens, tokenization, and assets, right? When I say non fungible and fungible, think of them as non fungible assets and fungible assets, or as non fungible tokens and fungible tokens, right? So you can draw parallels as you know now what is an asset and what is a token, right? So, fungible assets are your day-to-day money that you use is one of the best examples of your fungible assets. They have the ability to be swapped evenly with an asset of the same type. That is, they are interchangeable. What does that mean? Now, your fiat money is a fungible asset. That means if you have $100 bill versus if you have five $20 bills, you can exchange these two, right? Because the type of the asset is fungible. They can be exchanged with each other. They can be easily interchangeable, right? When it comes to non-fungible assets, right, they are the opposite of your fungible assets. They are important, they have some value associated with them, but they cannot be interchanged, right? Now, think of something that, for example, when you're playing this Angry Bird game, right, think of something like a badge that you won in the game, right? It is completely different from what some say somebody else who has won another badge in this game, but maybe at another level, right? These two are not interchangeable, right? One of the other examples that we also give to understand this in a better context is, suppose you are making something at home for your family or for your extended friends or whatever. Suppose you are making cupcakes, right? And say you give the recipe to your friend and your friend also follows the same recipe. The actual end result is never going to be the same, right? It might be the same in the taste and the texture, etc., but your whatever product you create has a touch that you have given, and whatever product somebody else creates has a touch that they have given, right? And these two cupcakes that have been made by you and your friend are non fungible assets. They are actually not interchangeable, you know uh, so this is one of the interesting properties of non fungible assets that help create non fungible tokens to represent digitally owned objects, right? So let's understand a little bit more about what are NFTs, right? So NFTs, or non-fungible tokens, can represent a digital asset that is unique in nature. Like I said, your cupcake is unique, right? And somebody else who maybe replicates the same recipe, their cupcake is unique to them, right? So you can, and similar to that, you have digital art, you have digital media, you have domain names which are all unique in nature, right? And NFTs can represent a digital asset that is unique in nature. The ownership of NFTs is recorded on the blockchain using digital agreements called smart contracts. So, as we just saw a couple of minutes ago about asset digitization and creating the ownership on blockchain, this is where NFTs bring in are bringing in a lot of excitement, because the ownership of these NFTs is recorded on the blockchain using digital agreements called smart contracts. Now that the ownership can be recorded on blockchain, it can be easily transferred, right? So the ownership can be transferred and traded online using secure blockchain contracts at the backend. That is the third point, if you see here. And NFTs are becoming more and more popular because they have brought about a secure way of creating digital ownership. right? Of scarce material. This is very important, right? Now, I'm sure, I don't know if you have heard of this, but if you see, there is a platform that is now NFT making your tweets, can make your tweets as NFTs, right? So there is a recent tweet that was going about by Jack Dorsey, which is now being bid for, like, I think millions and millions of dollars, right? So according to me, that does not make sense, because NFTs are creating a secure way to delegate ownership of assets that are scarce, right? Like your digital paintings, your digital art, or even domain names, I would accept that, or collectibles in a game. That is also becoming a very, very popular use case, right? You play some game and then you collect something in the game, like a gun, a sword, or maybe, I don't know, like a diamond, an ice cream, or whatever. And that's your NFT, and that you can actually trade, not just within the game but even outside the game, right? You can sell your ice cream, which can be which can act as a superpower in this particular game. Somebody else playing that game can buy that ice cream and then use the superpower in this game, right? So this is also becoming very popular. Collectibles within in the gaming world is also a popular use case, because these are also scarce, right? You only get them within that game. So whenever you think of an NFT use case, or platform that you're building, even real world assets, you can actually go even until there, right? Automobiles, land, etc. These can be NFT'd if enough effort and thought is being put into this, right? So ownership of scarce material, that material is not largely available, right? There are a couple of popular NFT standards, I'm sure that you must have heard, which are going about. The first one is ERC 721. So, an NFT standard is nothing but a set of rules that describes how this particular NFT will behave. These rules can pertain to a lot of things. It could be how a particular NFT is created, or how the tokens in the NFT are minted, or what can you do with an NFT. You can mint the tokens, you can burn the tokens, etc., right? So it's just a set of rules. Don't worry so much about it. It just says, like, okay, like a Bible. I wouldn't say Bible, but set of rules showing how, what an NFT is and how it should behave in an ideal sense, right? And how should programmatically, how should we construct the functions programmatically in order to replicate a particular NFT behavior, right? So ERC 721 is one of the first ever Ethereum based NFT standards that came about, and it is still extremely popular, right? And a newer standard is introduced recently called ERC 1155. It is a recent standard that helps you create classes of NFTs. So, for example, some of the NFTs could be, some assets could be fungible in some class, or it could be non fungible in some other class, right? For example, a particular sword, a collectible that you gain in a game, it could be exchangeable in that game, right? You could exchange the sword for something else, say a gun, in that particular game. In that case, it becomes a fungible asset. But in the outside context, when you're selling the sword, right, it could be just a non-fungible token. So this ERC 1155 is it allows you to create classes of assets which could be both fungible and non-fungible. Now, I'm going to be introducing another class of NFTs, which is NEP4. Why am I doing this and why am I not sticking to ERC 721? Is because, as we all know, due to a lot of increase in the gas fees in the Ethereum ecosystem, right? Artists who are trying to create digital art and sell them as NFTs are having to pay a bomb these days, right? So they are paying, like, if you have an asset, an art piece that you want to sell for, like, say, $50, they sometimes end up paying $70 in gas fees, which is ridiculous, right? So now there are a lot of improvements coming up with layer 2 solutions, etc. But we can also look at other blockchains that are offering the NFT feature. feature. So the NEP4 NFT standard has been created by the Near blockchain, Near protocol, right? So you can see that the Near team has created an NFT reference implementation that uses a different NFT standard, that is NEP4, right? I will open this and show you maybe in just a bit, right? I've opened it over here. We'll see that as well. So, what is NEP4? It is a very simple standard that does a bare minimum required to support ownership and transfer of NFTs. Now, why is this important to have a bare minimum standard? Is because you can, you can inherit this contract and then change it the way you want your NFTs to behave, right? You may have certain type of NFTs that you're creating where you would think some different kind of ownership rules, or not ownership, I would say, but some kind of additional rules need to be applied, right? So this framework just gives you a basic idea of how you can support the ownership and transfer of the NFTs. I'll show you that in a bit as well in a code format, right? And you can also make your own changes or add your own stuff, right? So one of the important things about NEP4 is it includes the possibility of delegating authority to other users or to other smart contracts. So you don't have to actually, sit and modify the whole code again, right? So yeah, so that what it means is that you, whatever future enhancements that you do, it might be added by cross contract calls with another smart contract. So instead of having to upgrade the contract that we have today, you can make cross contract calls, right? And then you can add the future enhancements to that, right? So there is, okay, sure. All right. uh, Okay, so now before going to the code part of things, just a small demo that I've set up. Let's take a look at the steps, right, for putting up the NFTs on sale, right? Before that, maybe I can show you. What should I show you? Are you able to see my Chrome screen where I'm opening up this Mintable.app?
Yes, we can see your screen, Rana.
Okay, great. So if you see on the right hand corner, right, I will select, you can either select Ethereum or Zilliqa. Let me just be here, right? And I won't be creating an account or anything, right? So here you can see, you can list an item for sale, right? It says create it, mint it, earn crypto. Turn any creation into a blockchain item. Trade digital items on Mintable to easily earn crypto. So you can list an item for sale. So you can say that I already have the NFT in my wallet, or I want to create a new item. Now I don't have any NFTs in my wallet, right? So I can create a new item. So here it asks me to create like my user account or whatever. But you can, whatever, say you can see, right? Somebody has created the dark official music video. Then there is Mask Monkey. Like you can see, this is like a one of a kind of piece. And then you can see what are the different types of NFTs that are there, right? Psychedelic rave smiley, and then you have some Bitcoin art, you have crystallized in the rain, right? Underpriced. There are some NFTs, it seems they are completely underpriced. So you can see the only cheap gas or space. So basically what you can do is you can create a digital piece of art, or you can also, if you own an Ethereum domain or any other decentralized domain name, there are different types of NFTs that you can upload, right? And you can list them for sale. You can list your price and it will go up for sale on this platform, right? Now programmatically, how does it happen? Let me just share that with you, right? Three simple steps. First one is, for your NFT, an NFT contract is created. Okay. So what that means is the NFT creator or owner needs to deploy and either an ERC-721 or any other, say NEP4, whatever standard you want to work with, right? The and that standard contract on the blockchain of their choice by providing a name and a symbol for their NFT. This is the general practice. It would vary from standard to standard and contract to contract. But from an ERC 721 context, this is how your ERC 721 basic contract exists. Okay. Now, this, whatever you deploy, this NFT contract is not your item. It's not the item that you're putting up for sale, right? The item that you put up for sale are actually your tokens. But what you can do is you can create a group of tokens under one NFT umbrella, right? And then put them up for sale. So first, when you deploy the contract, you just get an NFT address, right? Which will indicate that now you have created an NFT. So that's why when you saw on the app, right, you saw that it asked, do you already have an NFT with you, or do you want to create an item, right? So when you say create an item, the first thing that happens is an NFT contract is deployed, and you get an NFT address which is unique for you, right, on that particular blockchain. The next step is to mint the piece of art or collectible. So using this NFT address as a reference, you can mint these art or collectible, right? So under your, so NFT is more like your say, if you have wallet, right, and then you have money inside, so your NFT is more like your wallet, and your tokens are actually the money that are going inside the wallet. So you can mint various number of pieces of art under the NFT, right, using the mint function provided by that particular contract. And once you mint the tokens, you can put them, the art or the collectibles can be put up for sale, right? So you can put up like, you can put up five tokens under one NFT. You can put up one token for one NFT, where that particular NFT will be, transferred upon the ownership of that NFT will be transferred upon sale, right? So this is a simple process as to how the NFTs go up for sale. Okay, so for this demo, what I have done, let me see, there is a, okay, awesome. Sorry, I thought there was a question. Feel free to pop in if you have any questions on the chat, right? This demo, I won't do the entire demo. Let me just open up. Okay, so this is the demo that I kind of want to show, right? I won't be showing the contract or anything because let me just post this link in chat. But I just want to show you like how easy it is to, okay. Yeah. So this is Figment Learn is a website where you can learn about different blockchains for free. There are various pathways, where you can learn from the basics to the most advanced tutorials that are available here, and you can also do them, uh, on you can practice them on this data hub, right? This is a Figment Learn website. So let me stop share and reshare again. Desktop. Okay, right. So here you can see my terminal, right? Let me make it a little bigger. Okay. And then I'll open this Figment tutorial. All right. So here you can see that you can write an NFT contract and mint your own NFT. That's the tutorial. That's what the tutorial is all about. Here they talk about what are NFTs. Some of the famous NFTs are your crypto kitties and super rare, right? Two popular examples of Ethereum based NFTs. We can also implement NFTs just as easily on the near blockchain, right? So in this particular tutorial that I have chosen, there is a new species of NFT called the crypto flan, right? A single cell organism with unique DNA that is being created, right? So if you might have heard of crypto zombies, which is a tutorial to learn Solidity, right? Something similar happens over there. So here, like I said, the NEP4 standard is being used. So you can see that when I click on the NEP4, there is a GitHub repo that talks about non-fungible standard 4. You can also go. So it just is a standard interface for non-fungible tokens, allowing ownership and transfer, right? So you can see that there is a simple transfer, and then You can see like what and all exists in the code. There is grant access, transfer from, etc. So you can go through this and see the technical details. There is a template for smart contracts, right? Now, the smart contract, that is the actual, the NFT smart contract is written in a language called Rust, right? So we are not going to go through the smart contract. What I want to walk you through is just the process, just to, see that how easy it is and how it happens in the backend. So all the prerequisites and everything I have already installed on my system, right? And all this tool chain, the Rust up tool chain, everything is installed. As you can see, I was already trying this out, right? So I have a folder which I've created called NFT, and you can see that inside this there are contracts, and then there are the node modules, etc. Right. So everything else I have already installed, and I have cloned the repo and everything. Right. Um, so let's go down. Right. Okay, so I will just show you the Rust smart contract since I have it opened, right? So here is the smart contract for actually creating your NFTs and minting your tokens, right? So you can see that, so you have like this NEP4, it's a trait. A trait in Rust is similar to your interfaces in Java or C++, right? And these are the main functions that work on your NFT, right? So for example, this is the grant access, right? It grants the access to a given account ID for the token ID. That is, this particular account ID has now access to this particular token. Remember, tokens are nothing but your art pieces or collectibles, right? Then you have revoke access, that now this particular account does not have access anymore more to this particular token, right? Then you have your transfer from, right? So you can transfer your token from a particular owner to the new owner, because that's what NFTs are about, right? They're about ownership and transfer. And then again you have this other another transfer function, right? This will kind of use your transfer from, right? This the transfer uses the above function that is here. And then check access, you can check if a particular account has access to a particular token or not. See, the thing is, why these functions are important. Okay, let me tell you. First is this check access, right? Now when somebody tries to put up something for sale, you need to ensure that they actually own that piece of token. That means they have already registered that NFT earlier using their account, right? And get the token owner, right? So you get whether who owns that particular token, right? So you get an address over here. And similarly, the transfer and the transfer from, I used to transfer the ownership from one NFT owner to another NFT owner. Your grant access and revoke access are, you give the access to that particular account, to for a particular token or something, and then you can revoke the access as well. So you can see that this is just the skeleton of functions, that's all. This is just a simple set of functions that is present, and you can use these functions and write whatever you want, right? So if you just go down a little bit, we have created a structure called flan. Like I said, this is about creating a crypto flan, each of which will have a unique DNA, right? So everything is unique. So you can see that there is a DNA variable, that is u64, that is defined under the struct, right? I won't go too deep into the code since I just want to show you the demo part, right? So you can take a look at the code as in when you have some time, like during your leisure time. So you can see that using this we can look up a token's owner, transfer a token between owners, assign or revoke token transfer rights to another user, right? Let's just move on. Okay, you can browse the rest of the code at your time, right? All of these changes I have already made, so I'm not stopping, right? So let's, okay, all of this is done. Okay, I will just deploy this contract now. So I am using the near CLI, right? So you can download the near CLI as well, and then I'm just deploying the contract. So near dev deploy out NEP4. So WASM is your WebAssembly, right? And as you can see, the contract is deployed, right? Now you get an account ID, right? So this is your account ID that is generated for you. Dev hyphen a set of numbers, right? And this is the account ID that we will be using to mint the NFTs, right? So once I have deployed this contract, right, you can see that I've got the account ID, etc. You can also see the transaction in the Explorer, right, how they are mentioned over here. Let's see our contract on the testnet. So you can see that there is a transaction signed by receiver. You can see this is the same ID as the account ID that is creating. It is succeeded. You can see the transaction fee, gas used, the hash of the transaction, block hash, etc. Right? So let us go back. Oh, sorry. Uh, Zoom is not. Give me 1 second. Yes. Okay. Okay, so we saw the transaction now, right? Now what we are going to do is we are going to initialize our contract, right? So there is a new method in the contract which is used to initialize the contract. So think of this as initializing your NFT, right? So here we have this called, so here what we need to do is for the owner ID, the receiver ID and the caller ID, we'll just copy paste this account ID, right? Don't worry if you're feeling like this is like too overwhelming. I'm just going to be showing you 2 3 commands. That's about it, right? So one command I've already shown you, that is deployment of the contract. Why I wanted to show you this was to show you this account ID, how it is being created, right? Because think about every NFT, every token, right? It is owned by someone, so you need that account ID. That's why I wanted to show you that deployment. And now what I'm doing is I'm doing near call, right? Using this account ID, I'm going to be calling this new function, right? So that means I'm initializing the contract first. So once I initialize the contract is when I can mint the NFT. So you can see that, oh, okay, seems like I had already initialized this. Okay, maybe it's generated the same as yesterday. Let's see if I'm able to mint one. Okay. Okay, so I'm saying now, sorry. I'm going to paste this account ID here so I can copy it while I paste this command. Okay, so here I'm calling this function called mint token, right? And I'm going to give the owner ID as this particular account ID that I just created. I think the new function did not work because I had already created, deployed the contract and initialized the function yesterday itself. So that's probably why it's kind of panicking. Let's see though. Okay, let's see. Maybe because I already ran these yesterday, it's like panicking now. Should have deleted it and redone this. Okay. Okay, so here I am trying to get the metadata of this token. Okay, I understood what has happened. So what has happened is when I initialized the contract earlier yesterday. So I already created this token. Okay, this is also a good example, right? So if I have already created a token under an NFT, I can't recreate the same token ID again. So yesterday I have already created this 1234, right? That's why this whatever I was trying to do, it just panicked because it saw that I have already created this token, right? So if you see here, here 1234 is given as the token ID. I actually just copy pasted it. I should change it. Let me now change this token ID to 2345, right? And then great, awesome. Okay, so we are finally there. Okay, my bad. I'm sorry. I think that's what happened. That I had already deployed the contract and initialized the contract yesterday. And when I was trying this out, I created a token which was 1234, right? So I figured that if I redeploy the contract, I'll get another address, but that didn't happen. It gave me the same account ID, and for that particular account ID, a token was already created with the token ID 1234. So I couldn't create another one. But now, if you see, I was able to create another token with ID 2345, right? So once I have created this, that means now mint token, right? That means I have minted an NFT, minted a piece. This could be just as well a piece of art or your domain name or whatever, right? And that's all it takes to mint a piece of art in the back end, right? And this is what I wanted to show you. You can later see the explorer, etc., over there. Let me now show you what this piece, whatever token that I have minted, what it contains, right? So it should just contain a random DNA, because that's what we are creating, right? We are creating crypto flans, which with a unique DNA. So if you see, get the token metadata for ID 2345, that is the new one that I have created, and I'll show you one that is for 1234 also, that I had created yesterday. Okay. All right, so you can see that a unique DNA. This is it. This is all you have now, using just couple of lines of code. You have created an NFT. You have minted a token. That's all it takes in the back end, right? And you can, now that you have this knowledge, you can just do anything at the front end, use anything in the front end, just make these calls, and create your mint your tokens. You can mint your collectibles. You can mint your art. You can create a place where you can sell these minted tokens. You can create a marketplace where one can come and mint, right? These. So this is just like as simple as that. That's it. So I showed you for token number 2345. I'll show you now for token number 1234. So you can see that a unique DNA again. Some other so there's just a random number generator which is generating a random number. This is just an example to show you, right? And you can now see how simple it is to create an NFT and mint something, right? All right. Hide video ban. Okay. So let me now go back to the presentation. So that was a quick demo that I wanted to show you. And just a couple of things before we close. One thing is, I wanted to introduce the different communities that I'm working with. One of them is Women Who Code, right? Women Who Code is a non-profit which is based out of US, but it has various chapters across the globe. In India, we have a couple of chapters spread across the globe. I lead the Bangalore chapter for Women Who Code, and we are having and I'm planning to start one initiative called Women Who Code India Blockchain, where we focus on getting more women into technology, right? Generally, our focus is mid-career women, but we also welcome freshers or senior women who are interested to learn about different technologies. So I'm starting this initiative very recently. I'm in the process of kickstarting it, and I'm trying to select a bunch of volunteers across India who are interested to learn about blockchain and who are interested to, maybe work with me and create events, curate events, do some research, etc. It will be completely volunteer based role, of course, same as mine. So if you're interested, you can email me at gnana@womenwhocode.com, right? And we can of course chat, etc., and figure out. Even otherwise, Women Who Code, we do a lot of events, not just in the space of blockchain, but in the space of AI, DevOps, cloud, etc. And all of these events now are online and remote, right? So they're accessible to everyone. So you can always go to www.womenwhocode.com/Bangalore and see what are the events happening. There are also events happening with the Delhi chapters, with Mumbai chapters, etc. Right? So we have a couple of chapters. You can go and see all the India chapters and what kind of events are happening. Apart from that, there is another a community that I'm a part of, which is called Near India Guild, right? So, as a part of Near India Guild, we recently launched a campaign called India Learns Blockchain, where we are trying to spread the word about blockchain to local communities in local Indian languages. So, you can participate in this campaign by being able to create, like, any material in your local language of preference. It should just be in any Indian local language, it should not be in English. So it could be a video, it could be an infographic, or it could be whatever you feel like creating in a local language. You can tag us, and you can tag hashtag Near India Guild and hashtag India Learns Blockchain. And we are offering some swags, some kind of perhaps near tokens for some of the best content creators, right? And even in general, if you're interested in content creation, you're interested to spread the word about near protocol or blockchain in general, in the Indian ecosystem, you can always connect with me, and based on our mutual interest, I can always get you into the Near India Guild and volunteer over there as well. So, a couple of opportunities here. There is one recent initiative that I came to know about right today morning. That's why I don't have like a better slide for this. But the Women Who Code Delhi has organized an initiative, right? That is, you can build some labs and tutorials, right? So they are looking to build a repo of labs and tutorials from the community. So you are invited to create some mini and useful tutorials to share with the community. And for every lab that's published, there'll be like a happy swag T-shirt. So, in case you're interested to participate in this initiative as well, just drop me an email and I'll send you the details, or I'll connect you with the WW Code Delhi chapter. Yeah, that's about it from my end. Thank you so much for being able to join me. And I apologize for the terminal earlier glitch. I kind of misread some parts over there and thought it would work differently. So sorry for that. But I wanted to show you that mint token so you can see, that it's not that difficult at the back end. And all these awesome, this slide template has been given to me. I picked it up from Slidesgo and Freepik. I was super excited by this slide template. And yeah, so the template credit goes to them. I'm open for any questions. If you have anything, just want to ask me. It doesn't have to be related to NFTs, it could be anything. So feel free to just like ask me or even email me later if you feel like.
Thanks, Gyan. It was worth hearing you. Audience, if you have any questions, please drop in the chat box.
Yeah, I Arunima has a question.
Yeah.
What is the best ERC standard to implement shared ownership? So I am actually not an expert on shared ownership, but from what I have heard, and I have only worked with ERC 720 once. From what I have heard, ERC 1155 could be a good try, right? I think it's worth exploring that because it gives you the ability to create like a class of assets. So it is slightly more advanced than your ERC 721. So I think you can try that out. These are the only ones that 721 and 1155 are the only ones I'm familiar with. And I think ERC 721 might not be that great for shared ownership. I think you should definitely experiment the 1155. But again, I haven't worked with shared ownership, so I wouldn't say that I'm the best person to ask this question. But I would encourage to explore this, and whatever your findings are, please share with me also, Arnima. Yeah, thanks everyone for whoever is typing that you had a good session. I hope you had fun. And I would just request, if you're able to switch on your cameras just for 1 minute. It's fine if you're in like whatever situation, whatever state, it's okay. We are all women at the end of the day. So I know that maybe some of you are just like prepping breakfast or like having breakfast or like, just getting ready for the day, etc. It's completely fine. So if you could just like switch on your camera for just like 1 minute. I wanna like see people, maybe take a picture or something. I don't know. Anju, are you able to like see the participants' view? I'm actually only seeing the panelist view.
Yes, audience, if you're comfortable with the photo session, you can raise your hand so that we can give you the privilege of a
Oh,
panelist.
I see. Okay, okay. You have
Yeah.
to. They have to come.
Yeah, they have to be made as a panelist to click the pictures
I see.
together.
Okay,
So
okay.
they can,
Yeah, that's.
yes, I request the participants who are comfortable with their video sharing, they can raise their hands.
Oh, seems like I think that might be a bit of work. That's okay, no problem, no problem. I think that's okay in that case, no problem. I'll just take a panelist picture. Wait,
Yeah, one second. We have one more panelist. I'll ask her to join as well. One second.
okay. Thank you, Bindu. Thank you, Aruna. Thank you, Sumi. Thank you, Amy. And thank you, Anna. Thanks, everyone, for joining. Thanks for your valuable comments. If you have any feedback, feel free to share with me. As you can see, I'm also learning a lot about NFTs now. I actually started this because I participated in a ETH Denver hack 2021, and we won one of the bounties. So that's how I started exploring more and more about NFTs. We are building our own NFT marketplace for charitable causes. So that's how I'm a little more involved in this space, and just trying to explore the different standards, etc. So yeah, I'm also in the learning process. Okay, I will take a picture now. Yay. Okay.
Hey.
Awesome. Thank you so much. Thanks
Okay,
everyone.
all the best, Gyan, for your Women Who Code Blockchain India and also the new initiative, the New India Guild, right? Yeah, all the
Awesome.
best. I hope you get enough volunteers soon after completing this workshop from our
Yes,
end.
I hope so too. That more and more women are interested to volunteer or learn about the space. I'm always happy to work with them in whatever capacity I can. So yeah,
Okay.
thanks everyone for joining. I know it was a bit early in the morning for you all, but thanks for making the time, and thanks Arju for inviting me.
Thank you. Thank you. It was great pleasure having you today. Thank you once again.
Thank you.
Bye. Thank you. Well, welcome back. Next, we have with us Praveen. He's a research scientist and manager of Learning and Development Wing of Kerala Blockchain Academy. Praveen has a proven track record in adapting to multiple technology domains and is an active contributor to the KBA research and development initiatives. He's currently heading the Hyperledger Fabric team of Kerala Blockchain Academy and has over 4+ years of experience in technology related field. I welcome Praveen to the two-day free blockchain bootcamp for women organized by KBA. He'll be briefing on the blockchain basics and fundamentals. So with no further ado, over to you, Praveen. Thank you for joining us.
Okay, so I think I was muted. So are you able to hear me now?
Yes, we
Yeah,
can hear
cool.
you.
Yeah, fine. So good morning all. Anju already gave you an introduction about me. My name is Praveen and I am here working as a research scientist in KBA. And today what I'm going to do is I will try to help you understand some of the basic fundamentals uh, in blockchain technology. So in the previous session, I think I was also attending that one which Gyan taken. So that was a very good topic that you should explore regarding NFTs and all. But what I have seen is like most of the people are still not clear about some of the basic fundamentals that they should know about blockchain technology. Okay, so once you have this base clear, then you will be able to appreciate much research work that is going on in this paradigm, in this blockchain paradigm. So you will be able to understand some of the fundamental issues that still these blockchain technologies have, such as scalability issues, high transaction fees, not able to get into mainstream adoption. So all these fundamental aspects, all these aspects you will be able to understand once you uh, know some of the basics, and then you build on top of that. Okay, so today I will try to make it as simple as possible. So if you have any questions, just shoot it in the chat box so that I can help you out, right? So I'll share my screen first. Please let me know if you can see my screen. All right. So are you able to see my screen?
Yes, it's visible, Praveen. Go ahead.
Okay.
Thank you.
Yeah. Okay, so basically, when you hear this term blockchain first, these are some of the terms that you will hear most of the time. So maybe you will hear the term it's a peer-to-peer database or a decentralized database. Then you will hear this term distributed ledger, uh, sometimes chain of blocks, maybe this buzzword cryptocurrency. So blockchain is everything about cryptocurrency, uh, and some people might have already heard about dApps as well, right? So maybe all of these are some kind of applications of blockchain technology, maybe like cryptocurrencies or building a dApps. Those are somewhat some applications that you can build using the blockchain technology. But the other fundamental things like the decentralization aspect, the shared ledger aspect, and basically the chain of blocks. So you should first understand how these things fit together. I mean, how this chain of blocks is formed, how it is decentralized, why it is so secure. So these kind of fundamental ideas you have to make it clear. And once you have that basic notion, then you will be able to understand why building a cryptocurrency or building a token or like NFTs that you have seen in the previous session is much more secure when you use the blockchain technology. Okay, so we will try to understand some of the timeline in this field as well, like what are the the blockchain one solutions. So we have multiple versions, you can say, like maybe you might have heard about Bitcoin, you might have heard about Ethereum, and there are some third generation blockchains as well. So we will come to that at the end of this session, but let's try to stick on with the basic things uh, at this point. Okay, so basically, the fundamental problem is you know how a centralized system works. That is how we are used to and what we have seen so far. So most of the things that we have that we are interacting day to day and we are seeing day to day are some sort of centralized aspect, right? So every application that you use, everything that you interact with in your day-to-day life, say for example with a bank, or even if you can see the screen, like you can see a classroom where there is going to be a class teacher who is actually controlling the entire students in that class, right? So what we are used to is this kind of aspect, and we think like centralization is somewhat much more organized and give us a much better uh, opportunities for everyone. But that may not be the case, right? So if you think about a bit back about what happened in the 2008 financial crisis, you know how it happened and what was the role of banks in such a crisis, right? So centralization at some point it might be cool, but there are some limitations, and there are some drawbacks with such a system when someone is having too much power in such a system, like in a centralized system. So how can we actually decentralize uh, a system? So that was the fundamental notion behind the first cryptocurrency, that was the Bitcoin, right? So most of the times when you hear this term blockchain technology, everyone relates that with the term Bitcoin. So basically Bitcoin actually kind of a protocol, and with a capital B, and Bitcoin with a small b is actually the cryptocurrency that is being used in that network. And the fundamental notion there is uh, the proposer, who is Satoshi Nakamoto, actually wanted to have a ecosystem or a network where people can transact with each other without the help of a centralized authority, right? So that is the main focus, and that is the main notion of such an idea. You have to decentralize something that was centralized, right? So you want to make people to do transaction among themselves without the help of any third party service provider, say for example banks. Okay, so how is that even possible? So that is what we are going to see today, like what are the fundamental things that he has proposed in his paper, so that make up this technology. Okay, so the basic thing is, in the Bitcoin white paper, if you some of even if some of you might have read about it, you notice that nowhere in that paper he or that group has termed a term blockchain over there, right? So fundamentally they have just mentioned it like it's a chain of blocks. Okay, so now the people once started using it, and was trying to find out a cool name to collectively call it. They have used this term blockchain, and I think that is cool. I mean, it actually serves the purpose, and we were able to understand what exactly blockchain means. Nothing but a chain of blocks, right? Okay, so what would be the very simple analogy that you can take to think about a blockchain technology? Okay, so just think about a book that you have, right? So in this book, you know that each of these pages that has been written in this book is correctly ordered, and if one of these page is being ordered in a different way, I mean is mismatched, then what would happen is the whole flow of this book will lose, right? So you won't be able to get the information correctly out of that book. So it has to be sure that you have that piece of book with all the pages in the correct order, right? So in a similar way you can think about in a Bitcoin blockchain. Okay, so I'm using this term Bitcoin blockchain right now, but you can think of it in a generalized term as well, right? So what happens over there is uh, you have a chain of blocks that are properly ordered, and this chain of blocks are distributed to each and every participants. So these participants, you can call them as nodes in this network. So these participants will be having this chain of blocks among themselves. Okay, so what is the advantage of having that copy shared among with all the participants? What would be the fundamental idea for that? It is actually helping you to uh, say for example, assume that the book that you have right now with you, and you are a part of a classroom where all the children, all the students in that classroom having the same copy of the book. Okay, and what you would be able to do is, in your copy of the book, and you will try to tear a page, and then you will say to the whole class that there isn't a page like that in our book. So that is the statement that a student is going to make. But what would others will do is, they can actually challenge his statement, right? So they can actually uh, use their copy of the book and show that this is in the this is in the correct statement. We have actually that part as well. I mean, those, maybe you can think of them as those transactions as well. And the claim that you have put forward is wrong, and we won't accept that. Okay, so collectively, these people are actually coming into a common decision, and they were able to challenge a wrong statement as well. Okay, so think of a different scenario as well. So what would happen, assume that you have 60 students in that class. Okay, and majority of that students, say for example, at least 31 of those students would come up and say that there isn't a page number 4 in the book. Okay, so if that is the case, then the majority should actually win, right? I mean, the rest 29, even if they say that uh, that is incorrect, we have a different copy of the book and which actually has the page number 4, what you 31 people are saying wrong, that wouldn't be so when you think about that scenario, what would happen is, this is fundamentally known as a 51 percentage attack uh, in a blockchain network. Okay, so you can just I mean, google it this term after some time, like most of these uh, say for example, ethereum classic was prone to this attack last year, I think. And there were other blockchain technology networks as well, where they have prone to this kind of 51 percentage attack. So the thing over here is, uh, even though you have shared this digital copy with everyone in this network, if 51 percentage of the uh, people or the nodes will, if they try to collude, then what would happen is uh, they will overpower the network, and the trustlessness of the system is lost. Okay, so this is one of the fundamental idea that you should have, and you don't have to worry about in case of bitcoin or ethereum blockchain, because right now the scale of this network is too large that even supercomputers won't be able to take down this network with their computational resources. Okay, so but there could be a scenario like there won't be enough nodes present in a blockchain network. That was the case that has happened with ethereum classic before. And what happened at that time was, there was a 51 percentage attack that resulted in uh, tampering the block data, and that actually led to losing the confidence on that blockchain. Okay, but still uh, they have gained regained the power back from such an attack on ethereum classic, but that is fine. I mean, you should be aware about these kind of scenarios that could happen in a blockchain network. So I hope that you understood this basic analogy about this blockchain uh, with a book, right? Okay, so what are the main features that you are able to get from a blockchain network? So first thing is, it is a immutable and tamper-proof data store. So what do you mean by an immutable data store? So once you have written something onto a blockchain ledger, then no one will be able to actually come and tamper the network, tamper that data at a later point of time. Okay, so that is the fundamental idea. You can actually write it, but you won't be able to edit it at a later point of time. Say for example, I can do a transaction in bitcoin network today, and at a later point of time I can't go and say that I haven't done such a transaction in the network. So the network should rewrite that transaction. I can't actually comment that, because it is a decentralized network and no one is actually going to believe me, because there is some concept of public key, private key, digital signing and all that will come to it later. But understand this, this is going to be a write-only ledger. And I mean, you can write once and read as many as times that you want. Okay, so this is going to be a sequential chain with a cryptographic hashing. So how these chain of blocks are formed? Okay, so that should be something that you have to learn by some kind of demo. So I would suggest one site that you can explore. uh, Give me a second. Okay, so I will put this link into the chat window. So here is a place where you can try some of these basic ideas over here. So uh, first you can learn about hashing. So what exactly does hashing means? Say for example, you can give any input to the hash function and it will produce a unique output for for the data that you provide, right? So similarly you can learn how a block is being created. So this is a very basic scenario. Don't think that this is how it is being done in every blockchain network. So this is something basic that they have created it for you. uh, yeah, so what would happen is, let me give some data into this block and let's do the mining part. So what is mining and all, I will come to that in a later session, later part. But understand that there is going to be a a set of blocks which are linked to each other by way of hashes. So if you look at here, this hash that is being that is the hash of the first block is used as the previous hash of the block number 2. Okay, so again what happens in block number 2 is it will take the input as the nonce, the data value, and this previous hash as well. So the hashing function will take all these inputs and create a new hash value. Okay, so this is going to be the hash of the block number 2. And what would happen here is, now you have made a linkage between these two blocks, right? Similarly, the other blocks you can create in this chain by uh, continuing the same process, right? So the fundamental thing is you are preparing a chain of blocks by using cryptography. Okay, so hashes is one of the important concept that you should learn, that you should understand when you try to learn the blockchain technology. So why this is important? Because even if I do a tampering right now in this block number 3, say for example I am adding a new data that Praveen transferring Anju some 50 bitcoins. So now this is some tampering that I'm doing in the ledger, and what would happen here is this actually would change the hash value, because you know that the hash function will take the nonce, the data, and the previous hash as an input, right? So once I tamper with the data, then what would happen is the hash value of that block will change, and uh, all the further blocks will get invalidated, because you are actually trying to break the linkage between these blocks. Okay, so that is how the a link is maintained between these cryptographic hashes. And you have a trust-free consensus-based transaction. So what is a transaction? That is something that you are say for example in Bitcoin network, it is some kind of financial transaction that you make, or in case of Ethereum it might be a financial transaction as well as a contract call. uh, uh, so basically it would be might be some value exchange between either, or some contract code that you make to a contract. Say for example, what you have seen in the previous session, you saw that you can create NFTs even on Ethereum blockchain using the standards that they have provided. And in order to interact with these smart contracts that you have deployed in such a chain, then you can do that by, you can trigger that by way of transactions. Okay, so let me present it again. Okay, so let's try to understand the story behind these currencies. You know about, I mean, you might have already know about this uh, timeline about what happened in the history, right? So initially we had the barter system, then we have used shells in order to transact between people. Then we have used the metal coins, and then we reached to use gold and other valuable rare piece of materials to in exchange of goods. And finally we have banks. So this isn't a very fully exhaustive timeline, but just to give you an idea about how the things has evolved in the past. So once you had the banks, you have understood some of the real power that these centralized entities have, and that's why uh, Satoshi Nakamoto came up with a decentralized way of transacting between uh, the network. I think I got some questions. Okay. Okay, so I have already explained about this. So Bitcoin was the first blockchain network, but nowhere in the Bitcoin paper they have mentioned it as a technology called blockchain, but it was just a chain of blocks that is fundamentally used to transact between different parties, right, without the help of a centralized entity. So that is the basic idea. So whenever you get time, just go and read the Bitcoin white paper and get a feel about what was the notion about this Bitcoin protocol that Satoshi Nakamoto had, right? So you can take some time and go through the white paper and read about it. Okay, so even if you read that white paper, at the end of that paper, you will find a lot of references to some previous cryptography works that have done by people all around the world. So he has referenced a lot of aspects related to cryptography. So you can see those references over there and understand about it, right? So this is something that has been built uh, with, with where cryptography is very extensively used, and the beauty of this is the system is still working with very large scale, and more people are coming onto this network. So the adoption is getting much more increased these days if you see around the world, right? So this is still working even right now, and there isn't any problem with there is some problems, but I will come to that in a later part. But it is still working. Okay, so how does a basic blockchain transaction work? Say, for example, in case of a Bitcoin blockchain, uh, say, for example, if Praveen wants to send Anshu some Bitcoins, what I could do is I could use a wallet, or so basically the wallet is the end user client that will be used to initiate a transaction to the network. So you'll be saying that Praveen is sending to Anju some 50 bitcoins, but don't assume that there is something called Praveen and Anju in a Bitcoin network, right? So it is actually uh, we all the entities are represented with some kind of addresses. Okay, so again, how does a Bitcoin address look like? What is the idea behind a Bitcoin address? So these things you should understand, and to understand it, you should learn about the public key cryptography. Okay, so the fundamental idea about what is a public key, what is a private key, what is the relationship between this public key and private key, and how you can use a private key to make a digital signature, so that you can actually prove that you are the owner of that particular account. Okay, so basically I'll be having a public address, and my wallet will be controlling all those things, and I'll be using my private key to sign a transaction to the network, so that anyone in the network can actually verify that it is me who is actually owning that account, because I made a digital signature on that transaction. So those who doesn't know about these things, you can learn it about it at a later point of time about these digital signatures and all. uh, but just to get a feel about how these things are generated, how it is so secure, I will give you a site where you can go and try some uh, Bitcoin address generator. Okay, so if you look at here, this is some site that actually generate you a public-private key pair and a Bitcoin address as well. Okay, so what it asks for me to do is they are asking me to give a source of randomness. Okay, So this public key private key pair should be created in such a highly random fashion so that no one else will be able to recreate it, right? So if someone else will be able to do that, then what would happen is they will get hold of your keys. So that shouldn't happen. So how will you provide this source of randomness? One example is they are asking me to hover my mouse here and there, right? So what actually they are doing is they are taking the pixel values of my mouse movement and they are trying to create a randomness out of it and creating a public key private key pair out of it, right? So they have generated a Bitcoin address for me. This is my private key and I can use this to sign transactions to spend Bitcoins present in this account. Okay, so that is how you you will try, you can learn about these things. So I will just, you can use, you can go here and try this out and it would be helpful for you to do all these sample things, right? Okay, so once I make that transaction, what would happen is the transaction will be broadcasted to the network. So uh, every nodes who are a part of this network will receive this transaction, and some of these nodes are called minor nodes who can actually make a block out of these transactions. So it isn't just me who is making a transaction, but someone else in the world is also making some transaction at the same point of time, right? So these transactions can be collected together and a miner can actually, so miner is the person who actually adds new block to the chain. Okay, so there won't be uh, so initially what happened was during the 2009-10 times, you can actually uh, uh, use a single laptop to do mining and all. But now what happened was it isn't possible to mine with a laptop or anything because you should have some enough computational resource to do the mining. Okay, so once a miner mines this block and add it to the network, so all the other nodes will validate whether what the miner is saying correct or not, and they will be able to uh, yeah, so they will be able to understand about it. I mean, they can verify whether the miner is saying correct or not by validating the blocks, and then that block will get added to the chain. Okay, so I'm explaining this very simply, but I'm not introducing all the nitty gritty technical details at this point of time. That you can do at a later point once you start exploring this. Okay, so I don't want to make it too technical so that no one will be able to understand it, but just trying to give you a very fundamental idea about how a transaction is created, how it is signed, so that I can prove the ownership, how the network will, the transaction will be propagated to the network. The miners can actually take these transactions and create a block. So there isn't just a single miner that is present in the network. If there is only a single miner, that would lead to a centralization, correct? So there will be a lot of miners who actually want to create a block. Why they are so competing, why they are competing to create a block? Because if they are able to successfully mine a block, the Bitcoin protocol will reward them with bitcoins. So right now I think for mining a block, a miner will get at least 12.5 bitcoins per block. Okay, so this is the mining part is not that very easy. The Bitcoin network has taken enough measures to make sure that the mining difficulty will increase when more computation or when more miners are being becoming a part of this network. Okay, so that is the fundamental idea related to the proof of work consensus. Okay, so you should understand what is proof of work, why this proof of work is making the mining so difficult, that the miners has to spend a lot of energy to do a mining in the Bitcoin network. So if you simply look onto some mining farms all around the world, you can see the scale of the infrastructure that they have. Okay, so I think I have explained all these things, how it works, how the transaction is created, how the miners are mining the block and all. Yeah, so like I said, you should actually read about the Bitcoin white paper, where actually it try to explain about how to create a trustless system, how to solve the double spending problem. So you should also understand about what is a double spending. So say for example, like I said, I sent Anju some 50 bitcoins, right? But uh, at a later point of time, I also shouldn't be able to spend that same bitcoins again, right? So maybe my initial balance was say 52 bitcoins, and I spent some 50 bitcoins, and I gave it to Anju, right? Then my balance should be 2 bitcoins, and I shouldn't be able to again spend that uh, the 50 bitcoins that I had already transacted, right? So this is one of the very basic problem that Bitcoin is trying to solve. That is the double spending problem. Okay, so how Bitcoin is solving this problem? It is by with the help of the proof of work consensus algorithm that is present in this network. Okay, so how it is happen right now? I mean, in the current system, it is the banks who is actually doing all this kind of settlements and clearance process for you, right? So they actually make sure that there is no double spending happening in the system. But when a system which is decentralized and there is no one who is actually controlling that system, then there should be some mechanism, and that mechanism in Bitcoin network is the proof of work consensus protocol that makes sure that no double spending happens within the network. So if I try to go into proof of work deep right now, it would be too overwhelming and too technical, and I don't think like we have enough time for that. uh, Okay, so again, the technical aspects that I was explaining before, which was the digital signatures and all. So you should try to understand the concept of wallet, how a wallet is used to generate new address and keep your private key secret. So as a Bitcoin user, you should actually keep your private key so secret that it shouldn't be shared with anyone. What would happen is, if you have lost your private key, then someone will else will be able to spend the money or the bitcoins that is present in your account, right? In a centralized system like in the banking system that you have right now, you have an appellate authority, like you can go to bank and say that I have lost my ATM, my pin ID, and you should help me, right? But that isn't the way how it works in this technology paradigm. Like, you are the person who is responsible for your uh, cash and like your bitcoins, and you should be responsible with your private key. If you lose it, then it's all gone. Okay, but I mean, there are some other tweaks that can be done in order to keep this private key secure. Say for example, you can use a hardware wallet, or maybe you can uh, use a multi-sig account. Again, that is too technical, but understand that this is a basic problem, but the community is already trying to address this by giving different solutions, so that uh, people can somewhat able to retrieve their private keys uh, in different manner, right? So what is this consensus? So the fundamental thing is, in a decentralized network, you'll be having a lot of nodes, and like I said, some of these nodes might be minor nodes, some of the nodes might be the normal nodes, and some might be some light client nodes who doesn't want to actually download all the data in the blockchain. But there are different nodes, and you should come up with a mechanism to make them agree to a single state of the blockchain. Okay, so you have to come up with a singleton state for the technology for this blockchain network, so that all of the nodes accept that state. Okay, so if some people says that they only accept one a different state, and they won't accept a state that other group is accepting, then what would happen is that is actually a problem, and it will not make you move forward, right? So how is this issue is addressed in a Bitcoin network? It is by with the help of the proof of work protocol that actually helps you uh, building a consensus within that network. Okay, so this proof of work protocol, again, you can see it in the Ethereum network. But one fundamental flaw about this protocol is it takes a lot of energy to come up for mining a new block and to perform the consensus and all. So you have other consensus protocols as well. Say for example, you have proof of stake that is coming to Ethereum at maybe next year. uh, there are other protocols as well, like proof of authority, delegated proof of stake, raft protocol, and also these are some of the consensus strategies that this blockchain network can adopt. But proof of work was the initial one that has been used in Bitcoin network. So how blocks get added to the blockchain, I have already explained about it, like how it is being created by a miner, how then other nodes verify it, and uh, how it is being propagated to all the other persons, all the other nodes in the network. So basically, this proof of work algorithm, right now it requires a lot of computational effort to execute this algorithm to come up with a block. Okay, so initially you could actually use some basic laptops or some basic machines to mine a new block in the Bitcoin blockchain. But now the difficulty of mining a block has increased so largely that you have some enormous infrastructure. Like you can simply Google and see some of the Bitcoin mining farms that is present all around the world, and you can see the scale and length of these resources, so that they are actually trying to compete with other miners to build a new block in that network, right? Yeah, so what happens in mining is all the miners are competing to solve a mathematical puzzle. So there is a question that all of them are trying to address. So they are trying to find a value. So that value is known as the nonce value. So if you look at uh, I mean, in the old example that I have shown you, which actually explained about the block creation and all, you might have seen a term called nonce value. So that nonce is used to that nonce is something that every miner is trying to find out, and that is actually a puzzle. So why or how a miner is trying to find out that nonce, that involves a bit of technical part that you can look into it at a later time. But understand this, every miner is trying to solve a very basic mathematical puzzle, not a very basic mathematical puzzle, but a very computationally uh, that actually requires a very high computational power to come up with a solution for that mathematical puzzle. So that is why this kind of enormous infrastructure is being used by the miners all around the world. Okay, so once you solve that puzzle, then you will be getting rewarded with uh, block rewards for mining that, along with the transaction fees that uh, you give into the uh, that you give to the miners for mining your uh, block. So these are some other terms that you will hear on the blockchain paradigm. Sometimes you will hear this term as distributed ledger technologies. So basically, it is nothing but a shared ledger between different entities in a network that are accepting a state by way of consensus. Okay, so how this consensus is used, like I said, in Bitcoin network it is the proof of work, but in different other networks you'll be seeing other kind of consensus protocol as well. Okay, so this consensus is also a limiting factor for the scalability of this network. Okay, so in Bitcoin network it is only 15 transactions per second that the network can process. So the proof of work has a wide the proof of work is one of the reason for this kind of low scalability in a Bitcoin network, but it actually ensures some other aspects as well, like you will be getting the decentralization as well as the security aspect, but the scalability is reduced. Okay, so this is a kind of a blockchain trilemma. Like you can have decentralization, security, and scalability. Uh, uh, that is what you are aspiring for, but you can't have all these three at any single point of time. You can have at least two of these three. Maybe you can have decentralization and security uh, uh, like without having much scalability, or maybe you can have this security and scalability, but that would lead to more centralization. So that is what happened in some of the blockchain network out there, like EOS and all, where there are some 21 block producers who are responsible for creating new blocks in the network. Okay, so this is some blockchain trilemma that you should understand. And DAOs, ICOs, and all these are some buzzwords related to Ethereum blockchain network. So I don't think like I have time to explain all about it right now, but just keep these terms in your mind and try to explore it at a later point of time. So you have multiple variants in blockchain technology. You have a permission one and a permissionless one. So permissionless is something that doesn't have it is actually a public blockchain network, right? So Bitcoin, Ethereum, all are public blockchain network. So permission is actually used by some enterprises to explore the features of the blockchain technology, but they don't want to actually make it available to the whole public. So that is why Hyperledger has come up with an initiative under the Linux Foundation uh, to come up with creating some enterprise grade blockchain. So you might have heard about Hyperledger Fabric, Hyperledger Sawtooth, and all, right? So blockchain version one is the Bitcoin, and the two is the programmable blockchain where you can actually create smart contracts. So in the previous session, you have heard about the NFT tokens and all. So similar way, you can create contracts in the network. So that is how it is done in Ethereum blockchain. You can do the financial value transfer with Ether, as well as you can create programs in Ethereum network as well. Okay, so Bitcoin network, you can only do financial transactions. You don't have any Turing complete programming language that available over there to do some kind of coding. But in case of Ethereum, you have a coding standard called Solidity, a coding programming language, which you can use to create smart contracts, and you can interact with that smart contract in the network. So one fundamental idea is these smart contracts are so secure that no one can able to actually tamper this contract at a later point of time, right? So you have to abide by the rules of whatever things that you have written initially, right? But there are some ways in which you can update you can extend your the logic of your smart contract and all that you can learn at a later point of time. But understand this, Ethereum is something that actually helps you to build dapps, decentralized applications in the blockchain ecosystem. So future is to get into the more mainstream adoption on blockchain paradigm. You should have uh, you shouldn't have just Ethereum, but the fundamental problem all these blockchain solutions that have is these aren't that much scalable. But when you want to make these kind of systems much more widespread, you should address that problem without losing the decentralization and the security aspect. So there are some research work that is happening on that front, like how you can scale the Ethereum network, or how we can come up with a new set of ideas, maybe new set of network uh, with some different way of doing things, right? Okay, so how disruptive is blockchain? You have already understood about it. You have understood that it is something that is not controlled by a single entity. There isn't going to be a single point of failure. Even if one node fails in a Bitcoin network, then that doesn't lead to a failure of the entire system. The system will still work, and you won't be able to corrupt the data. And the data that is available in a blockchain network is transparent. Anyone can go and actually see those data, right? uh, so that is something that is still being addressed. Like, no one actually want to make their data public to everyone, so they want some privacy as well. So zero knowledge proofs, Zcash is one such cryptocurrency that you can use to do private transactions in a blockchain network. So there are a lot of things that is happening in this field where they are trying to address some fundamental issues, like they want to have some privacy within the data that they sell. And how these things are addressed, uh, it will open up a very wide range of wide ecosystem of new research works to you. So there won't be any intermediaries or trusted third parties. So you don't have to believe on someone. So you can't that isn't what you want to have in a decentralized system. You don't have to trust any third parties in order to uh, believe in the dapps or the smart contracts that is present in a network. So that is another important aspect of blockchain technology. Yeah, so that's it. I mean, if I would have more time, then I could have shown you some examples as well, like how it start from a basic block to building a chain of blocks, then distributing that chain of blocks to a decentralized set of nodes, how the mining happens. But maybe in a future session I might be able to do that. But for now, I think this is fine. So I would like to see like if you have any questions so that I can answer.
Thanks, Praveen, for the lighter walk on blockchain. I'm sure the newbies here would have like definitely rewarded from your talk. Participants, if you have any questions, please drop in the chat box. I think we don't have any questions. Shall we wrap then? Yeah,
Yeah,
Praveen?
yeah, sure.
Okay, thank you. Thank you for joining.
Yeah, thank you.
Hello and hi everyone, welcome back. Next, we have with us a highly dynamic, skilled banking and financial consulting professional, Ms. Loretta Joseph. Ms. Joseph has over 25 years of experience in the global financial services industry and is a blockchain and technology advisor to the companies, organizations, and governments. She has held many senior positions at the investment banks across Asia and India, where she was responsible for managing multiple asset classes and emerging market environments. This includes RBS Macron Group, Deutsche Bank, Credit Suisse, and Elara Capital. Ms. Joseph has advised many international banks and global hedge in the areas of portfolio management and exposure to derivatives and related products in the emerging markets. She has also served as a chair of the advisory board of Australian Digital Currency and Commerce Association, which is an advocacy group dedicated to ensuring the responsible adoption of blockchain regulation. She is also sitting on the advisory boards of UWS Business School and Bloom Ventures, which is India's one of the leading tech venture capitals. She's received FinTech Australia's FinTech Leader of 2017, Female Leader in 2016 awards, and Alumni Award for Social Impact in 2016 from Sancta Sophia College. It's a great honor to have Ms. Laura today on the free blockchain bootcamp for women in connection to the International Women's Day. We're very delighted to have you on board today, ma'am. On behalf of KBA and KBA Women Connect, I welcome you to the Studio Free Blockchain Bootcamp for Women. Over to you. Thank you.
Thank you, Andrew. Good morning, everybody. Happy International Women's Day. Wow, that CV sounds much more impressive than I think it actually is. But anyway, so I hope you've all had a nice International Women's Day. Namaste. I lived in India for a number of years, maybe close to 10 years, in Mumbai. So I've been to Kerala many times. I love Kerala. So I've got a good understanding of India. I wish everybody well with blockchain. I've just sent a proposed legislation on cryptocurrencies to the Prime Minister, Mr. Modi. So let's all pray that he takes that on board and we don't have a situation where India bans crypto, because I don't think that's good. So yes, so I've had a very long career. I started as a trader in 1991, futures trader in Australia. I've traded every asset class I think that there is to trade. I've been in financial markets for over 30 years. So I was a banker. I ran a bank in India. I was the managing director of Royal Bank of Scotland. I was a very early innovator in fintech in Australia. I was a very early adopter of blockchain in Australia as well. I built a clearing and settlement system for a securities exchange in 2015. I bought my first Bitcoin at $40 way back in the day when nobody thought that it was anything and nobody believed me. So I'm pretty happy about that. And I've been an advocate, I guess, for ensuring that we see around the world responsible adoption of Bitcoin and cryptocurrencies and digital assets, which are the larger asset class. So that's my background. I guess we can all, I don't know how many of you actually are familiar with blockchain or the applications of it. So I'm going to go back to the first application, which we saw in 2008. I was actually in India. So the global financial crisis hit. It was detrimental to the entire financial system of the world. We all lost faith in our governments, in our banks. Nobody trusted anybody. At that same time, a group of people called Satoshi Nakamoto put out on the internet an open paper for everybody to read, and it was called the Bitcoin PDF. So in that PDF, what was explained was a peer-to-peer cashless electronic cashless system, effectively, and it was decentralized. So that was the first time that we'd heard about the underlying technology blockchain being talked about, and this was the first application. So not that long ago, you probably all heard of Bitcoin and seen the unbelievable volatility and riskiness of the asset. So it's a new asset class. The blockchain technology is just what is the application is Bitcoin, but the technology underlying it is blockchain. So what is blockchain? So blockchain technology is nothing more than a fancy word for a database. Now, you all use databases every day of your life. The difference between the database that you use and the blockchain in the Bitcoin database is that it's distributed. So at the moment, we all use databases which have a central point of control. That's vulnerable. Every database in history has been hacked. government databases, corporate databases. It's getting worse and worse because they're honeypots for people to come and hack. People get information on people all the time. The Bitcoin blockchain was the first ever decentralized database that we saw. So what does that mean? It's a way for untrusted parties to reach an agreement on a common digital history. So I'm going to break this down in a bit. So a common digital history is important because it shows us digital assets and transactions can be hacked, they can be copied as we know them today on the internet. People pirate movies and videos all the time. But blockchain technology actually solves this problem. And what we say is that it's an immutable, transparent, secure database. It's not owned by anybody. It's every computer in the world that's connected to the Bitcoin protocol, to the Bitcoin network, have to vote to change that database. So no longer is one central party in control of the database. Nobody can change the rules just because they want to. It's what we call the consensus mechanism. So that means that when you opt into the Bitcoin database, so Bitcoin itself, the blockchain behind Bitcoin is what we call a public database, a public blockchain. Everybody can use it. We'll go on to other models in a bit, which we call DLT models, which are private blockchains. They're all a bit different. But the Bitcoin blockchain is certainly the biggest, and it's the only one that has never been hacked. So that's very important because it's, as I said, you've got people that are using the Bitcoin network all over the world. You have to reach 80% consensus. So all of us, everyone's watching me, I think we've got, how many people? 78 participants. So all of us 78 participants, if we opt in to being part of the Bitcoin network, we have to agree to abide by the rules. So we have to agree to what they call the governance models. 80% of us would have to agree to change a rule or change the protocol. So that really can't happen unless you get consensus. So it's a secure, immutable, transparent database, which means everybody can see it, nobody can change it, nobody can fake it, and it has to have the entire network has to be validated by everybody using the network. So that's what we call the consensus mechanism. So why is it called blockchain? It's called blockchain because it's basically a series of blocks which are connected by a chain. So we'll go back to the beginning. In a public blockchain, as I said, like Bitcoin, the first block is just a whole bunch of information. So maybe your date of birth, your address, whatever. You have this block of data. Now that can never be changed. And if you're all interested, go on to the Bitcoin PDF. You can actually see the Genesis block, which we call it in Bitcoin, is the first ever block of information that made the Bitcoin blockchain. So under that block, you have headers. Every time people put more information into that block, it goes into a new block. So nobody can change the information. It's time-stamped, it's recorded, it's immutable, and it's secure. So each block then subsequently more information is added, and all those blocks are joined together, hence creating what we call the blockchain. So it's effectively, as I said, just a bunch of information that's time-stamped. When that information was put on the blockchain, it's recorded. A transaction is done in that block, then other transactions come along and they're added onto the block. So yeah, as I said, you can see the first ever Bitcoin transaction, which we call the Genesis block. So I say that Bitcoin is probably the best use case of blockchain as we see it today because it's the only one that works. And effectively what it is the digitalization of money. So this is exciting to me because, as I said, I've traded many asset classes. So imagine if we can now digitalize money. Now, money means something to everybody differently. Money can be a store of value. Money can be a way of paying for things. Fiat currency, as you see today, the Indian rupee, that's what we call fiat currency. So the legal tender of a country is that piece of paper. I've written a lot of legislation around the world where I've said Bitcoin is not currency. And I think the Bitcoin community was a bit silly when they came in and they called it Bitcoin, because the minute you put coin into a sentence or currency, everyone goes, oh, that's going to upset the central bank, that's going to upset people. So I looked at what Bitcoin was back in 2015, and I had to, because at the time people were referring to digital assets, they were referring to crypto assets, they were referring to virtual assets. Everyone was referring to something that was inherently the same, but everybody had a different definition. So as I said, Bitcoin was the first application of blockchain. What it was the digitalization of money. Now, that doesn't mean currency. Money comes out of barter. Thousands of years ago, we used to barter corn for potatoes, and then that got too difficult, and then people moved into bartering shells and rocks, and then they moved on to little coins, and then, you know, time goes on, and now we have pieces of paper with people's heads stamped on them. That's called fiat currency. So that is a very different model to what barter was. So I've written law that says Bitcoin is the commodity. It has characteristics that are akin to a commodity like a grain or gold. I effectively call it digital gold because it's a store of value. If you want to use Bitcoin to pay for things, that's a very inefficient and very silly thing to do. But so there was, as I said, Bitcoin was the first application of the blockchain technology. Since then, we've seen new protocols come along like Ethereum in 2012, which I'll get into in a bit. But you just think about now, if we can digitalize money on an immutable, transparent database, imagine what we can do with other assets. And the problem for me as being a trader all my life is that, when we're trading assets, the clearing and settlement time to do that is very, very different. But databases get hacked all the time. So there's a whole range outside financial markets for blockchain, things like registry functions. So now we could digitalize land titles. We can digitalize government records, anything that has a digital a registry function. We can digitalize equities, securities. I've written the first regulation in the world around security tokens in Mauritius, if you'd like to go and read it. I've also written the first regulation around custody of a digital asset because nobody thought of that. I also do a lot of work now with central banks around the world on a central bank digital currency. I'll get into the details of that at the moment, but that one still worries me. So when do you need a blockchain? And I'm going to say this to you all once and once only, because you only need a blockchain when you have competitors that have to be collaborators in a network that don't trust each other. So it's the trustlessness of the blockchain which we find most fascinating. If you're transacting with one party and say I'm transacting with Anju, I trust her. So I don't need a blockchain. Am I transacting with Anju and maybe 5 of you that are watching my panel? I don't know the other 5 of you, so probably not. So it is only needed when you have collaborators and competitors that need to share information in a network that don't trust each other. So that is what the blockchain use case is. If you are just trading with one other party and you trust them, you don't need a blockchain. A lot of people and countries say to me, "Oh, Loretta, we need a blockchain." And I say, "Why?" And they go, "Don't know. It's decentralized." And I said, "Listen, what you may need is just a better encrypted database. Databases work very well, but just that they get hacked." So as I said, so that's when you need a blockchain. So you've all probably heard of Bitcoin. You've all probably heard of a token. They're terms that can be very confusing, I guess. A coin, Bitcoin is a coin, and there are many altcoins. So there are other cryptocurrencies that have come along after Bitcoin. They use the protocol of Bitcoin because everybody can go in and see, because it's open source, so we can all see how the Bitcoin protocol works. Other alternative coins have adapted the Bitcoin protocol, done what we call forking. So they've taken some aspects of the protocol and gone and created other coins. Some other alternative coins like Ethereum actually work on their own blockchain. So Ripple, Ethereum are blockchains which are not based on the underlying protocol of Bitcoin. A token's an interesting one because it's a representation, I think, of an asset. So an asset or a utility. So I think it usually resides on top of the blockchain. As I said to you, a blockchain like Ethereum. These tokens can represent basically any asset class, and that's why I get excited about these. They're fungible and they're traded. So now I said we can have illicit asset classes, things like gold. I mean, I've always found it very interesting, especially in India, because everybody buys gold and Diwali comes along and everyone's wearing gold. But other than wearing it, what is the value of gold? Because it's scarce and it's in demand, everyone wants to buy it. But other than wearing it, it's not a very useful asset to go and liquidate. It's very hard to liquidate. So I think the way that we've tokenized money, we can now tokenize any asset class, a commodity, a security, all of those things. Loyalty points. So Emirates loyalty points are things like we can do it. So that's important. I think it's important to see what the different protocols can do. So everybody talks about Ethereum. Ethereum came along in 2012, and it was built by a guy called Vitalik Buterin, who said, well, the digitalization of money is just one use case. That's Bitcoin. What if I could create a protocol that we could digitalize everything? So it works differently. There's something called the proof of work and a proof of stake, which identifies both blockchains as being different. The Bitcoin network, it's as I said about the consensus mechanism. People, the people, all the computers around the world that are watching every Bitcoin transaction are effectively keeping the network safe and the integrity of the network. So everything has an economic and social trade-off. So in order for them to do that, they get paid in Bitcoin. So Bitcoin is mined. There's only 23 million in existence. I think we've mined 17 million now. So it's becoming finite. It's finite. It's very tight in supply, and there's only there's a limited supply of it. So it's becoming much more popular because we're getting to the end of where the mining is. I think they can still mine Bitcoin until about 2040 though. So Ethereum doesn't work on that. It has the people guarding the integrity of the protocol are paid with a license fee model. But for me, Ethereum's promised a lot. The one thing it did give, so it added on to a blockchain something called a smart contract. So the Ethereum white paper talks about a smart contract. All a smart contract is executing code. It's not smart and it's not a contract, but it allows a transaction to happen on the blockchain, say selling a house. And I bought a house today, but it was very laborious. I'm very proud that I bought a house today, but I had accountants, I had lawyers, I had banks, you name it. I had all these middlemen involved, and I think I almost paid as much money paying them as I did buying the house. So imagine now with this technology that I could buy using the blockchain, I could buy that house, buy and sell it between me directly, me buy it from the seller directly without the need of intermediation. So I don't need the accountants, I don't need the lawyers, I don't need all those people that come in the middle of transactions. So the blockchain, again, it does another important function. It takes out the need for intermediaries. So that's why a lot of people are a bit hesitant about it, like banks, accountants, lawyers, because effectively now that we have these smart contracts, which effectively say, if A happens, then B happens, the contract's executed. So it's just executing code, but it means that we can speed up the cost, speed up the pace of a transaction like a house sale into a matter of seconds, not a matter of months. It means that we can have registry functions on the blockchain that take out the need for intermediation. So lots of intermediaries in markets create a lot of friction, but they make money out of that friction. So you think about it, if you're sending money from the Bank of Baroda to Axis Bank, that's one okay transaction. But if you're sending money back from Canada into India, or from Australia into India, or wherever, there might be sometimes 3 or 4 banks that are in that process, and that can take somewhere between 1 day and 10 days. And nobody's ever been able to tell me why that happens. So it's like trading a security. I trade a security, it takes 3 days, an equity. You go into the Bombay Stock Exchange or the National Stock Exchange. I go and trade a water entitlement in Australia, and that's 27 days. Like, to me, that never made any sense. So when I looked at blockchain, I didn't look at it from the aspect of Bitcoin. I looked at the blockchain in how it could make things like clearing and settlement of different assets much faster, much cleaner, much more efficient, and disintermediate markets. So when you disintermediate markets, as I said, you upset people because you take out a lot of the friction in the systems, and people have been enjoying making money out of frictions, especially in financial markets, for 400, 500 years. So crypto itself is traded on a private exchange. It's usually quoted in a dollar, US dollar, or an INR. You can trade Bitcoin versus Ethereum. You can trade Ethereum versus Litecoin. The top 10 cryptocurrencies are probably the oldest ones, and probably the ones that will be around for a while. So why do I keep talking about cryptocurrencies? I keep talking about them because they're the only use case of blockchain at this moment. I think as the next decade we accelerate with technology, use cases will become much more clear. The problem with a lot of these protocols is they're not interoperable, so you can't move something off the Bitcoin protocol and into the Ethereum network. The throughput, some things like how do you do many transactions, like the SWIFT network that the banks use is very fast. It can transact millions of transactions in a matter of seconds. Bitcoin takes 10 minutes. It's very slow. It's very clunky. To validate a transaction, but it was designed like that because Satoshi Nakamoto didn't want Bitcoin to be a trading system, a payment system. He wanted it to be secure, because so the people that built Bitcoin built it because they don't like governments, they don't like banks, they didn't like a lot of things. So they thought, if we build something, an asset that nobody can touch, that it's secure, it's transparent, immutable, that's a really good idea. So there's things called privacy coins, which are totally anonymous. Then that started to scare a lot of people because people think that Bitcoin's anonymous. And I work with a lot of law enforcement around the world. And let me tell you, if you're a criminal and you want to you're a nefarious actor and you want to do an illegal transaction, use cash, don't use Bitcoin, because it's an immutable, transparent, secure database, we can see every single Bitcoin that has ever moved. So my argument is that cash is the best tool still for criminals. Bitcoin is the best for law enforcement. And I work with a lot of law enforcement around the world. So the problem, though, with things like crypto, and I think this is why the Indian government's got upset and the central bank, because they used the words like coin and cryptocurrency. Had they have called Bitcoin Zen token, nobody would have cared. So it's a lot about the terminology. They borrowed terminology, like cryptocurrency exchanges where you trade crypto, and not exchanges. I've worked very closely with the Bombay Stock Exchange, a lot of numbers. So they are private-public partnership. The rules around a security exchange are very, very laborious. They're very convoluted, because they're very important to a country. Now, the other thing about a security exchange is a process called novation happens. And not unless you're a trader, do you know this. So when buyers and sellers come on to say something like the Bombay Stock Exchange, for that split second that the buyer meets the seller, the exchange takes on the risk. So in these cryptocurrency exchange, they don't do that. I call them digital asset marketplaces because all they are marketplaces where they match buyers and sellers. They introduce buyers and sellers. That's very different from the process of novation on a security exchange. They're very unregulated, so it's been scaring people a lot around the world. I wrote the first legislation on digital assets in Bermuda, I think in 2017. I've written it in Mauritius. As I said, Bitcoin itself is a commodity. It's not currency. And I've also said in all my regulation, this is not legal tender, because that takes out the problems of the mandates of the central bank. It has more commodity-like features. So it's a very volatile asset class because it's immature. It's very risky. I always say to regulators, you can't stop technology. No, I actually know the man that built the internet, Robert Kahn. So he sent the first ever message across an open network, which we now know as the Transmission Control Protocol or the Internet Protocol, to a man called Vint Cerf, which said hello. So he's my mentor on understanding the technology behind blockchain and open systems. I've learned a lot about the internet, building the TCP protocol, and I'm not an electrical engineer, but I've done that. And I also have Lord Magnum Desai, he was the chair of the London School of Economics. I think he's taught 18 central bank governors. I think 7 of them sit at the moment. He's a macroeconomist. He was sitting with Mr. Nixon the day that they got rid of the gold standard in 1973. So the day that Nixon said, yes, this piece of paper used to be backed by an asset called gold, but we're not going to have that anymore. So my argument is that even paper money isn't backed by anything. Lord Desai has been paramount with me, helping the Indian government, speaking to the central bank to sort of quelch the fears that people have around cryptocurrencies and associated applications of blockchain. So everybody seems to like blockchain, but nobody likes cryptocurrencies. And I'm like, well, it's the first application and it's the only one that works. So you sort of can't have one without the other. But it scares me that it's such an unregulated market. So I've spent the last 5 years writing regulations for security regulators, for anti-money laundering, terrorism finance regulators, all the different regulators. And what we can say, as I said, you can't stop people using technology, but what I can say is buyer beware. My little 16-year-old daughter, I mean, she uses her smartphone, and I think it's a part of her left hand 24 hours a day, except when she sleeps, and then she picks it up. So the way that our kids and the millennials use technology is quite different to the generation of me. I'm 52 and above. But we have to allow policies and regulations that don't stifle innovation, but they put in protection. So I'm very big on that, because regulators are not technologists and technologists are not regulators or policymakers. So in the last number of years, my job has been to sit in the middle of both of those worlds and bring them together, because the internet taught us the walled garden approach to making regulations and policies just doesn't work. I speak to Bob, as I said, Robert Kahn, who built the internet, the father of the internet. I'm very lucky to have him as a mentor. I'm a very lucky woman. And he said to me, in the first 10 years that he created the internet, everybody says it would be only used for pornography and gambling. And then he said he got taken into the government and into private enterprise. They said, no, you have to shut this down. And he said, well, I can't shut it down because it's open source, open network. And he said the same people came to him 10 years later and said, no, we want to buy the internet. He's like, you can't buy it either. So I think blockchain is the extension of the internet. And for me, all it's done, as I said to you, Bitcoin is a secure database. From, this is my mobile, from the internet that I get off my mobile device, as you all do, from the first protocol that Bob Kahn built when he created the internet. None of us know, we just use this thing every day, but there's 39 protocols that have been built on top of the first IP, Internet Protocol, and Transmission Control Protocol. Nobody knows that, nobody really cares. And are we worrying about the infrastructure and the terminology and the regulation of the internet now? No. So what blockchain is, and I said to you with Bitcoin, it's done the one thing that they haven't been able to do in computer science. It was solve the security of the internet. So if you just look at it from a technology point of view, that's the most important thing. And Bob's told me when they built the internet, they didn't put in a security protocol layer. So all you've seen now is Bitcoin come along, and the internet was the democratization of media. Bitcoin itself, I think, is democratization of money. But Bitcoin, the application has actually just made the internet secure. And that was the one thing missing. So that's a very important point. And I think some other protocols, I think what will happen, you will get a meshing of all these protocols like Ethereum. Another really interesting one is Polkadot, Bitcoin, and the security protocols of all of these different different protocols are going to mash together to make the next journey of the internet, Internet 3.0, incredibly secure. So for me, it's also an infrastructure build that just makes the transfer of value across an open network, is what we do effectively with the internet. That's unsecure. So all we've done now is made the transfer of value secure. So that's an important point to note. I know I'm running out of time here, so I won't keep you much longer, but I wanted to sort of just go through a number of the facts. So I've written, as I said, I've written the first legislation in the world around digital assets. And what I've said is the digital asset is now a new asset class. I'm very proud to say that I've been born into the inception of a new asset class, and I can write rules and regulations and legislations. I'm not a lawyer, by the way. So I said so a digital asset is the broader bucket of these new assets we can digitalize with the blockchain. Cryptocurrencies is just a subset of that. So they're nothing more than a subset. I think the challenge that we've seen in regulations, as I said to you before, is that regulators are not technologists and technologists are not regulators. All a regulator can do is say, there is risk, but there's risk in every asset class. And I've traded every single one of them to date. I will tell you all, no one asset class goes one way forever. Nothing just goes up. There's moves and they go up and down. And that's inherent across every asset class, including cryptocurrencies. So please buyer beware. I always say to people, they ask me if they should invest in Bitcoin and cryptocurrencies. I say, you only ever invest as much as you can afford to lose. And that's a very important point. And that's all that regulators can say, because we're living in a day and age where I think the millennials have access to the internet, and information allows people to be much more have a greater ability to digest risk and understand what risk is. And I think that's very different from the days that I was a trader back in the 90s and 2000s, because we didn't have the internet per se. We didn't have mobile devices. Our life was very different. So the challenge, I said then, of regulation is that the legacy institutions, things like banks, are under threat. They don't like this new technology coming in. Consumer protection and investor protection, I said, is still very important, because that's what regulators do. And the first thing that people do is when they get scammed is go and complain to the regulator. Data privacy acts around the world are not harmonised. That's a challenge for us. The small nations, though, and I've worked in a number, Bermuda, Mauritius, Serbia, Malta, they're leading the charge in this because they don't have these huge political legacy systems. They can change laws and innovate very, very fast. So that's been interesting. The US and Europe have been very slow because in the US they have a different regulator in every state. In Europe the same. It's like every country has a different set of regulations and they're close together. So these countries and these regions that have big bowls of spaghetti as regulations, you go and tip them into the one bowl. That doesn't work. The other thing is that people always talk about cryptocurrency being risky. As I said, it's for nefarious actors and it's for money launderers and terrorists. But the blockchain itself, it's one of the best use cases I see for AML CTF, because of the strong cryptography, which is what's behind blockchain. So blockchain itself is a combination of a peer-to-peer system, the internet, and cryptography, which is encryption, which makes things secure. That's been around since World War II. So it's just a meshing of a couple of other technologies. But the cryptography sort of enables multi-stakeholders, I guess, with the use of the technology to see and understand KYC and AML better than they've ever seen before. And so there's new opportunities, I think, to revisit the whole reasons that we created AML CTF regulations. There's a body called the Financial Action Task Force, which I say is the big kahuna of regulators. They even sit above security regulators. And they put out standards for countries to follow to mitigate the risk of financial terrorism and money launderers and terrorists. So that the information that they've come out recently has been that something called the travel rule, which means that every cryptocurrency exchange has to know the beneficial owner of that cryptocurrency and the seller. Same as what we do with banks. We do that under SWIFT. So it's interesting, and I think the intent of the blockchain can curb a lot of the problems that we have with AML CTF risks as opposed to enhance it. I've done a lot of work. A few years ago, there was a hit put out on a Japanese politician in Bitcoin. Silly thing to do. So all the security agencies and all the security regulators and the money laundering regulators, we all got together. We got some of the cryptographers from the Bitcoin protocol, and we could trace this Bitcoin as it was moving across exchanges on the world. And we not only caught the criminal that put out the hit, we got his computer and the Bitcoin that he'd said that he was going to use. So law enforcement were like, wow, this is the best thing we've ever seen. So anything you hear and people say that Bitcoin's anonymous, it's not. It's pseudo-anonymous. It means that we can still track and trace it because the blockchain, again, is secure, immutable, and in a transparent database. So first movers, I guess, have been Australia, where I come from, Mauritius, Bermuda, Malta, Singapore. I know I've run out of time and I've probably gone a bit over. Everybody's starting to embrace blockchain. When I started to talk about it in 2014, no central bank wanted to listen to me, no government. They all just sort of tolerated me. But now you've got the IMF, you've got the World Bank, you've got a number of central banks saying they're going to introduce their own central bank digital currency, which is a bit dangerous in itself. I've got a whole lot of slides for this presentation, which I didn't share with the organisers, but I will. After this, and I've got a whole lot of reference documents. If you're really interested, over my career, over the last 7 years, I've collated probably the best list of reference documents, which is videos, regulation, just interesting books to read. The blockchain revolution is an interesting one, so I'll share that with everybody. I hope that was useful. And we need more women, by the way, in blockchain, because if you've only got guys coding this, it's not going to end up well. Is the internet. We need women to code. I taught myself to code when I was 43. My 9-year-old at the time learned to code. She now codes across 4 protocols. So teach your kids to code, especially the women one. So happy International Women's Day, everyone. I hope that was useful. You can send me a LinkedIn if you have any questions. I'm on LinkedIn, Loretta Joseph, and I will share, as I said, my reference documents and this presentation with the organisers. Thank you so much for having me. Anju.
Thank you. Thank you. That was a power-packed session. Thank you so much. I'm sure the audience here are enlightened from your words. It'd be great if you could share some resources to them because we have like newbies in blockchain who can be helpful with your resource.
As I said, I've got this book. The first book I read was something called The Blockchain Revolution by a man called Don Tapscott. You can get it on Amazon. I really suggest that everybody reads it because you'll understand exactly what the technology is, where it can go. And please go and read, just download it off the internet, the Bitcoin PDF. It's 8 pages, that's all it is. It's quite mathematical, but it explains in that white paper exactly what blockchain is. Thank you very much for having me. I hope I get to come back at some point. Like, I hope I get to come back in person when we get over this COVID thing.
Sure, sure. We'll be very happy to associate with you in similar events in the future, ma'am. Thank you. Thank you for joining us today. Bye. Take care.
Stay.
Next, we have with us Ginsha George, next graduate of KB, to share her blockchain story. Ginsha is currently working as a research lead engineer at Panasonic Global Info Park at Nagaland. It's great to have Ginsha with us. Hello, Ginsha. Am I audible to you?
Yes.
Yeah, Ginsha, go ahead. Yeah, thank you. Thank you for joining us today.
Greetings of International Women's Day to one and all present here. Thank you, KBA, for being with you to join this program. I can remember the time which I joined KBA for blockchain education. At that time, I joined there for after a big break in my career. So I am from a non-IT background, and that time I can even now I can remember how helpful the KBA staffs and all. Especially, I can remember that the students in my class are from different backgrounds, at different age groups. As a teacher, I can, from a teacher's point of view, it is very difficult to manage such students from different backgrounds. Even then, the staffs are very helpful and they are very much supportive. And for me, it was their interaction with the KBA, my interaction with the KBA staffs, it gave me very good confidence. So this is a very good opportunity to share my experience in my career. During my career, I have a lot of breaks. Now I am working in Panasonic. I can tell you that this is my 9th institute or a company. Because of as a woman, I have to manage my family and career, but never I stopped learning. Always I continued my learning process. So always I have a dream that I want to become a research engineer or a scientist, like that. But that time, I don't know how can I reach that point. But that decision when I took, that is in my mind, and each and every day I try to reach that goal. So when I reached KBA, before that, I completed the prerequisites for blockchain, that full stack course, the developers course from ICT Academy. After that, I joined KBA. And so during my blockchain course, I understood that there are people like me. I have so many students, my colleagues and my friends are there. So they all are want to change their career one way or another. So they are also trying to learn the new technology. No one is having an experience in the blockchain. So that was a very comfortable for me. That was very comfortable for me because if someone near to me is very brilliant and I am very, if I am not up to that point, then we feel that no, I can't study this one. So actually, this blockchain course which KBA is trying to deliver is to students of from different categories. Without the students are coming from non-IT background. So even such students can come out of their blocks or hindrance. So they can come out and they can move to the new industry. The latest technologies they can learn, and we can bridge the gap between the job market and our education system. Even very few freshers also can utilize this opportunity. And after completing my blockchain course, within 1 month, I got this job. I asked research lead engineer at Panasonic. Now I am working in multidisciplinary areas. Actually, I am from medical background. Then so everywhere I did multidisciplinary areas. And this is very much helpful for me at this position. Because as a research lead engineer means I have to interact with different teams, implementation team and algorithm team. I'm working in the algorithm team, but there will be a gap between the implementation team and algorithm team. So in that gap, that I can fill that gap because I have that base that blockchain developers are there, blockchain architect job is there, then implementation teams, many other groups are there, biomedical section is there. So each and every team, they can interact with me, they can clarify with me. So now I am feeling that this learning process, which I continued in my life, is very much useful at this point of time. I had teaching experience, but because of the breaks during my career, either I took so many breaks with from marriage onwards, I had so many breaks for delivery purpose, kids taking care of kids. Then during my spouse's transfer, all these times I took a break, and later always I tell myself that I can join a new job within 6 months. So when I resign from one job, then that time onwards, I will start learning for the next job. I will try for the next job and update my profile. But one thing which happened in my life is when in the year of 2017, when I resigned 2016 from Mumbai and shifted to Kerala. Then again, I started searching for a job. But what happened is I understood the fact that for one permanent post in an engineering college, more than 200 candidates are waiting, highly qualified, experienced candidates are waiting for that job. So that is the situation here. And then I sort of think learning. So there is two options, either go for a PhD or go for learning new technologies, cutting edge technologies. So that time I choose this blockchain technology and I came to KBA. So now, now I feel like it is very, that decision was very good. But that during that time, it was a very difficult situation which I moved, because each time I had to prepare my profile, then I have to apply for the job. I'm facing the interview board. The one thing they are asking is, they can see in my profile that there is lots of breaks. So that itself is giving them a bad impression about me, that I felt, though that is not my problem. As a woman, we have to take care of my kids. There is a woman, and actually, we women have an inner power to balance the family life and career life. But at some point of time, we will feel like we can't do that. But we have to overcome such situations. That is what I understood. And I can share with you a slide. Okay. As we know that the theme of the this year, the theme of International Women's Day is Choose to Challenge. And as we all know, we have to challenge ourselves. Each day, we should do something better than the last day. Let me tell you that as a woman, we will think that women are struggling, or women are getting tired of doing all these things. But one thing we should understand, that woman has more inner power than men. So that we should understand. Women should understand our inner power. That is what we should do. Usually we are not getting such informations or such knowledge during our lifetime. And I can, we women should do these things, focus on your passion. See, actually, we should not go, we have to do some our works at home. We should take care of our family. And at the same time, we want to take our career. Then one thing we should remember, that we should not go for a job, not for a job, but we should go to do our passion. Whatever is our passion, you do that one. Then it will be easy to do. If you are learning, most of the time, students or most of the students are having this problem. Means they will learn engineering or field, and they will go for banking. So they are doing banking work and they learn another field. So in that time, it is very difficult to focus in our job. We won't get that satisfaction. That's what I felt. That's my personal thing. Means I understood like that. If we have the passion to do something, we should do that. Then it will be easy to move. Because we cannot avoid our family or our relatives, anything. But at the same time, we need the career. So that is what I felt. Then be patient when you are on the field. Means we should be updated and we should be expert in our field. Keep working hard. Success will be definitely yours. Try to be creative and keep your image different from the rest. That we all know that early bird gets the worm. No? So what I told before, no, there is more than 200 candidates for one permanent position. So what we have to do, we have to update our profile. We have to update our profile, and we should be different from the rest. Something should be the interview board should can find something different from others, something attractive for them. And dream big and listen to yourself. So when we are in some struggles or when we are in some problem, always there some two things will happen. One thing is that our friends or relatives or many people will guide us, and they will suggest so many what they feel right. But one thing we should understand, that we should listen to ourselves. What my mind is telling, that will be my passion. Don't listen to others' passion, but listen to others and get what we need. Don't follow them. That is what I understood. Focus on your positives. Understand your weakness. The main thing we have to do this, the weakness we should understand and we should overcome it. Keep your profile updated to bridge the gap with the job market. Be passionate in learning latest cutting-edge technologies. Always do better than you are yesterday. That is what I did in my life, because when I take this decision that I want to become a research engineer, that time I am simply sitting at home. I have not touched with any of my subjects, even mathematics. I am not in touch with that. I am not reading newspaper also. So such a situation, if I am taking a decision that I want to become a research engineer, means I have to go far. I have to learn a lot that I know. That time I understood what is my weakness, where is my learned earlier everything. From that point, I started learning each and everything. Then only I reached the KBA. After learning and completing the prerequisite courses, I reached KBA. So at that point, I felt very confident that these KBA staffs are very much if we ask them directly also, they take the time to explain us. So I'm very happy and thankful to KBA. And for women, usually we will forget our health. So always stay healthy. And what I learned from my life is every exit has an entry somewhere, every end has a new beginning, and every dark cloud has a silver lining. So always we should think positive. That is very easy to say, but it is very difficult. So never leave hope. Life means possibilities. So thank you. I think this will be helpful for you.
Thank you, Ginsha. That was a beautiful word to say. I'm sure the audience here would have motivated from your talk. Thank you. Thank you for sharing your blockchain journey and your personal experience being a blockchain woman. Okay, hope we can associate in the future events too. Okay, thank you. Thank you once again for joining us live today on the 2-day free blockchain bootcamp for women. Have a good day. Bye.
Thank you.
Hello and hi everyone. Next we have with us a highly valued contributor to the blockchain space, Alex Alban. Alex is a director of marketing and sales at ChainStack's Blockchain Managed Services and the founder of the blockchain consultancy, Ashra Labs. She has previously been the CEO of the Space Chain, instrumental in creation of the first decentralized network of satellites, also the part of the team that made the installation of a Bitcoin node on the International Space Station a reality. She has been the founding member of the Ocean Protocol, a decentralized data exchange that has been advising a number of blockchain projects such as DexTF, decentralized traded funds, Mahadavo, the world's first non-depreciating currency. She has been a she has a significant experience in structuring and scaling up operations for startups and bringing up new products to the market, particularly in blockchain and data innovation projects. She has been instrumental in commercializing technologies that have attracted significant investment by major venture capital funds and corporate partners. She has held full budget responsibility for many million projects in aerospace and automobile, government and public-private partnerships, education management, and digital innovation projects. Alex has been nominated to the inaugural of IMDA's 100 SG Women in Tech, also the Oxford Said Business School and INSEAD Executive Education alumna. It's a great honor to have Ms. Alex today at the two-day workshop for women. She'll be keynoting on the much anticipated topic, DeFi, the Future of Finance. On behalf of KB and KB Women Connect, I extend my heartfelt gratitude to Alex for joining us today live. Over to you, Alex.
Hi, everyone, and thank you so much for the introduction, Andrew. It's such a pleasure to be here. I've been looking forward to this session for the entire week. I feel a little bit nervous, guys, because this is an interesting topic and we have so much to cover. I hope we will do so in a sufficient in-depth way, but if not, feel free to ask questions. If there is anything that you want to ask or anything that I'm not covering to sufficient level of details, or I'm going too fast, just stop me and ask. This is, I hope, a very interactive session as well. I will ask you questions. You can ask me questions. It's not like a front end where, just look through the mirror glass and so on. It doesn't want to be that way. If that is okay, I will try and share my screen. Let's see if everything goes all right. I hope you can share my screen now. Yeah, is everything okay?
Yes, perfect.
Awesome. That was the riskiest part, probably. So that bit we have done. So thank you, everyone, for being here today. Today, we are going to cover a lot. We're going to start and look at what is DeFi and what it is, the differences between DeFi and CeFi. CeFi is centralized finance. I thought it would be interesting also to take a look at what's been the history of DeFi and why we are where we are. Otherwise, it always feels like an incomplete story. You feel like if you're just starting up now, you haven't been part of the evolution of it up to this point. But let's bridge the gap and look at everything that happened up to today's with DeFi. We will look at what you can actually do within DeFi. There are different areas that are in common with traditional finance. And to a different level of details, we're looking at lending and borrowing today. Flash loans, I will touch just briefly on that. We'll look at stable coins, including CBDCs, decentralized exchanges, derivatives, margin trading, insurance, and then a very important bit, which is the oracles, upon which the entire DeFi is based on. And I will offer you my my thoughts about what are the barriers for the DeFi for the near future and what are the prospects and the main areas of work. Brilliant. So before we start, of course, as we touch about regulated industry, just know I am not offering financial advice. I'm not a financial advisor. I'm just a very curious person reading and learning and living in the blockchain space for quite some time. We are here to learn, so I'm going to learn from you guys. Same as you probably will take away, I hope, something useful from this session. But that is the main reason we are here. So not financial advice. As you will get inspired, I hope, and you will start to get more active if you have not done anything before, or you've just done the superficial level. Just know that before investing, you have to do a lot of research. Find a buddy. I know that works quite well. If you don't know of anyone, please reach out to me. I put my LinkedIn details everywhere. Just reach out. I will be happy to find your buddy to try and learn with you, together with you, on the DeFi space. DeFi is a high rewards but also high risk space. So be extra careful and invest only what you can afford to lose. That's very, very important. You will see the numbers are just astonishing, but it comes at a price. So be careful when you're in this space. It is also non-regulated. You will see there are drawbacks from that. And just a quick note, I'm happily Director of Marketing and Sales at ChainStack, a blockchain managed services. However, today I am just speaking as myself, and none of the things that I will say today will be like official endorsement from ChainStack or any official opinion or position about the project I will mention today. Okay. Let's get started. But before we do, can I just ask for a raise of hands? I know you can Zoom. We can bypass being in the same room. We're having some tricks. But raise of hand, how many of you have actually opened or have ever opened or are keeping a MetaMask account? Like, do you have a MetaMask account? Have you done any DeFi or any investment? If you haven't, brilliant. Today we're going to cover all the basics. If you have, brilliant, contribute and add if I have any gaps, just out of curiosity. Maybe Andrew, Kartika, you can let me know afterwards, what's the proportion of people who have just started.
Yeah, sure.
Brilliant. Okay, so let's get started. So, let's go. The first thing that you need to know about DeFi is that, of course, it's decentralized finance. And what do we mean by decentralization? Every time you hear decentralization, think about shift in power dynamics. And that shift is enforced using code. It is very important because that is kind of going to be your test. Is this decentralized or not? Ask yourself, has there been any substantial shift in power dynamics in the decision making? And I want to say this as we start because you will see that DeFi and blockchain in general is as much of a technology as it is a political activity. It has to do with shifting what is the ability for people to make decisions and to have a voice, and to break monopolies, and to break also the closed door approach on what is, to great extent, the traditional finance. So you will hear, quite often blockchain being referred as a democratizing force. And that's, I think, what it means. That's the actual, not in a nutshell, that's the actual power of blockchain and decentralization. So shift power dynamics, and you will see throughout the process today, looking in depth into each detail why that is important. So DeFi doesn't care who you are, and that's very, very powerful. There are some set of rules that are encoded in the protocols, and everyone needs to follow those rules. Those who are, have experienced DeFi already, you will know that it is extremely, extremely fast. Although, there are concerns about the ability to perform transactions at the same speed as traditional finance. In reality, when you look at the actual products, you will see that the speed at which transactions are happening, or in general, activities for financial activities, it's nothing compared to what is on traditional finance, and that's mostly because it's peer-to-peer and it is automated. You will find that in DeFi there are lower fees because everything is transparent. So there is only so much that you can get away with from doing a ripoff, because also a lot of the projects are open source. If something is not good enough for the customers, someone will pick up the code and do a product that it is more competitive. So there will always be something that is customer centric. And in terms of costs also, it will be much easier to run a DeFi project because there will be everything on chain. The accounting is much easier. It is transparent, but also easier to execute. So there will be less human capital. When you think of a bank like Citibank or HSBC, OCBC, you name them. how many people are, behind closed door, in front of a spreadsheet doing a lot of numbers. With DeFi, teams are much smaller. There's no need of, that big machine at the back. The other thing that is very important, DeFi, very interesting, is that interest rates in general are configured as part of the protocol, and they are calculating based on supply demand and with risk parameters of the assets that we're touching on. So that's something that it's automated and it's transparent. It's very interesting, and it is applied equally. And of course, as blockchain goes, there are no intermediaries. There is no what the most ideological DeFi people would call parasitic layers. Let's call them no value add layers. So that is removed. There is only the protocol and the user. And I think something that you will find as part of the culture, the community, which is as fascinating as the technical aspect, is this idea of irreverence and playfulness. You'll see there are strange and weird things going on in the community, but that's quite fun. Whether you're planning to work within the industry or just be a consumer within the industry, be ready for definitely untraditional moves and names and terms. And probably the best bit about DeFi is the sense of community that is bringing everyone together. There is a sense of shared values on community and shared willingness to break the rules and get something better at scale. So DeFi is a new financial system, which is both alternative and complementary to CeFi. I actually don't believe that everything will be replaced necessarily. You will see banks are actually moving quite quickly into incorporating DeFi products and even cryptocurrencies as part of what they're offering. There is money to be made for them. It is better for customers. It lowers costs, so why not? Everyone can improve with that. There is no culture war that way. DeFi, in a nutshell, is finance that is built using cryptography. It is definitely done on a blockchain, and it is done so thanks to smart contracts. Probably over these 2 days, you've heard quite a bit about what smart contracts are. I don't want to go into the depth of that. Just know that because of the complexities and potential of smart contracts, the majority of DeFi is built on Ethereum. And that's because there is the language program called Solidity that will allow for that complexity to be executed. So when every time you hear smart contract in DeFi, but in general, just think about an input that execute a logic and that then update the blockchain state, in accordingly. The other thing is it's done irreversibly. So there is no way that you can then go back, and that's the risky bit, but also the bit that makes it so powerful and allows for the disintermediation of some of the layers. We are going to get into the details of all of this, but I just want to go in broad terms to begin with. Smart contracts allow to build the logic for DeFi, and it is an ecosystem that leverage network effect. The other important aspect, you probably heard this before, crypto never sleeps. You will see CeFi does need to sleep, does need to recover, that needs to have closed doors sometimes during the day, to clean the house, look at the, inside the cupboard, close the doors and do whatever it needs to do. Crypto is always open and it's always auditable. It's always there, it never sleeps. It is open to everyone. And you will hear these words quite a lot. If you want me to get into more details, but just let me know. It's permissionless, and it does enables cooperative work thanks to being open source. If there is one message that you want to take away today, is really that centralized finance allows only for banks and financial institutions to create financial products. DeFi breaks that dramatically. So that opens opportunity for everyone. So when we're looking at centralized finance, we're seeing that, right? It's happening behind closed door, and it is done by a group of privileged few. We know, even if you're not looking at the problem of diversity in itself, even if in terms of actual execution, there are in the end very few people that have got the knowledge, access, network, and actually the jobs to actually execute the things that are happening in finance. There are massive inefficiencies within centralized finance that produces a a lot of cumbersome processes, because even though there is a nifty and easy to see UI UX, due to the very expensive compliance costs and regulation, and the big machine that needs to happen at the back, even the most advanced and user-friendly traditional financial products require a big machine behind the screen. Always remember that DeFi is challenging it. Other important things on CeFi, you've heard quite a bit probably about having DeFi, or in general, blockchain, trying to bank the unbanked, and providing financial services to those who traditionally don't have access to it. If you look at it, centralized finance does have limitation. We'll tell you you can or you cannot. They will decide. They are the gatekeepers because they are centralized, and they will make the decisions based on certain criteria. The other thing, if you have ever tried to launch a product within banking or finance, the barriers to entry are incredibly high, which suits well the incumbents. They're very safe. They know that they have to spend a lot of money to get into the market, but then they can just do their thing, because there will be, only so many competitors will come into the market. It's kind of a self-regulated competitive market. There will be slow innovation. That means that they can charge high fees, and they can just, get along with each other, get along with the regulators, and do their best, within a very complex system. Finally, final, but not definitely the last when it comes to centralized finance, everything is built to be proprietary, closed, and protected. And that's, maybe we can touch maybe another time on how banks are actually trying to innovate using blockchain. And there is a bit of friction because their systems are not designed to be collaborative and open. So you will see over the next months and years how banks will actually be able to embed DeFi or just crypto within their current infrastructure. So just a quick promenade across the history of CeFi. It's been like decades of technological innovation. In the 1920s, we're just a counting machine and punch cards. In the 50s, we've got computers coming on board. Then there will be ATMs, credit cards. Stock markets started to get computerized. There will be the beginning of what will become algo trading. So automated trading using computers, computations, very complex calculations behind it. In the 1990s, the internet booms that created different level of relating between the consumer and the banks. Like people will, started to expect to be able to bank from their own house. And in the 20s, the 2000s, that really boomed into what is the fintech revolution with the tech-first approach. You will see like PayPal, TransferWise, Robinhood, and so on. But ask yourself, have the power dynamics changed? No. It is still a centralized entity makes the decision, and they decide whether or not you can access the services or not. It's still centralized finance. Even the more sophisticated and user-friendly fintech, it's still centralized. So let's get into the decentralized part. What is actually changing? You can have very efficient services. You have immediate settlement and no geographical barriers. Interesting to see how the regulatory bodies will actually respond to this. You've seen India has been very, very prudent, very slow, if not hostile towards the crypto space. But we will see some city-states going to be faster to adapt. Like Singapore has been, definitely one of the, where I am like now based, one of the fastest to embed and experiment with it. You will see when we're touching CBDC, you will see that Singapore has actually done quite a bit on that. But in general, geographical barriers really DeFi don't care about it. It is fair and unbiased. There are a few projects that call themselves unbiased tokens. That means that you have equal treatment. It's not about who you are. It is only about what you can do within the DeFi space. Especially for loans, that will open a lot of opportunities where before there were closed doors for social reasons or economical reasons and so on. It is permissionless. As long as you've got an internet connection, you're fine. No other prerequisite. That's all you need to be part of the DeFi space. And it is censorship resistant. I don't know if you followed everything that happened with the GameStop. There's been, if you followed there, you will know that Robinhood was helping non-institutional investors to buy stock and do their own bids and try to make exceptional profit out of shorting certain stock. But eventually they decided that it was enough, and they just pulled essentially a killer switch, and they said, enough, you cannot do it anymore. So on DeFi, that it's not possible. There's no single party that can just deny you access or just pull the trigger and say, no, enough. It is not anymore in my interest or in my investors' interest. And once the protocol is there, that's what decentralization is. It will just keep going. And we will see there is also a degree of decentralization. Not everything is fully decentralized, but I'm not going to touch on that at all today. It's a talk on its own. But in a nutshell, multiple parties cannot just change rules. Even if there are many of them, they will try to collude. If it's robustly enough, robustly built, then DeFi is unstoppable. In fact, that's another word that is used quite a lot: unstoppable systems, unstoppable applications. And it is transparent. As it goes for financial products, everything is on the blockchain. It is feasible. If a protocol is offering services to you, you want to check, you can see, it's very easily to find what are called explorers, or like CoinMarketCap and other services where you can look at trading volume, outstanding loans. Everything is for everyone to audit. And if you've seen like what happened with the 2008 financial crisis, that was the exact opposite of transparency behind closed door, or what was going on. Finally, it is open, so everyone can contribute. And that's my personal request to everyone in this room. I know it's quite a few of us connected together, virtually together here today. We need more diversity in the community and in the industry, both gender and representation. It is getting better, but it is still not as good as it can be. So please, roll up your sleeves and then just try it out. I'm pretty sure this writer, this poem, but you cannot cross the sea merely by just standing and staring at the water. So after this talk, just get involved, get a new project, or get as a customer, build something. It is possible. It is doable for sure. So why do we care about DeFi? First of all, because of the incredible growth that we've seen over the last 12 months alone. The total value locked in, which means the total value that is collectively across all the protocols in the DeFi space, has grown from 1 billion to over 32 billions and USD. And I don't know if you can think of the scale of this, but that was just in, let's say, 10 months, 11 months. That's absolutely astonishing growth. The trading volume has gone from $500 million in April 2020 to over 50 billion in, I think it's January 2021. And the total value settled on Ethereum now, it's over 1 trillion, which is more than PayPal. So we are getting there, guys. Things are moving. But how did we get here? So let's get into like the history. I will go quite quickly. I know that we have 1 hour, but you will see it's going to take quite some time to get through everything today. I want to spend some time on everything. So, of course, the beginning was Bitcoin in 2009. There were some limitations by design. It is programmed using programming language called Script that didn't allow for applications, and that's why Vitalik Buterin in 2015 came up with the idea of having smart contracts, a virtual machine, and ERC20, which is kind of the cookie cutter for building more cryptocurrencies, more what they call tokens on top of Ethereum. And that was in 2015. 2017, there was first move on building actual applications in finance. And the very first one was MakerDAO in 2017, what is called an unbiased currency with no volatility. It's essentially a stable coin. After that, there will be the first DEX, Ether Delta. Of course, it got hacked, which happened quite often in the early days. And in the end, it also got charged by the SEC for running an unregulated exchange in 2018. Sorry to break the news, but I don't think they're coming back anytime soon. I think that the project is gone for now. But there are many more that learned lesson from these pioneers and built more. If you have heard about ICOs, of course, there was a big spring in 2017, bridging all the way to mid-2018. And it was about fundraising in a new way. Again, democratizing fundraising. It was not about a single VC promising you money and asking you for a lot of equity. It was about instead offering tokens and going and crowdfund it, so offering to the public. If you believe in the project, buy the token, be part of the revolution, have skin in the game. So that was the ICO. Some were legit, some were just, for the sake of the opportunity and made quite a lot of substantial money and disappeared. So bad rap that came out of it. And that kind of opened the crypto winter in 2018, 2019. But don't be fooled, the teams and the passion for the technology was still there. Everyone was busy behind the door building. That's how in 2018, Uniswap, one of the major projects for DeFi, was funded with a small grant from the Ethereum Foundation. I think no more, I think it's 20,000 USD. And you will see the magnitude that actually is now Uniswap holding in terms of total value locked and transactions, overall transaction. 2019 was the time for synthetics, the first derivatives on blockchain, decentralized derivatives, and other projects that are still there. Kabir from Singapore, OX, Compound, and REN. Everything was almost coming back to a spring, if not summer, when Black Thursday happened in March 2020. Probably, I don't know if it was fresh in your memories or not. I was very much glued to the screens and seeing the price tumbling down dramatically. ETH price went down 30% in less than 24 hours. Many projects lost a lot of their war chests. It was a big blow for the entire ecosystem. But that didn't last long, of course. Crypto just says, okay, shrugs it off. They said, let's build something better. And that's how DeFi Summer started in May 2020 with Compound and the Comp token. And actually it was quite an interesting way of bouncing back. And it was the actual beginning to me of DeFi. This is it's pre-comp and post-comp. The actual DeFi Summer started with a post-comp in May 2020. So they built rewards and incentives for trading different tokens, which resulted in different annual percentage yields. And that gave the birth to yield farming. Probably heard, if you've been around the DeFi space, you heard about farming a lot. That's what it is. Essentially, you're looking at the annual percentage yields and you try to optimize it, switching across borrowing and lending using different tokens in your basket. That opened opportunity for new companies, new protocols to start up new projects. That's how Yen Finance started in early 2020. And that became essentially what's a robocall. It's an automatic switching between lending protocols. That was like a hugely positive response with the beginning of liquidity mining. They issued actually their tokens by liquidity mining, and it rose from $6 per token to 30,000 in less than 2 months. That's really like astonishing growth with a lock value of over I think it's 630 million actually. As things go, you will see that vampire icon over there. That's the beginning of the weird DeFi stuff. But in August 2020, Amplefort was born. We will see more in details about Amplefort later. It's elastic supply model, and Yam. Yam is in like the potato, like the yam vegetable. That's the name of it. And it just was just launched in 10 days of code development. Absolutely no due deal, no audit. It was done, honestly, it was done with no real purpose. It was just done to make some money, but people really flocked towards it, and they found a critical bug on their base mechanism after $500 million value was locked into it. Quite a few people lost quite a lot of money. That was not fun. And I think Yam still around. I don't think there will be a lot going on after this. It's yeah, the trust is gone in many ways. And in August, I don't know if you've ever heard about Sushi Swap. It is one of the most controversial moves and also gossipy things that happened in DeFi last year. It was launched by an anonymous team, and they launched what is called a vampire attack. They tried to siphon away all the liquidity from Uniswap. They managed to do so for about 1 billion, and that didn't go down well with the community. After that, there was a whole generation of what they call food finance or DeFi food. There was the pasta finance, spaghetti, kimchi, hot dog. They were all short-lived, and there was not much that actually was successful after that. That was the end of the summer. It is actually marked with the launch of Uniswap token. With a retrospective airdrop, everyone got a lot part of it. Essentially, Uniswap token was given to the community for free, and people made more than $1,000 just because they were part of the ecosystem. As part of the liquidity mining program, then they raised about 2 billion, and they managed to reverse the vampire attack from SushiSwap, got quite a bit back. Now it's grown quite a bit from 169 million in August 2020 to just now around 15 billion, and the total value locked overall just now at the end of the summer, it was back in till September 2020 up to 10 billion. So after that, again, you see in crypto we talk about spring, summer, and winters. Another winter, everything went down 70 to 90% token price. It was not pleasant, but honestly, it still was quite remarkable. It bounced back quite immediately, 50%, and the value kept increasing and increasing, even though we're in the middle of the DeFi winter. Hitting just now, February 2021, we are at 32 billion. If you think that just started in April 2020 overall, that's astonishing. That's quite amazing. And you will see just now where we are now, there is what I personally call memes finance, with projects with no real purpose that are quite fun, but who knows? And you will see a lot of movement in that sense. And of course, NFTs. I know there have been already talks about NFTs, so you know everything about NFT. I will not touch on NFTs today, but that's what I personally think it is. It's just that's the season of NFT. Okay, a bit of a breather. If you have questions, just stop. Andrew, feel free to stop me with any questions if at any point they're coming up. That was like a brief but intense overview, and now we're going to get deep into each of the DeFi categories. It's going to get a little bit more technical. Hopefully I will do a good job. If not, stop me and ask me a question.
Yeah, sure. Cool. As of now, we don't have any questions. Maybe they may drop at the end of the session. We may continue.
Fantastic.
Yeah, thank you.
Fantastic. Thanks a lot, Andrew. Okay, so lending and borrowing, we all know what it is, right? There is nothing, the concept is the same. You got a lender who provides funds to borrowers in return for interest on their deposit. Borrowers and loan takers are willing to pay some interest on the amount that they borrow in exchange to get some funds right away, right, for whatever need. That's the mechanic of lending and borrowing. That's not changed. The first innovation was with introducing crypto as part of the lending and borrowing, but that is still done as part of a financial institution. It's still centralized with crypto banks. So essentially, you can borrow Ethereum, or you can borrow Bitcoin or any other token. That's still traditional borrowing and lending. And because the assets are still held by a third party, so it is not peer-to-peer, disintermediated, or with a protocol that is doing a smart contract that is executing it. You're still giving it to an institution who is mediating it, and you have to trust them with your asset. So when it comes to borrowing and lending, just crypto is same vulnerability as a CeFi. Now in DeFi, that gets broken up because borrower and lenders are able to interact with one another using a decentralized and permissionless ecosystem. And they are able to also maintain full custody over their own tokens. And they're able to do so because there are smart contracts that are executing this logic. How does it work? You've got a supply that comes from on the lending side. Let's say that you want to make some money, earn some interest by lending some tokens to someone else in the system. You supply your tokens to the protocol. Yeah, you send them to a smart contract essentially. Now they are available to other borrowers. They can just take it instantly, right? It is for there is no like agreement, contract sign, or like can you do it, can you not do it? No, it's disintermediated. You say, okay, you've got an account, you want to borrow, just take this money. When you are lending the tokens, you are being given a native token from the protocol that represents the value of the tokens that you have supplied, plus the interest that you're going to earn. So to get your fund back, you have to redeem them by giving these tokens to the protocol back, to the smart contract. So the smart contract will say, okay, this is the equivalent, and you can get back whatever amount you have given to others for borrowing. There are specific tokens that they use for compound. They're called C tokens. For Aave, which we're going to talk now, they're called A tokens. So it's very secure, actually. It's very safe. DeFi loans are over collateralized. What does it mean? It means that every time the amount that is taken out for borrowing, it's much lower than what it is put in for lending. It is, it is forcefully and strict. So why do you want to borrow? Primarily, it is because you want to maintain your tokens, but you still want to have some liquidity at the back. So you don't want to necessarily sell the tokens that you have because you think that maybe you will appreciate over time, or you just want to, keep them for your own portfolio without selling them. You can just park them and earn more than what you would otherwise by just having them in your own wallet, in your own custody alone. And how much can you borrow? Anything. There is no limit there. And it is not means tested. That's the thing that it's very different in DeFi. It's not like someone is coming and saying, oh, because of so-and-so, because of the jobs that you have had or not have had, because of the income that you now have, or because of the place where you live, or the age that you do have, that you are at, then this is the amount that you can borrow. No, as long as you post collaterals, you're fine. And collaterals are transparently calculated by the protocol according to a very fair and equal dynamic called collateral factor. So that applies to everyone. There is no adjusted risk factors in that sense. As long as it's for the a certain pair, that's a collateral factor that is calculated there. So you can, but however much you want to borrow, that must always be lower than the collateral that you're posting. And if it falls lower than what is the threshold that you have stipulated, then your collaterals are going to get liquidated by the smart contract automatically. It's very transparently done. And there is no time limit. Plus, the lenders will receive an interest that again is determined automatically by the protocol based on the ratio that there is between the supplied and borrowed tokens. So, the rarest the token is, of course, the more interest there is for that token, the higher the interest rate is going to be for that specific pair or token. One project that has been hugely successful, we mentioned it earlier when we started with a pre-comp, post-comp, that's actually Compound. That's the nice logo that they have. 630 million of value locked. The interest rate in this case is calculated algorithmically, and it is done in an autonomous way. There is no accountant or trader sitting in the back room and saying we shall post a different interest rate based on our own personal interest today. No, everything is calculated algorithmically with rules that you can see and audit in a very transparent way. And the supply assets for Ethereum, Brave. By the way, the browser Brave. If you're not using Brave as your own browser, you can earn tokens just by using that browser, and Tether and 0x. Plus, you can just post the collateral. That's mechanics that we've covered. Another interesting platform is Aave, which is Finnish for ghost, hence their symbol, their logo is with the little ghost there. The A tokens are actually quite crafty because they don't just represent the amount that it is that you're lending. So it is not a one-on-one, but it also adds the interest within the ERC20 token itself, which means that it will increase over time. And the super crafty and interesting feature that they've created is that because it is an ERC20 token, you can even send it to others. So the other will receive a tokens that it is still appreciating because it will keep accruing interest over time. So it's super nice. Read more about it. It's a great project. Finally, they're really good at marketing as well. They call instead of tokenomics, Avenomics, and they're using the tokens for governance. So that's when we go back to the concept of decentralization as also a power dynamic change. The token holders are those who are making the decision and can vote for governance. So it's there. I want to take a little bit of a breather, and then we're going to quickly on the flash loans. I hope it's not too fast or too intense. Okay, flash loans. It's the same principle. It is a bit weird as a concept, but it is super crafty. Essentially, you can borrow any available amount that you want in terms of assets. You can do so with a smart contract that is pulling together a lot of assets, but you don't need any collateral, like with traditional DeFi lending and borrowing. So no collateral. There is, however, a snag, and that's why they're called flash loans. You have to borrow and repay it within the same blockchain transaction. So we're probably talking no more than 10 minutes apart. And you would say, like, what's the use actually for that? As there are opportunities now, computing power is so great that when you hear like algorithmic trading, they can actually take opportunities, even if it is a small margin on arbitraging or swapping collaterals. At volume, at scale, can actually make quite decent money for traders. So that's what they're used for. They were very popular probably 4 months ago. There was like the flash loans summer. Just now, there's still a lot of innovation happening. Let's see where it will actually take us. Okay, now it's a big one. That's on stable coins. So stable coins are coming to try and break one major snag about cryptocurrencies, and that's about volatility. You'll see prices. That's the one thing that everyone knows. Prices going up a lot, is going down a lot, which is a good thing if you are using them for store of value. But if you want to use it for transactions or for e-commerce, then it's not going to be a good thing for you. So they come up with a new concept for cryptocurrency. And that's what where stable coins are coming. That's stable, right? They're not fluctuating. They're trying to keep it with a stable price or relatively stable price throughout the life cycle. So like fiat cryptocurrencies, of course, but even though like fiat currency, there would be like an depreciation. If stable coins are pegged to the fiat currency, by fiat currency we mean normal currency like the dollar, the Swiss franc, and so on. So those are the fiat currencies. They may appreciate and depreciate over time, but overall they're quite stable. So they want to recreate exactly the same thing in crypto. Again, can be store of value. Many people will just make a lot of profit out of the arbitrage and the volatility, but then keep the earnings into a stable coin, so they don't have to worry about volatility. So they will use it with what is called store of value instead of for speculation, and that can be quite interesting. How do they do it? They are using smart contracts to keep the price stable. I will get into the details now, but there are different ways of actually getting there, and there are also different ways to back this stable coin. Though some are using crypto and some are not. Some they're not backed at all. So the main difference are between algorithmics and non-algorithmic stablecoins. What does that mean? If they are non-algorithmic, It means that they have a fixed exchange ratio with the fiat currency that is backed by an actual asset, and that is done by a centralized entity that makes sure that there is always this value on a 101 or whatever ratio it is. Very popular USDT, USDC, and PAX. We can categorize it by the type of collateral, the type of banking, and you will see if they are completely collateralized, that means that they have assets including tier one, means like essentially what is the central banks are issuing, or they have fiat currencies that are backing it. For example, with Libra or Ikrona, that is actually a CBDC, you will have for one Libra coin could be $1, okay, could be €1, could be like it's exactly the same ratio, but someone is actually holding that fiat currency in their own bank account, in their own in their own custody, to make sure that then the value can always be liquidated if that is needed, right? If it is collateralized with crypto, it's the same thing. The only thing, instead of having fiat currency at the back end, you will have crypto. So it could be that the one DAI equals one Ether, okay? So you will always have someone, like a company, a centralized entity, that will hold those funds safe to make sure it is possible to liquidate them to back whatever is the need of the platform, right? Others are instead non-collateralized, and those are the ones that are based on algorithms, because they're using an algorithm to look at the price, so that if it is high or if it is low, it will get completely evened out over time. And now we're going to look into the details of it, so you can see some examples. The first one was basis. Then there is Ampleforth. If you remember, we had mentioned it earlier in the summer of DeFi, and one of the projects that I've been advising on called Mahadao, and that's also like a way for keeping the value stable over time. They're using algos for it. And then there are hybrids, of course, where you have part algorithms and part collaterals back into fiat or crypto. So how does it work? In algorithmic stablecoins, you have a fixed exchange ratio to a fiat currency, but that normally needs to be backed with a fiat asset. But instead, with an algorithmic stablecoin, to maintain value, you're just using essentially the issuance of bonds. You are incentivizing the community to buy or to sell, depending on where the price is for the coin. So when the price is increasing, you are issuing more coins. So there will be more liquidity, so people are buying more, so the price will go down. When instead the price is falling, you are, as a protocol, you are buying them off the market. That creates demand, so the price rises up. In that way, you can kind of balance it. And the algorithm will make sure that the price remains stable. Hugely crafty, great engineering that goes into it, fascinating. Read white papers, by the way. Never be scared of picking up and looking at the tech side. Even if you don't understand it first times, over time, maybe in a month, you will read more and understand more, and so on. Never be scared of looking at the tech side of all of these protocols. So Ampleforth, Mahadao, as I mentioned. And just know, though, that this is cutting edge DeFi. People still don't know what are the implications of it. People are still experimenting. So approach with caution. There are good opportunities to make good money, and there are good opportunities to witness something quite epic for the entire industry. But just be careful. Also, because the code is enforcing all of these dynamics, regulatory bodies for now, they're not involved at all. So again, beware, but it's interesting. One specific type of stablecoin, they are CBDCs, or central bank digital currencies. You probably have heard that quite a bit. You have quite a few countries that have issued that. Some, of course, everyone is centralized because they're from the central bank. They are issued and regulated by the competent monetary authority, and they are used to represent the local currency. We still don't know. There are quite a bit of debate over the backing of it in terms of reserve, but we will see where they will take. Each country is going to take a different approach to it, and they're designed to work alongside regulated money as a whole. Cool. Again, if you have questions, just let me know. Huh? So decentralized exchanges. What is an exchange? On exchange is when you've got some currency and you want to swap it with another, and you have an entity that will set the price and will tell you what are the exchange rate and the exchange fee, right? You have crypto exchanges where you can get fiat for crypto or crypto for crypto, and traditionally they are the bigger ones. They're all centralized. You are seeing Binance, Coinbase, Kraken, Bitfinex are probably the bigger ones in the market just now. Poloniex, so many. You have with these like centralized crypto exchanges, there are of course liquidities, and you will find fees that they will charge you. They will accept credit cards. It's very traditional experience also as a customer. You will have your own cryptocurrency wallet where they will take and will keep your funds. You can keep it there, not that safe. Or you can just put the money that you need to exchange for just the time that you need it to exchange for, and then you're going to keep it on your own personal wallet, offline wallet, and code wallet. There have been tons of hacks and scams, not on the more reputable now, but the crypto history is full of people just parting ways with everyone's money. So it's kind of a scary business. So be careful. Never leave your funds on a custodial wallet on an exchange. And they are working with authorities. They are fully regulated to an extent. They are, of course, doing KYC and AML. The experience normally when you're opening an account with an exchange, you have to give your passport, you have to give your proof of address and so on, as if it was like a normal bank. And you will see like they're also cooperating with the authorities in many ways, like for taxation purposes and so on. Decentralized exchanges are very different. There is no central authority. Most are transitioning or have transitions under decentralized governance model, a DAO. You don't need to give up the custody of your asset at all. Some of them also don't have KYC. Some do. It's a mix. It's their choice. But essentially, you are able to swap currencies on a peer-to-peer basis, using the exchange, the protocol as a means to do so. Some are order book based, so you have a dynamic list of buys and sell orders, which is also how Wall Street works. And some others instead are using liquidity pools, and we're going to look at it just now. So you will have, normally traditional order books, you will have market open and market close, where at the end of the day, they will consolidate all the pricing and put up an opening price. With crypto exchanges, that doesn't work. Even if it's traditional model or order book, remember, crypto never sleeps, so it's continuous. There's never adjustment in that sense. The biggest and the most popular in terms of liquidity pools and so on is Uniswap. The tokens is Uni, and they use smart contracts to make it completely decentralized, permissionless. Nobody has the power to deny you access to the protocol, as long as you do, you play by the rules that are set on the protocol. And they're using what is called concert market maker to make sure that the rates are at market value at all times. Other decentralized exchanges are Kyber, Loopring, PancakeSwap, actually on Binance Smart Chain, and of course SushiSwap. That's a very good resource if you want to get into it. There is a great resource there. Brilliant. Am I overwhelming everyone, or are we still alive? I hope it's okay. 6 minutes to go. I hope we can cover and still leave some time for questions. This is a tough one. I'm gonna go as slow as I can, but it's okay. So when you're looking at derivatives, that's something that is massive, massive, massive for the financial market. DeFi is not very different. So what is a derivative? We've got a contract that derives the value from the performance of another asset. Could be stock, bond, commodity, interest rate, even a cryptocurrency. So why do you use a derivative? Normally you do it for two reasons. One is to hedge in order to manage your risk and get more stable income, or is to speculate, like really maximize your income. I'm going to try and explain in very simple terms how the hedging with the derivatives work, because that's quite relevant for DeFi. So let's planting weeds or like throughout the year is committed for the entire season. Now the price of wheat may fluctuate over time, and that's a risk, major risk to their income, right? So how can they try to hedge this risk? They may sell short future contracts. Essentially, they're saying at some point in time, the wheat will have that price. And I bet that actually at that point in time, the price will be lower than that. So if you're betting with me, then you can buy this short contract that I'm offering to you. When harvest time comes, if the wheat of the price is low, that short position that the farmer had will make profit. So whatever income he's losing because the price of the wheat is low will be compensated by the profit that will be done with the shorting of their position. If instead the wheat price is high or higher than what expected, then the short position will make a loss. However, in the end, the income will still be like the loss on the shorting position will be compensated by a higher price on the wheat. So that will reduce the risk of very dramatic difference between a good price and a low price, and it will make it for a very like a much more predictable income for the farmers. So that's used a lot in DeFi. You have heard about DeFi farmers trying to get yields and make the most out of their portfolio, but it's the same principle. Instead of wheat, they're doing it with their tokens. They're hedging the price of the tokens in this way, and they're using derivatives for it. There is also speculation, and speculators are actually very important for DeFi ecosystem because they provide liquidity. But I will not get into the details of derivatives as part of the speculation for now. Market is massive. You can see 1 quadrillion overall. For crypto, it's still relatively smaller, but I'm pretty sure it's going to grow quite a lot. Take a look. I will not get into the details of synthetics, but just know that it's super collateralized, 500%. That means that for every 500 tokens that are used for the backing of the synthetic assets, only 100 can actually be issued. So whatever was the big flow on the on synthetic products on traditional finance, and to an extent it still is, of over leveraging it, DeFi has learned a lesson and is hard enforcing a very high threshold for collaterals. Margin trading is a bit hard. I'm going to go quickly through it. If you want to learn more, just let me know, and I can send you more details about it. But essentially, it's used to make good profit, really, really good profit. So you are just borrowing more funds based on a ratio that is called the margin from a broker, to make sure that if you're very sure that your position is a winning one, you will make much more profit, even like extending onto what you can actually afford yourself. It's very risky. As much as you can increase your profits, you can increase your losses with it. But it is quite interesting, and I think we will see that as DeFi goes, there would be like a margin growth of this part of trading. Some example of products, DYDX and Fulcrum. And by the way, Binance.com has a great academy, like a knowledge center called Academy. Very, very welcome to use that for anything that has to do with DeFi. I have 2 more. I will go quickly to insurance and to oracles, and then we can wrap it up. For insurance, you know what insurance, right? You've got guarantee compensation in case something happens in return for you paying a premium all the time, right, on a regular basis. For DeFi, it's the same principle, but it's quite interesting because it is not done in a way that will benefit just the insurance company. It's done on a peer-to-peer basis. One good example is Nexus Mutual. I love the definition that they have given for themselves to describe what the product is. But essentially, they're saying it used to be mutual risk. It was a community-based model. It was not the adversarial model where you've got a large institution that dominates and and sets the premium, and it always squeezing value from the users. Should be like a shared risk across the community. So that's what they've built. It's a system that aligns incentives using smart contract code, and that's built on the Ethereum blockchain. Take a look. I mean, even for using it, I think mostly in DeFi space, it's used to protect against loss of funds or for smart contracts failures primarily. But over time, I'm pretty sure there will be products that will reach out on like healthcare and other or life insurance and so on that can be used in that way. Just the last one, and it's going to be super fast. That's on the oracles. Everything that we need on DeFi is based on data. So you need a bridge between what is the real world, the CeFi world, or the commodities, like the real life, and what is the DeFi protocols, right? They all the smart contracts, they need reliable copies or digital information about what is happening in the rest of the world, right? So that's what oracles are. Some of them are centralized, but they start to begin a whole movement on getting decentralized oracles that can be, again, trustworthy, transparent, and limit the reliance on single source of truth. Probably the best known project just now is Chainlink, but I'm sure there will be a lot of innovation and more projects coming up in this area. Good. So just to wrap it up, there are some issues. DeFi is not perfect. It's still nascent. Just remember April 2020, it was the very start. There will still be some bugs in smart contracts. There will still be some sudden protocol changes that you have to watch out for. There is also different degrees of decentralization. You probably have heard of all the debate with Binance Smart Chain, of the decentralized, centralized finance model that they are proposing. There will always be the risk of actually the entire model of a unstoppable system to actually have a killer switch. And that's a big debate in the community that is happening just now. We will see what it will take. There will also be always systemic risks, like the famous Black Thursday, where all the asset prices will be tumbling down systematically across the board. And of course, from a pure technology point of view, network fees, congestion, and scalability will probably be always an issue until we can find a better solution. But that's what it's nice about DeFi. We're pulling together as a community. Although everything is built on Ethereum, personally, I believe that there will be much more diversity over time. ETH2 is coming with the new different ways of doing the consensus. That will probably, actually, they will surely help with the scalability of Ethereum itself. There are also a number of layer 2 solutions that are built on top of Ethereum to help with the scalability. And there are also new protocols that are coming with new smart contract capabilities. Polkadot, for example, is coming. And there are many others that are contending for specific use cases. Plus, there is a rise of hybrid centralized networks, and the holy grail, of course, is the interoperability between CeFi, DeFi, and public and permission networks. So let's see, let's watch it. But so far, it's very exciting as it is. I hope you can take away from today, some basic information about what is possible with DeFi. And I hope that you can reach out, to me personally or to the entire community. Just see if there is anything that you want to try and dip your toes in. It's not actually very different from any other project. Just get stuck in and start building. Okay, that's all on my side. I will stop sharing. Thank you so much. Probably I've taken 4 minutes longer than expected.
No
I'm
worries,
so
no
sorry.
worries. Thank you. That was a brilliant presentation. You walked through the finer points on DeFi. I think many are newbies to the term. That's the reason we are finding little deficiency in the topics. I mean, the questions from the audience end. Maybe DeFi is destined to disrupt the traditional finance. Maybe the more education and more accessibility towards a DeFi will, get more people into the community, I believe.
Yes,
So
and like as a special message for today, especially the women's in the room, do get involved. Really, we don't have enough representation, and I'm very happy to be a bridge. If anyone wants to just reach out on LinkedIn, just do. I will introduce you to the network, or if you're looking for the first job in DeFi or in general in blockchain, reach out. Happy to be a power networker that way.
thank you, Alex, for joining today.
Thank you, everyone. You take care.
Thank you. Hello and hi everyone, welcome back. Now we have with us Anandan Rajashekharan. He's a blockchain trainer and research engineer at Kerala Blockchain Academy. He's a judicious developer and a blockchain enthusiast with more than 2 years of experience in multiple blockchain domains. He's a part of the Ethereum and Coda research development team of KBA. On behalf of KBA Women Connect, I extend my heartfelt gratitude for Anandan for sparing his precious time with us. Over to you, Anandan. Thank you for joining.
Thank you, Anshu. Thank you for the welcome. Okay, so today we'll be, I'll be discussing about the Ethereum blockchain technology, the journey of Ethereum blockchain technology. So we'll be going through the history, the different mechanism features of Ethereum blockchain technology, and the application on top of that. And finally, I'll end it with a demonstration of a sample application. So let me just share the screen. I hope my screen is shared and everyone can see that.
Yes.
Okay, thank you. Okay, so Ethereum can be said to be one of the most popular and one of the best Ethereum blockchain out there, and it has a vast variety of different people interacting with it and working on the improvement of the Ethereum technology. So yeah. So as an introduction, when the Bitcoin blockchain was introduced, the world was very happy about that. I mean, we got a new and innovative mechanism in which we can move forward in the financial domain. I mean, the financial domain had many technological improvements, but a technological improvement like Bitcoin, which was a decentralized financial platform, was new to that domain. So everyone was happy and everyone focused on the financial aspect of Bitcoin. At that time, nobody actually realized the potential of blockchain. Everyone was concentrated on the Bitcoin blockchain technology. The blockchain, which was actually the backbone of the Bitcoin, which was used to store all the financial transaction that was happening on the network, was more than just a financial or a ledger. So after time passed, people began to realize this, that we can't really constrain blockchain technology only to the financial background or financial domain. We need to expand it. We need to let it open its wings and fly it to the sky so that it can realize its potential. So that actually led to the creation of Ethereum. Ethereum is just like the predecessor, is an open blockchain. Anyone can access it, and it is also a banking for everyone. Basically, just like Bitcoin, it can be used as a financial platform, a decentralized distributed financial platform. And even though Ethereum has some credentials like an username or password, it is not actually tied to any real world identity information. So you remain anonymous on the Ethereum blockchain network, just like in the Bitcoin network. I mean, then it's a peer-to-peer network. It's censorship resistant. I mean, basically, if you want to put something on the internet, you will always have to go through some censorship management, IP rights, all those things. You have to look through those things. But if you want to put something, you build something after a lot of hard work, and you want to put something, then you don't really need to go through this censorship, all those things. You can directly put that into the Ethereum blockchain, and the customers, the internet customers, can access that. The commerce is guaranteed. Just like I said before, there is no boundary within Ethereum. If you have an application, if you have a genuine use case, then you can put that on your blockchain network, and the customers, the internet customers, can always access that. There is no problem in accessibility. So any business that is going to be built on top of Ethereum, it has its commerce guaranteed. Then it has a huge number of developer communities that is set up around the Ethereum network. So yeah, these are what we call the Ethereum blockchain. But what what can we simply say about an Ethereum blockchain? So Ethereum was first of its kind, a general purpose programmable blockchain technology. To elaborate on that, at the time when Bitcoin was introduced, there was no general purpose programmable blockchain. If you had an idea and it needed the implementation of blockchain as its backend, then you had to fork the code for blockchain for Bitcoin. Then you have to modify it to your needs. Then only you have your own blockchain. Otherwise, you can't deploy your application on top of Bitcoin. So that was Ethereum. It was one of a kind. There was not actually at the time of release of Bitcoin, there wasn't any other blockchain that wasn't like a fork or that was not similar to Bitcoin. So it was one of a kind at that time, and it was a general purpose programmable blockchain technology. Now let's understand how this came to be. So as I mentioned before, the potential of blockchain was constrained to the financial domain at the time of Bitcoin release. But gradually, people come to realize that they need to do or implement the blockchain on other domains also. So one person who had same thought process, known as Vitalik Buterin, created something called Bitcoin Magazine, which was a community that was formed around Bitcoin. I mean, when Bitcoin was introduced by Satoshi Nakamoto in 2019, a lot of people were interested: traders, business personnels, developers, researchers. Many people came together and formed many community around this Bitcoin technology. And Vitalik Buterin co-founded a community called Bitcoin Magazine, which was for the sole purpose of releasing a content towards cryptocurrency or blockchain technology or Bitcoin technology altogether. They released contents for like articles related to cryptocurrencies or financial technologies like these. I mean, it was mainly concentrated on the Bitcoin technology. Then Vitalik realized that the blockchain technology needs to be more elaborate, or it doesn't need to be constrained to this financial sector. So he proposed a scripting language. I mean, if you have an idea, if you have a solution that needs the implementation of blockchain, then we can just script that idea into the blockchain and deploy our application. So Vitalik proposed something like this to the Bitcoin blockchain, but at that time, community really wasn't into it, and so that proposal was turned down. But Vitalik, he didn't give up hope. Around 2013, he worked with a company in a project called Colored Coins, and at that time, he developed a draft paper about the concept of Ethereum. An outline was made how this blockchain should be, how this blockchain should move on, how this blockchain should work. The basic concept was a big blockchain or a one blockchain for every application out there. So basically, for the entire world, there should be one blockchain. So that was the concept Vitalik introduced. So this was outlined in the paper in 2013. It was a draft white paper. Moving on, in January 2014, the formation of Ethereum was announced in a North American Bitcoin conference. So, I mean, there were a lot of conferences that happening at that time. So Vitalik and his team announced that they were going to release such a concept or such a blockchain, and they named it Ethereum. Then a lot of people was attracted into this, and one of the founder called Gavin Wood, he actually proposed another paper, an yellow paper, which laid out the mathematical foundation or reasoning for the Ethereum. I mean, as you know, the Bitcoin technology or the blockchain technology in general is actually a combination of many domains like distributed computing, decentralized, then consensus. There are many solutions or many protocols that are in this technology. So he actually defined all these protocols. Gavin Wood actually defined all these protocols for the Ethereum blockchain. I mean, you have to be you had to customize a little bit for the Ethereum blockchain, but he did that, and which was actually a very good foundation laid out. So based on this, in August of the same year, they started a crowdfunding for this project, and around 40 million US dollar was acquired in that crowd sale. And I mean, if you are going to invest into something, you will be promised to something in return, right? So Ether, which was actually just like Bitcoin, the native cryptocurrency proposed for Ethereum was Ether, and this was given as for those people that invested in the Ethereum project, those who trusted the potential of Ethereum project. Then all the hard working actually came into existence when they released their first version in 2015 called Frontier, and the blockchain network, which was a test network, but it came into existence. So that's how the journey of Ethereum was realized in 2015. And after that, many iterations until now has been released. But that was the starting of the actual starting of the network. The founders includes Vitalik Buterin, De Lauro, Charles Hoskinson, Mialis, Amir Chitari, and later on, Joseph Lubin, Kevin Wood, and Jeffrey Wickel. These were the people, I mean, the first five were the first five, and these were the people that came after the release of the paper and all those things. So this is the journey of Ethereum. Let me just discuss a little bit about the design philosophy of Ethereum. The Ethereum doesn't have something called features, because the reason is that you can create any feature inside Ethereum. So the universality design philosophy mentions that there is nothing as features of Ethereum. I mean, there are some things that are inbuilt, but if you don't find a feature inside Ethereum, then you can code it. You can code it using the scripting language that is on top of Ethereum, which is called smart contract. You can code your logic in that and deploy that to the blockchain. So basically, if you want to build artificial neural linguistic AI on top of that, then you can code it. You don't really need to worry about the features not existing. If you have the idea, then you can go ahead and code it. Then simplicity. So one of the main philosophy or main design mechanism of Ethereum is that if you are going to develop a protocol or develop a mechanism for Ethereum, or any already existing mechanism in Ethereem should be simple, even at the cost of space-time inefficiency. That means if it might take too much space, or it may take too much time to execute, but that's not a problem. It has to be simple. Any person, I mean, basically they are aiming that it's a community building project, right? So people should be able to understand it, and so we should keep it simple. Now, next one was modularity. Any protocol, as I mentioned before, it's a combination of many different kind of protocols, messaging protocols, peer-to-peer communication protocols, storage protocols, indexing, like storage indexing protocol. So there are many kind of protocols or many kind of mechanism that is inbuilt in Ethereum. So these mechanisms should be modular. I mean, the improvement or the development on top of Ethereum should not only focus on Ethereum. Like if someone else is building a blockchain, like after Ethereum was introduced, there were many other blockchain technologies that were introduced, like in the private sector, the public sector, there are many blockchains that followed this pattern of Ethereum. Like it has a scripting language, or it has a designable feature on top of that. So if someone wants to use a technology or use a protocol that is used within Ethereum, they should be able to cut and copy it and paste it on over their technology. So basically, it should be modular, like it should be as a modular part component to the Ethereum, and that component could be fitted into another project. So that was the one of the other philosophy. The next one is agility. So basically, every protocol that is defined in the Ethereum is not set in stone. Like if you want to change it, you can change it, but it should just follow the previous design philosophies. Like it should be simple. The new feature should be simple. It should be modular also. The simplicity and modular. It should be if it follows these features, then that's okay. So that is the basic principle of agility. Then the next is non-discrimination and non-censorship. So basically, any new features or any new implementation that we introduce into the Ethereum domain or Ethereum place, then it should not put any constraint on the activities done by any user, or it should not put any constraint on what kind of data the user wants to upload or put into the Ethereum network. So basically, anyone should be able to do anything as long as it is within the limit, or it should not breach the integrity of the Ethereum network. So basically, there is no censorship or there is no discrimination when operating with the Ethereum protocols, or if you are defining a new protocol for the Ethereum network. So if you follow these design principles, then you can actually design a protocol and introduce that to the Ethereum network. I mean, it takes some time, but you can do that. Now let's move forward. So the simple concept of Ethereum is a single computer or a big computer for the entire world. So basically a single blockchain for the entire world, and they call it Ethereum world computer. So everyone in the world, they will be able to access this computer. Everyone will be able to run a part of that computer. I mean, in theory, it is called Ethereum world computer. Basically, it is a group of small computer waved together, forming a network, and it is called Ethereum world computer. So let me just talk about a little bit about the internet. So when the internet was pioneered, the dream was to have an equalized platform for everyone, where everyone can openly and share information. I mean, yeah, it was a dream, it never happened, but this was the concept. It was a concept that was driven by freedom, equality, and everything. But even until now, we are not able to realize this concept. The internet was supposed to be accessible or freely accessible. Anyone should be the internet. The data shared on the internet should like for the betterment of the human community. I mean, we had like a lot of concepts that didn't really happen. We are yet to achieve those concepts. So if you currently look at the trend, the internet infrastructure is controlled by some prominent companies, internet companies in the world. I mean, we have something called a centralized architecture. Most of the things that we need are like controlled by a big company. And if we look at one of the incidents that happened in last year December, if you guys, I hope you guys remember, in 2020 December, there was like a 45 time window in which Google was shut down. No one had no idea why it was stopped, but everyone felt it. No one was able to communicate with each other. Companies were like on a brink of stopping, like standing still. Like it was like a time stop. At that time, we really realized how centralized our system was. I mean, if Google shut down, when we can't be able to do anything on the internet, we won't be able to send messages because we highly dependent on that centralized system. So Ethereum actually is trying to make this centralized system into a decentralized manner. So in case if one peer is disabled or one peer goes off, then that doesn't matter because all the other computers are turned on and they can carry on with their task just like as usual. It doesn't matter how, like even if like 25% of the peers are turned off, it doesn't matter. It doesn't affect the network. So we are trying to, the Ethereum, what Ethereum is trying to is move this our world internet from a centralized manner to a decentralized manner. So basically a world computer, a big computer for everyone. So anyone can access it and everyone will be able to have the copy of the contents in that computer, in their own computer. So that's the vision of Ethereum, one computer or one blockchain for the entire world. But it's a huge responsibility, right? It's a huge, I mean, it's an interconnection between a lot of computers. Tens and thousands of computers are interconnected together to form the Ethereum world computer. So how do we manage the integrity of this computer? I mean, it should not fall, right? It should not fail, or it should not show any anomalies or something like that. So there are three key properties which determine, or which are not determined, which are actually the foundation of the Ethereum world computer. These are determinism, terminability, and isolated. So let's look into each of these. So the determinism means any operation that is going to be executed in the Ethereum world computer should be deterministic. That means we should be able to calculate the output of that particular operation. For example, if you have an equation called a plus b plus c, and at any moment of time, I give an input for a equal to 2, b equal to 3, and the result should be 5, which should happen at any given moment. It should not vary like some other time. If you gave 2 plus 3, it should not return 4. It should always return 5. That means any operation, like it can be the simple operation as addition, or it can be an operation as storing your data. But that operation should have a deterministic result. It should not be something that an anomalistic, or it should not lead to something anomaly. Then the next one is terminable. Just like I mentioned before, the operations. So any operation should be deterministic. Just like that, any operation should be terminable. Any operation that is going to happen in the Ethereum network should be terminated. I mean, it should be terminated based on our will. So there are many ways in which we can implement. We can set a timer, like after a set time, the operation should terminate, or we can set a step counter. Like an operation has a fixed number of steps, and our step counter goes exceeding our counter or limit, then we can stop that particular instruction. Or we could set a fee meter. Like for each operation, we could set a particular fee or cost. And if that cost or fee exceeds a particular amount, then we can stop that operation. So this is the mechanism that followed by the Ethereum computer. And for that, they use the native currency called Ethereum. So basically, Ethereum was released as a fee meter, or a way in which they can achieve terminability. It was later on converted. I mean, people actually perceived it as an cryptocurrency, but the actual use of Ether was to act as a terminability agent. So act as a fee meter, like the unit of fee meter was established in Ether. Now the next one was isolated. So basically, you are putting a code into the Ethereum computer and executing that, right? So this code should not be able to interact with the other programs in your computer. I mean, it's a group of computers, right? So in your computer, you will be running a part of Ethereum computer. So anything that is running on the Ethereum computer should not be able to interact with our computer. Like someone could put a virus in the Ethereum computer. It might not affect the Ethereum computer, but it could affect our computer. So that should not happen. Then vice versa also. Any program that is running on our computer should not affect the Ethereum computer also. So to do that, we needed to isolate this computer, and we created something called virtual machine. Virtual machines can be used, I mean, can be used to create isolated sandbox environments. So basically, it will be self-sufficient, and using only a set of protocols, you can communicate with this particular Ethereum computer. So anything, any other program communicating to this using any other ways will not be able to affect the program in any other manner. So basically, it will also ensure determinism, because basically, if a plus b is equal to c, like 2 plus 3 comes, the result of 2 plus 3 becomes 4. In that case, that means something else influenced that equation or that calculation. So something like that won't happen when you have an isolated sandbox environment. So these are the key features: isolation, terminability, and determinism. These were the key features or key fundamental requirements necessary for maintaining the integrity of Ethereum computer. Now moving on, as you know, Bitcoin was the predecessor of Ethereum. Both are using blockchain. So there were many similarities between these two blockchain technologies. But that was not the only thing. There were some differences between them, and let's just look into that. So basically, Bitcoin's blockchain was a distributed data storage system, which was used to store the transaction that happened in the Bitcoin. For Ethereum, it actually works as a distributed data storage, but alongside that, we have some computing mechanisms also. Then the native currency for Bitcoin was Bitcoin, BTC. Then Ethereum was Ether. That's not much of a difference, but that's a difference. Then the block type. I mean, whenever a transaction need to commit, it is actually grouped together, something called a block, then that is actually written into the blockchain. So for that to happen, Bitcoin needed 10 to 20 minutes or all those time. And for Ethereum, it was actually 10 to 20 seconds, around 10 to 20 seconds. And the block size for Bitcoin, I mean, this group of transaction, one block was around approximately around 1 MB, and for Ethereum, it's actually also like around 25 KB. I mean, it could change, but not that much change. It will be around 25. Then the scripting language. I mean, that was the main reason the Ethereum was generated or Ethereum was introduced. The scripting language, after some time, I mean, at the time Ethereum was introduced, Bitcoin didn't really had a scripting language, but after some time, they also introduced, I mean, they also realized the importance of a scripting language and introduced a limited scripting language for that, which was Turing incomplete. So basically, what Turing completeness means that you have an idea and you should be able to implement that using a particular language. Then that language can be said as Turing complete. So in Ethereum, we had something similar called smart contract. Basically, if you have an idea, you can implement that in the Ethereum blockchain. If Ethereum blockchain lacks a feature, then you can implement that. Then the mining rewards given out were like has halved, just like for Ethereum also. The current mining reward for Bitcoin is around 6, alongside the cost for processing each transaction, and for Bitcoin Ethereum it is 2. And transaction fees were simple in Bitcoin, because basically you send some Bitcoin to someone else and that's it, nothing else happens there. But in Ethereum, you had some computational process, like you have to call or store data, call the smart contract or store the data into the smart contract. Those kind of things were happening. So the calculation of transaction fee, that fee, right, that cost for execution each instruction, were a lot more complex than calculating it for Bitcoin. Then like the scripting language, the applications that use the scripting language were called decentralized applications. So basically, just to be clear, decentralized applications are like applications those are built on top of decentralized network, like Ethereum. So we just call them decentralized app because it is actually working on top of, or working on based on a decentralized application or decentralized network. Now, what happens here is that rather than the application controlled by a single organization, we, the public or the participants of the network, share the responsibility for controlling this application or controlling this decentralized application. So the control or the maintenance of this application gets distributed or shared among all the participants in the network, in the Ethereum network. And mostly, whenever you create decentralized application, the code for that will be kept open and transparent. Basically, anyone can go into that particular repository or location. If it is a smart contract, then go into the Ethereum network, then audit it and check if there are any problems with the smart contract, if it needs correction or something like that. So basically, it was auditable, and you should be able to trust it, because you yourself are looking for the contract and you will be able to finalize if you are able to trust it or not. Due to the factor or design philosophy of Ethereum, the smart contracts will be always simple. Now, this actually people, I mean, for example, let's take an example of Google Pay. Like if you have an application and you developed a mobile application either for Mac or like iPhone or Android, and the next process will be for you to go to Android store or Google Play Store or Mac Store to put your application for sale, so that your customers may able to access that. But in case of Ethereum, you don't really need to wait for the tedious process done by the Google for vetting your application. You can directly go and deploy that onto the decentralized application, or sorry, your Ethereum network, and then anyone can access that. So it gives you some kind of freedom for building new and innovative solutions and piecing them together in an innovative way. So that's that's the idea of decentralized application on top of Ethereum. Now, so this might give rise to some questions like, is it possible? Like, can't anyone simply come and tweak the code just as I like? Or how do DApps run in absence of a centralized control system? So this is where actually the smart contracts comes in. The concept of smart contracts were introduced in in the 90s, I think. I forgot. But at that time, it was proposed as a paper, assuming that we have an immutable ledger, then we can have some kind of scripting language on top of that. That's how this was proposed. But when blockchain was introduced, this was absorbed into the Ethereum blockchain ecosystem. And with the features or the nature of blockchain gives us the auditability feature, the immutability feature, we will be able to implement something like this self-executing smart contract system, and which will actually control all the control and govern all the things related to this application, which in turn is controlled by the network. So yeah, the answer to these questions is yes, we can do that. So that's how we introduced a smart contract. So simply saying, smart contracts is a digital representation of a normal contract. Smart contract contains a set of instructions that constrains any digital transaction or any form of digital communication. So if you want to exchange money, property, shares, or anything of value, like if you have some asset have a value, then you can like constrain that transfer of asset using smart contract in a transparent and conflict-free way. So basically, you will be doing it's a peer-to-peer transaction. It will be happening in a peer-to-peer network. So if you want to send like sell your house to some other party, then there won't be any middleman. You can directly sell it to the other party, and there won't be any conflict, because if once you transfer the ownership, that will be registered in the blockchain in an immutable manner. No one can alter that, and it will be a proof forever there, and you can actually actually say that this particular asset is in my ownership. It's transparent, anyone can look into that, and there won't be any middleman. So Nick Szabo, who was a famous cryptographer, actually defined the smart contract as a set of promises specified in digital form, including protocols within which parties perform these promises. So you have a promise based, for example, I promise to sell my house to someone else, and that's a promise. So this, which will be governed by the smart contract until that transaction occurs. And even after that transaction occurs, it will ensure that transaction happened and the ownership has been successfully transferred. So this is simply saying a smart contract. So basically, you have two parties or more than two parties, and you create a smart contract in a smart way. Like, it is not inherently smart. Whatever constraints you define in that makes it smart. So then the execution happens. So instead of in a normal contract where you have to meet, then go create a smart contract, notarize it using a third party, or you have to have some witnesses in that, then that execution happens. But here, two parties or more than two parties meet, they create the smart contract, and via that smart contract, they execute their transaction. And in most of the cases, they don't need to create a smart contract, because that the smart contract they needed will be already there, and they can just use that smart contract to do their transaction, just like the house transaction. Then what are the benefits of a smart contract? So this actually includes the benefits or features of the blockchain also, because smart contracts are running on top of blockchain. So basically, direct dealing with customers. We are having a peer-to-peer network, and smart contracts also enable us to directly deal with our customers or directly deal with each other. So if it is a trade between houses, then the owners and the other party can directly deal with each other. Then it is resistant to failure, because even if one node or two or three or node goes down, it still runs. The network will still run. It's immutable. Any data that we write into the blockchain is immutable. It fraud due to that fact, it is fraud reduction, and it cost efficiency, because we are all sharing that. We are all having a shared purpose in that, so it will reduce the cost, and basically it is immutable. That means any data that we write into that will be kept forever as long as we want. So record keeping is one part of that. Then let's look at it in a technical aspect. So smart contract is actually self-verifying. Like, basically, if you put some data into that and you have written enough conditions for that, then it will look verify those data and put that into this thing. And self-executing, it doesn't need any external interaction or something like that. Once it's started, it will finish all the transaction related to that. So in a technical aspect, or even in a, even in someone's mind, that's very interesting options actually. So basically, you don't really need anyone else's manual interaction. You just need to say to do some actions and it will complete. It is tamper resistant due to the fact that it is written on an immutable ledger. So that will reduce malicious or accidental events also. And it is deterministic. That means every outcome at any time period will be fixed or it will be deterministic. And in an economical aspect, it provides us transparency, right? So transparency means we don't really redo things, or we don't really need to do any other things, and then it reduces intermediaries, and comparatively it has less transaction cost if you like compared to other blockchain technologies or other technologies that exist at time. Then in a legal aspect, yeah, so it can automatically control the execution. It can document any events that happened during this particular execution, and it can predefine a set of conditions, and the actions will only happen within that set of conditions. Then if implemented correctly, we can also provide that security for that particular contract. I mean, that based on the implementation, and it's distributed. So any outcome that happens due to that smart contract execution can be validated by everyone, because it's happening in a publicly visible or transparent ledger, and it's actually immutable. That means no one can like, oh yeah, I did this and I want to remove that. That thing happened without the concerns of the community. Then if you want, the participants involved in the contract can be anonymous, only the participant can be only known to each other. Like if I am transferring something, then I'll be able, obviously I'll be able to know that other party in the real world, but anyone that is looking in the network won't be able to know who did this transaction. So that's a good thing. Then this is actually a bad and good thing nowadays. There are no regulations, like there are no people that is there to keep an eye on what is happening. The same like the anonymity. So that's actually a pro and con. I mean, in some cases it might turn into a pro, and in some cases it might be con. Like if people started using with these things, this kind of application with malicious intent, then anonymity can be a pro. Can be a con. And in case if it is used by a genuine person, then that can be a pro, because people can really get my private details, so that can be a pro. And just like that, regulation, there are no regulations on the use of blockchain, so that can be a con. Like that can be, I mean, in some aspect that can be a con. Like anyone can create any kind of application on top of blockchain, so it has to be like there are no legally no legal bounding to those kind of things. Like that is happening within the network, and that is happening with the concerns of the participants that is working on that application. So that can be a pro and con in, based on the circumstances. Then yeah, we've seen all the necessary things that are for this. So like the pros and some cons, but these are not the only cons that are available to that is affecting the smart contract. The first thing is that smart contract can only be enforced on digital assets. Basically the Ethereum computer is in a digital world, right? So for example, I'm trying to transfer my house ownership to someone else, and in the digital world I said that happened, but I didn't even after transferring the ownership, I didn't vacate the house, or I didn't do the actual procedure for that. So any process that happens within the actual world or the physical world cannot be constrained using the smart contract. That has to be done using some other mechanisms. So if you can completely convert an asset into a digital form, then that's okay. Then you can like control all the transaction or all the ownership details regarding that into this. But this is actually a limitation of the actual contract also, because after I sell the house and I don't move, then yeah, you have to go some legal ways on all those things. But yeah, technically speaking, a smart contract can be only enforced on digital assets. And yeah, the blockchain network is decentralized, but it is not legally regulated. There is no legal constraints that is happening on the blockchain network. That is actually the aim of the blockchain network, but that can be sometimes a con for that or a limitation for that. Yeah, just like I said before, even if the smart digital asset the assets are digitally enforced, then the interaction of that assets in the physical world cannot be constrained by the smart contract. And basically speaking, the smart contracts are some constraints implemented using if-else statements, or it can't really implement any sophisticated variations of things. Like it's basically it's a if-else statement and storing data, and they're controlling the storage of data, or controlling the retrieval of data, or controlling some kind of things using some conditions. So if you need a much more sophisticated things, then that has to be there are workarounds, but that has to be hard to do that. Now, yeah. So finally, before ending my talk about smart contracts, I will just need to go through the development phases of a smart contract. So it is similar to developing any project. Like not only the development project phases of smart contract, it is closely related to decentralized application, because the decentralized application becomes a decentralized application when it uses the smart contract. So you have to first think of the product. I mean, that's the first thing. You have to go create a product map, like the release date, the development date, the customers who will be receiving these things. I mean, everything related to market research, all those things. Then you have to do a usability research, like just like the market research, who will be doing this thing, or who will be the audience for this particular application, those kind of things. Then you have to design the architecture of the smart contract. What will be the functions, or how will it govern the transactions, or yeah, those kind of things. Then the development phase, you make a team, or you appoint another company to do your smart contract development. Then it goes through manual testing and unit testing, those kind of things. Then if you are not like, if you want more security, like smart contract is actually developed by the human, right? Human makes mistakes. So if you want to make sure there are no mistakes, then you can like give it to another company. There are like third-party companies that look for common mistakes, or many mistakes that happen during the development of smart contract. They will audit and correct it for you. And then if even if it is not enough, then you can like conduct a bounty program, like a bug bounty program, and then you can go through another finalization of smart contract. Then finally you can store that into your Ethereum blockchain computer, sorry, Ethereum web computer, then execute that as part of your decentralized application. So finally, let me just give you guys a brief introduction about the architecture of the decentralized application. So basically, I mean, there are different variants of decentralized application. Simply saying an application, a normal application that is running on top of the decentralized network is called a decentralized application. So it will be using, it will not only using this decentralized network, like it will not only be using the Ethereum network or the smart contract, it will be using every other thing, like the database, the hosting platforms, every other thing alongside the blockchain technology. I mean, we can't really only use the blockchain technology in some applications. In case of some applications, we can only use the blockchain technology, but in real life use cases, we have to use a mix of these technologies. So basically, you will have the Ethereum blockchain technology, and on that you have already deployed the smart contract, which can be accessed using a wallet. So basically speaking, wallet, I mentioned that there will be some kind of a login mechanism to the Ethereum web computer, some kind of credential mechanism, right? So that credential mechanism will be managed by something called wallet. And some application might access via the wallet, or some application might directly access the blockchain network without the usage of wallet. Or some blockchain network clients might have the wallet included in them. And your client could be a desktop client, a mobile client, or a web client that is hosted on a decentralized platform or a centralized platform. Sorry, a distributed hosting platform or a centralized hosting platform. Then, yeah, there are many other variations, like a desktop client that access a server-side client that is hosted on a centralized or hosting platform, then that access a blockchain network. There are many other variations, just like our normal web application or normal application that is currently we are developing. But the only thing is that only change is that we will be using a blockchain alongside the that already using databases or some kind of thing. Now, these are generally the things, the stuff that I want to talk about the Ethereum's journey or the Ethereum. So to summarize, we have something called Ethereum world computer, basically one big computer for the entire world. That was the concept in which Ethereum was built on, where you have a business idea, you can code it and deploy it to the Ethereum world computer, and you can run it, and every audience will be able to access that particular computer. That was the dream. I mean, that was the dream that we are building towards the Ethereum computer. We have still achieved it completely. Like we have some issues like scalability, all those things, but in the future we will definitely achieve that. So let me show you guys a demo of a decentralized application, how that interact with the Ethereum blockchain network, all those things. So yeah. Okay, so let me just introduce you guys to this application. So basically, this decentralized application is for issuing certificates. So there will be two actors. One will be the issuer, and the other person will be the candidate who will be able to view their certificate. So simply imagine this as a stripped down version of KBA's Sati chain. The Sati chain application is an application where we actually issue our certificates for the different courses, such as a certificate blockchain associate, certificate Ethereum developer. Those kind of courses certificates will be issued on blockchain, and the product is called the Sati chain. So you guys can go check it out in our KBA website. So this is actually much stripped down version of that particular thing. So there are two functions that we can do using this thing. The first one is to issue a certificate. So basically you can issue a certificate by selecting the particular course. Then you can view that particular result also. Let me just confirm one thing. Okay. So basically, if we are creating an application that is fully relied on the full uses almost all the potential, I can show everything, but this thing actually uses a wallet to manage the credential to the Ethereum network. So you will have
Sorry to interrupt, and then your screen is not visible. Could you please share it?
No. Okay, let me check. Can you see my browser now?
No, not yet.
Hello?
No, and then we can't see your screen.
Okay. Like, is it black or something like that? I mean, what's happening here?
No, it's like stuck.
Oh. Okay, so let me just log out and come back.
Yeah.
So hi, I'm back. So let me just share it again. Can you see it now?
No, not yet.
It was okay during the time slide was playing, right?
Right from the demo, there was a problem with your screen.
Oh. Maybe. Okay, let me just check. So is it visible now?
Oh, and then it seems some problem. It's just showing that you started sharing the screen, but it isn't visible.
How about now?
No, please check your internet connectivity. Is there any problem with the bandwidth? Because in between it, it was
Okay,
displaying as
so
low bandwidth.
yeah, maybe I'll just restart my computer and come back.
Yeah, thank you.
Hello, Anju. Can you see my screen? No?
Yes, now it's fine.
Oh,
Go ahead. Thank you.
okay. So, yeah, let me just introduce it again. So, this is actually a step down version of the Satichain version. And here we have two options, two methods, two features. Yeah, two features. One is to issue a certificate, and the other is to view that particular certificate. And I'm using something called MetaMask. So yeah, MetaMask is actually a wallet that can be used to control my credential to the Ethereum network or Ethereum computer. Okay, so let's So simply saying this is actually my account that's can be similar to the username or username that you use to log into Google or Facebook, and it was corresponding password, but that will be managed by MetaMask, and that will be only stored in my computer. Basically, if you close it or delete this instance of MetaMask, then you have to restore it using other mechanisms. Okay, so I'll be using this wallet to interact with the Ethereum network and the Ethereum computer. Then I'll be using something called Etherscan, which is actually a block explorer using which you can explore all the contents or all the actions that is being performed within the Ethereum network. So I'll show what will happen when I interact with the Ethereum network with using these tools. Okay, I hope that this thing works completely. So the first thing is to log in or connect using MetaMask. So let me just go ahead and do that. So basically what happens here is that I am connecting my particular account via MetaMask. So anything that happens within this decentralized application will be using my account. So remember when I said that terminability feature of Ethereum Well Computer, it had a fee meter, right? A cost. So doing anything within the Ethereum network, and those things are called transactions. So like if you write a data, that is called a transaction. You read a data, that is also called a transaction. So for any transaction, there will be a set amount of cost only for the write transaction, not for the read transaction. So for any write transaction, there will be a set amount of cost, and I am telling that to use this particular account to for that particular cost. So yeah, let me go ahead and connect to this particular site. So I am now connected to my site is running on localhost 3000. So I'm connected to that particular site using that particular account. So my site has access to this account, and it can do actions based on that. So next, let me issue a certificate. So yeah, I'll just enter a certificate ID, KBA, CBA 101, and this was actually issued on this particular amount. So basically the course name, certificate ID, the candidate name, the particular amount grade that occurred, and the issue date. So issuing certificate, that is actually a write transaction into the blockchain network. So it will have to do some operations within the Ethereum network. So you need to have a particular cost for that. So this will be the actual cost that is needed for doing this particular transaction. So just confirm that. And it will take a little bit of time. If you go into the MetaMask, you can see that there is a pending transaction. And if you go into the Etherscan, Etherscan takes a little bit of time to read that particular transaction. So let's just wait. Maybe the transaction will complete before the Etherscan reads that. Yeah, the transaction is complete. Let me just check the yeah. So over here, you can see what happened when I did that transaction. So this is a transaction hash. So whenever a transaction happens in the Ethereum network, you can see a unique ID will be generated for that, and using that unique ID, you can retrieve that transaction, the data corresponding to that transaction. Everything will be there. And the status, basically, it says that it happened. The transaction was successfully carried out. and in which block it was happened, and when it happened, and from which account to which other account. So basically, both any scripting language, we were calling this smart contract. So that contract will also have some kind of credential, but that will be managed by the code that is associated with our smart contract. And for from account, that means my account, the account that I used, and to this particular contract, I didn't send any ether value, but I sent some data. Like to decode the input, you have to have the corresponding smart contract. But yeah, so this is the number of transaction I did from this particular address, and gas used for the cost for that particular transaction. So like for it is I mentioned that it is like represented in ether, like 0.001 ether, but you can see another amount here. That is because it's mentioned in way, which is actually the smallest denomination of ether. Like for example, for rupees, we have something called paisa, right? Like 1 paisa, 2 paisa, like 100 paisa is 1 rupees or something like that. So just like that, for ether we have something called way. I mean, there are so many denomination, but the smallest denomination is way, and everything is expressed in way internally. Everything happens internally, it will be expressed in way, the gas cost, the fee, or everything, something like that. And this fee is called gas cost or gas. And yeah, so this is basically the inputted data, the all these things, the course name, certificate ID, the candidate name, Anju, everything is shown as the input data. This is actually encoded into, it's actually the encoded form. If you have the correct decoding mechanism, then you can decode that. Yeah. Then if we go back and yeah, let me just copy the certificate ID. Try to retrieve that certificate. Then you can see who that certificate is for, and you can see all that data corresponding that. So this is basically how a decentralized application simply works. So whenever you want to issue a certificate, you need to provide that particular certificate details regarding that certificate, the name of the candidate, the grade, and these are actually all the data regarding that certificate. But whenever you issue a certificate on blockchain, so why the blockchain has a transaction cost or transaction fee is that basically, you guys may be remembering about the torrent networks, right? Yeah, so I accidentally clicked it. So in the torrent network, whenever I mean, usually we use the torrent network to download cinemas or films or something like that. So people that use the torrent network always use it to download some content, but that content need to be hosted by some peer, right? So the number of peers that host this content are very low in this network. So basically, people take from the network and are not willing to give into the network, because why? Downloading gives you a benefit, right? You will be able to view or use that particular download content. But if you upload, it will be a waste of data, all those kind of things. So within the blockchain network, people can do transactions. So if you make the transaction fee, then people that verify the transaction might not get anything. So people will not verify the transaction, only people will do transactions. So people will do the transaction, no one will be there to verify the transaction. That means every transaction will be having the status pending. So if you have a transaction cost, and that cost will be given to those people that verify and vet these transactions. So that's why we have a transaction fee within the Ethereum network. Then the other thing is that if you don't have transaction fee, like anyone can do many transactions. Like I send zero either to Anju or some other colleague of mine, and I can do this an infinite amount of time if there is no cost. So that is why one is to avoid spamming, and one is to encourage people to verify the transaction that is happening on the blockchain. So that's why we have a transaction cost. Then we confirm, like we send, we collect all the data we need, and when we create a particular transaction, build a transaction, then to execute that transaction, we need to specify some either or some cost for that, for the execution of those operations. Then we confirm that, and here I am like simply using this MetaMask wallet to do that, a wallet using which you can interact with the Ethereum network. And I can see the transaction that happened and the details regarding that. And we can explore that in this network also. So the another thing to mention is that here I am using the Ethereum network called Ringcup. There are different Ethereum network. The one is called main network. See, this is actually the main Ethereum network. I mean, this is where the ether has value. Like one ether is actually amount to almost 2000 USD. So this is a network where ether has value, and all these other network are test network. So using this MetaMask, I can like seamlessly connect within different networks. So currently I'm connected to Ringaby network, so that I mean it's a demo purpose, right? So I can't really spend real either, and so you can use the test networks to do that. And if you have an application, you can like first deploy into the test network, like satisfy with its working condition and all those things. So currently all of the networks are not really working well. That's why I use the Ringaby network. Then one important curious thing I want to show is that the zeroth block or the genesis block, whenever you commit a blockchain, the zeroth block is called the genesis block. And I told you that the when crowdfunding happened, the people were promised either for giving money, right? They have around 14 million. They amused like they received around 14 million for their crowdfunding, and these are all the transactions that in which they have given out the ether corresponding to the cash that was given by the community. So you guys want to go ahead and you guys can like explore the Ethereum network using Etherscan, and you can interact with the Ethereum network using MetaMask. And yeah, so yes, that's basically a simplified implementation of Sati chain, where you can like go ahead and issue a certificate and retrieve the details regarding that certificate. So yeah, that concludes my presentation. Thank you guys. Any questions or something like that?
Thank you, Antam, for the beautiful presentation. Audience, if you have any questions, please type them in the chat box. Thank you, Antam. We don't find any questions. So shall we wrap the session?
Yes, thank you.
Okay, thank you so much for joining. Thank you. Welcome back all. Next we have with us Lakshmi MD. She's a blockchain trainer and research engineer at Kerala Blockchain Academy with more than 2 years of experience in the blockchain domain. Her area of interest includes Hyperledger Fabric, Hyperledger Soto, and Hyperledger Indy. She is also an active contributor to the Java community with a prior experience of working more than 3 years in the Java development domain. On behalf of KB Women Connect, I extend my heartfelt gratitude to you, Lakshmi, for sharing your knowledge on Blockchain Bootcamp for Women. With no further ado, over to you, Lakshmi. Thank you for joining once again.
Thank you, Anju, for giving me this opportunity. Am I audible, Anju? Okay. Let me share my screen. Anju, I'm not having the permission to share my screen. Yeah, letting me come. Okay, this session is about Hyperledger Sawtooth. I think after attending all these sessions, you all have got, you all have understood the basic concepts about blockchain technology. Is it? And you also heard about Bitcoin, Ethereum, and all. Coming to Bitcoin and Ethereum, they are actually public blockchain networks. Public blockchain network means anyone can join the network, can do transactions, and can participate in consensus and all. That is, there is no restriction on participation. But such type of a network is not suitable for an enterprise-based or business applications, because most of those business applications are meant for a particular group of people. So as you all know that this blockchain guarantees various features such as it is decentralized, it is distributed, it is immutable or tamper-proof. Means the data or transaction that is written into the blockchain is permanent. It cannot be altered. And also there are many other features such as it is traceable, it is transparent, and the system is cryptographically secured and all. So due to this wide variety of promising features, many organizations wanted to implement their product or applications using blockchain technology. And many started research on developing a solution for building blockchain application in a permissioned environment. And here comes this Hyperledger. Hyperledger is actually an open source collaborative effort that aims at that focuses on developing solutions that are suitable for business enterprise grade blockchain deployment. This Hyperledger is hosted by one of the world's leading open source community, that is Linux Foundation. So under Hyperledger, it is not a single project. Under Hyperledger, you can see multiple projects, not only projects like various frameworks, tools, libraries are available under this Hyperledger. So we can call this Hyperledger as an umbrella project, or we can call it as a greenhouse. Then coming to its objectives. The main Hyperledger aims at building blockchain solutions such that it will it will be very much cost effective, and also the complexity should be minimum. Then only people will adopt blockchain technology. So in the case of Ethereum and all, you may have seen that Ether is needed for executing transactions. That is, there is a transaction fee and all for executing the transactions and all. So, but in the case of business operations, there are a huge number of transactions will be there. So it is not feasible to pay a transaction fee for each of these transactions. And also coming to the complexity, in the case of Ethereum and Bitcoin, you may have seen that they are using a consensus algorithm called proof of work. So in the case of proof of work, there is a concept called mining. Mining means like miners are separate nodes that which are creating the blocks. So in order to create a block, these miners have to needs a high computational power for solving a cryptographic puzzle. So such type of complexity is not suitable for a business and business or enterprise based applications. And also coming to the case of enterprise compatibility of blockchain systems. This hyperledger focuses on developing solutions such that the various blockchain systems should be interoperable. That is, different organizations have different kind of requirements, and this hyperledger focuses on developing solutions such that it satisfies most of the features that are required for an enterprise application. And also it should ensure enterprise compatibility between different blockchain systems. Then coming to the third point, um, in Hyperledger there is an open technical governance structure which actually proposes various rules or protocols or tools that should be followed, frameworks that should be followed in enterprise applications, so that it allows interoperability between the various blockchains. Then here is the website of Hyperledger, that is www.hyperledger.org. And in this site, you can see what all latest developments are happening under this Hyperledger world. And you can also see the various associate members. That is, Hyperledger actually started with very few member companies, like about 30 member companies were there, like during its initial stage, that is during in 2015-2016 period, there were only very few member companies such as IBM, Intel, R3, Consensus, and Monax, Soramitsu, and all. But now you can see that there are more than 250 companies are partner to this Hyperledger, and they are also actively contributing to this Hyperledger world. And you can also see that KB is also a learning partner of Hyperledger. And all the projects that comes under this Hyperledger is open source. That is, its code and all everything is available in GitHub. So we can use this code. We can go through the code and all. And if we are finding any issues or we are finding any problem at any point of stage, we can post the issue with the concerned team, and they will be looking into it. And we can also suggest some modifications also to this Hyperledger, to the various projects under this Hyperledger. And there is a technical steering committee is there, which will go through all the proposals and all. And if it is a valid proposal, they will be publishing it under this Hyperledger. So in this figure, you can see the various projects under. You can see the various projects under this Hyperledger. They are mainly classified into distributed ledgers, libraries, tools, and domain-specific projects. Distributed ledger means they are actually platforms that can be used for developing various enterprise-based blockchain applications. I think the term distributed ledger is familiar to all of you, is it? Like distributed ledger means the ledger is distributed among all the nodes in the network. That is, every node will be having a copy of the ledger. Ledger is actually a means for recording the transactions. So that is the term distributed ledger. And coming to each of these distributed ledger, the first one is some of these like you can see that many about almost 16 projects are there under this currently under this hyperledger, and some of them are still in incubation. That is, initially the project will be submitted as in incubation mode, and later after final testing and all it will be production ready. That is, its stable version will be released. So here you can see that Fabric, Indie, Iroha, and Sawtooth are production ready. That is, its stable version is available, but all other projects are still in incubation. Then coming to each of one, the first one is Hyperledger Besu. Hyperledger Besu is actually a Java-based. Hyperledger Besu is actually a Java-based Ethereum client. Ethereum client means like it is actually like in the case of Ethereum network, to become a node in the network, we need Ethereum client and all. So this Besu actually works as an Ethereum client, and this Besu actually supports both permissioned and public blockchain network. Then coming to the next project, next framework, that is Hyperledger Burrow. Burrow actually supports Ethereum. That is, it provides a permissioned environment for running Ethereum smart contract. As you all know, that Ethereum is actually meant for a public blockchain network. But if you want to run Ethereum smart contract in a permissioned environment, we can go for Hyperledger Burrow. Hyperledger Burrow provides a permissioned Ethereum virtual machine for running these smart contracts. Then coming to Hyperledger Fabric. Hyperledger Fabric is one of the widely used framework for building various business blockchain applications, and it was introduced by IBM, and there are so many real world projects are also running in under this Hyperledger Fabric using Fabric. So many use cases are also available over internet, and so many real world applications are also running on Fabric. Then coming to Hyperledger Indie. Hyperledger Indie is a project mainly for managing digital identities. So which is based on it is actually based on a concept called decentralized identity. And also there is a one more term is there, that is self-sovereign identity. Self-sovereign identity means the user have the control of managing his own identity. So these are some of the terms related, some of the features or some of the concepts related to Hyperledger Indie, and mainly used for managing the identity in a secured manner, that too in a decentralized manner. Then coming to Hyperledger Iroha. Hyperledger Iroha is actually a simple project that can be, if we want to convert an existing application into a blockchain application, then we can go for Iroha, because this Iroha is actually having a simple architecture, so that we can easily incorporate it into an IoT based or other infrastructure applications. And Iroha also provides various Android and iOS libraries for developing mobile-based blockchain applications. So, in order to, if we want to develop some mobile applications using blockchain technology, we can opt Hyperledger Iroha. Then coming to Hyperledger Sawtooth. Hyperledger Sawtooth is also another framework that can be used for developing various business applications in blockchain technology, and it supports both permissioned and permissionless network, and also provides support for Ethereum smart contract. That is, it can run Ethereum smart contract in a permissioned environment through a separate transaction family called Ceph. So in this section, actually, I will be taking in-depth detail about this Hyperledger Sawtooth. So before starting Hyperledger Sawtooth, let me sort of giving you an overview or idea about this Hyperledger projects and various tools and libraries coming under this Hyperledger. And then coming to the various libraries, we have Hyperledger Aries. Aries actually provides various shared and reusable interoperable toolkit that are needed for managing identities. Like in the case of blockchain applications, uh, they are the case of permissioned blockchain applications. It give more importance to identity. That is, only those with valid identity are allowed to do transactions in a permissioned blockchain network. So Aries provides the libraries that are needed for managing this identity. That is, for storing or for creating for sharing the digital identities. We can use the libraries that are available under Hyperledger Aries, and also it provides a wallet for storing the keys. That is, in the case of blockchain, mostly user will be having a public private key pair and all are there. For in order to managing the accounts, they need they will be having a private key and public key. So in order to securely keeping the private key and public key, the Aries provides wallets for storing the keys. Then coming to the next library, that is Hyperledger Quilt. Hyperledger Quilt is actually mainly for inter blockchain communication, or it is actually a Java implementation of this interledger protocol. That protocol is mainly used for communicating between different blockchain networks. Then coming to Hyperledger Transact. Hyperledger Transact provides the libraries that are needed for running the transaction. That is, for executing and processing the transaction. Or we can also say that it provides an environment or platform for executing the smart contract. That is because in smart contract, we will be specifying that how to execute the transaction and all will be defined in the smart contract. So the transact module actually deals with executing the smart contract and also processing the transaction and all. Then coming to Hyperledger Ursa. In blockchain, you may have seen that various cryptographic concepts are used. Like, for example, there will be signature generation, that is digital signature. Then signature verification will be there. Then key generation. Then encryption, encoding, hashing. So many cryptographic functionalities are used in most of these blockchain projects. So in order to implement these cryptographic functionalities, this Hyperledger Ursa provides the libraries needed for implementing these cryptographic functionalities. Then coming to the various tools under Hyperledger. So the first one is Hyperledger Avalon. Avalon actually provides an execution and secured execution environment for transaction execution. That is, it has come up with the idea of executing the transaction outside the blockchain, that too in a secured manner. So mainly the main objective is to improve the scalability and also to improve and also to achieve more confidentiality. So that is why if the transactions are executed outside the blockchain, we can increase the scalability and also it guarantees much more confidentiality and all. So Hyperledger Avalon provides the platform needed tools. It's a tool that support transaction execution or transaction processing outside the blockchain. Then coming to the next tool, that is Hyperledger Cactus, which is mainly for inter-blockchain communication. So that is, if some data or some value has to be transferred from different blockchain networks, then we can use the tool Hyperledger Cactus. Then coming to Hyperledger Caliper. Caliper is actually a benchmark tool for performing the for measuring the performance of a blockchain network, and the various performance parameters that can be measured using Caliper are such as resource consumption, that is how much of memory or CPU is needed. And then next one is that the transaction throughput, that is how many transactions can be executed per second, and also transaction latency, that is how much time is taken to execute a transaction. And then success rate, that is how many transactions are successfully executed or how many transactions are failed. So all these parameters can be measured using Hyperledger Caliper. Then coming to Hyperledger Cello. Cello actually provides a blockchain as a service. That is, it provides a dashboard with which we can check the status of the blockchain, status of the network, and also we can easily create or start or stop or delete a blockchain network using this Cello tool. Then coming to Hyperledger Explorer. Hyperledger Explorer is actually mainly for viewing the in-depth like blockchain details about the network. That is whether block creation or are block creation and all are happening properly. That is, if we want to know that how many blocks have been created and what time each block has been created, and if we want to know that how many transactions are there in a block. So in order to explore all these details about the blockchain, we can use Hyperledger Explorer. It is actually a web application. Then one more is there, that is a domain-specific project, which is called Hyperledger Grid. Hyperledger Grid is actually, it provides the libraries, tools, and all that are needed for developing a supply chain application. Supply chain is actually one of the popular use case in this permissioned environment. So in order to manage or create a supply chain application, this Hyperledger provides all the tools or libraries needed for building a supply chain application. So these all are a brief description about the various projects, that is various distributed ledgers, libraries, tools, and the domain-specific project that comes under Hyperledger. Now let us look more detail about Hyperledger Sawtooth. Hyperledger Sawtooth is actually a framework or platform that can be used for building or deploying or running distributed ledgers, and it actually follows a modular platform or modular architecture. Means like each functionality, each functionality will be managed by different modules. So if we want to add some updation, if we want to update some module, we need to modify only that particular module. So Hyperledger Sawtooth is a modular platform for building, deploying, and running distributed ledgers. Hyperledger Sawtooth was initially contributed by IBM. Let us see the project line of this Hyperledger Sawtooth project. Hyperledger Sawtooth, this Sawtooth project was started in the year 2014 at Intel Labs, and initially its name was Sawtooth Lake, and later in 2016 the Intel has contributed this project to Hyperledger, and then its name has been changed to Hyperledger Sawtooth. And Intel also introduced a consensus algorithm called proof of elapsed time consensus algorithm. So and also and in initially this project was under incubation, and in 2018 January they have released the first stable version of Sawtooth, and in December they have released the next version, that is Sawtooth 1.1, and the latest version, that is Sawtooth 1.2, is released in the year 2019, and it is the currently available stable latest stable version of Sawtooth. Now let us look at the salient features of Sawtooth. Sawtooth. So the first one is parallel transaction execution. So in Sawtooth, there is a parallel scheduler in which allows in which it can execute independent transactions parallelly. That is, it can more than one transactions, that is more than one independent transactions can be executed parallel. It is mainly to increase the scalability. Like for example, in the case of Ethereum, and all, you may have seen that the throughput, that is the number of transactions that can be executed per second, is only about 15 to 16 transactions per second. And in the case of Bitcoin, it is only about 8 to 9 transactions per second. But for a business or enterprise-based applications, we need to execute a large number of transactions in a short time span. So for that, they have come up with the concept of parallel transaction execution. So if there are independent transactions running at the same time, then they can be executed parallelly. But if dependent transactions are coming, we have to execute it serially. Then coming to pluggable, it supports pluggable consensus. That is, in Sawtooth, Sawtooth supports different consensus algorithms such as POET, that is proof of elapsed time, then RAFT, and one more is there, that is PBFT, that is practical Byzantine fault tolerance consensus algorithm. So Sawtooth supports different consensus algorithms. So pluggable consensus means, like, based on the requirement of the network, we can change the consensus. That is, we can plug and play. That is, it is possible to change the consensus algorithm of the Sawtooth network by submitting some transactions. And the next point is, it supports on-chain governance. On-chain governance means, if the Sawtooth network is running, we can change the settings by submitting some transactions. That is, for example, we can change the consensus algorithm, or we can change the permissions of certain nodes, or we can do some other settings. Like if any settings have to be done, changed, we can do it on chain. That is, without stopping the network, we can change the settings. And also all these settings values are stored in the blockchain. And hence whatever changes we will be, whatever settings we are changing, it will be applicable to all the nodes in the network, because all the settings data, that is settings data transactions, will be stored in the blockchain, and this blockchain will be available with all the nodes in the network. So this concept is called as on-chain governance. That is, Sawtooth supports on-chain governance. The next point is multiple language support. In the case of Ethereum, you may have seen that the developers need to study a language called Solidity for developing Ethereum applications. But in the case of Sawtooth, they provides SDKs. SDKs are available in Python, Go, JavaScript, Rust, Java, and all. So that it is not needed for the developer to study a new language. So he can develop a sort of application in any of these languages which he is comfortable, because there is this like very stable running SDKs are available. SDKs are available for running a Sawtooth application. Running, not only running, for building a Sawtooth applications. And the next feature is that Ethereum contract capability. That is, it supports Ethereum smart contracts. Under Sawtooth, there is a project called Seth, which can run Ethereum smart contract in a permissioned network. So that is why we can say that it provides Ethereum, it is Ethereum contract compatibility. So apart from these features, the Sawtooth provides other common blockchain features such as it is decentralized, distributed, it is traceable, it is transparent, it is auditable. So all those features are also there. And one more feature is also there. In the Sawtooth, there is the cryptocurrency. There is no cryptocurrency, and also there is no transaction fee concept, and all is not there. So and also mining complexity is also not there in this Sawtooth. So instead they are using a different consensus algorithm. So these are the various features of Sawtooth. Now let us look at the various consensus algorithms supported by Sawtooth. The first one is proof of elapsed time, that is POET. It is actually a Nakamoto style consensus algorithm, means a lottery based consensus algorithm. And this POET consensus algorithm is suitable for large blockchain network. We can go for this POET consensus algorithm, and this POET is introduced by Intel. And the next consensus algorithm is DAO mode. DAO mode is actually a consensus algorithm that is suitable for developers. That is for development purpose or for testing purpose. The developers can use the DAO mode consensus algorithm, which is a simplified random leader algorithm. Then comes the Raft and PBFT. They both are leader-based algorithm. And in the case of PBFT, but we can use it only for smaller networks. Like PBFT and all can be used only for smaller networks. But if we are defining an application that should be run for a larger network, we should go for POET consensus algorithm. So these are the various consensus algorithms supported by Sawtooth. So let me explain how this POET consensus working. So in the case of POET, a random waiting time will be assigned to all the nodes in the network, and the node which actually waits for the minimum waiting time, will be selected as leader. That is for the node that is the node which has completed the waiting time first, means that is the node which has got the least waiting time will become the will be selected for proposing the block. And also this particular winner has to provide a proof to other nodes that it has waited for that much particular waiting time, and also it has received the minimum waiting time. So this is how the POET consensus algorithm is working. Now let us look at the various components of Sawtooth. The first one is client. So the user will be interacting with the network through this client. So client provides interface between the user and the network, and the client also is responsible for creating the transaction. Transaction means, like here in a blockchain, like we can call any process or any activity can be called as transactions. Like not like it does not refer only for money transactions. We can any process can be called as transaction, like user registration or user like so many like user registration, or like in the case of consider the case of a land registration application, where we can say that the user registration or land ownership changing, like all these processes can be considered as a transaction. So the client in the Sawtooth is responsible for creating the transaction. So the transaction for Sawtooth is actually required in a particular format. That is, there will be a transaction header, a header signature, a payload, and all will be there. So the transaction, creating the transaction will also be, transaction will be created by the client. Then comes the transaction processor. This transaction processor is similar to the smart contract. That is, the business logic is actually defined in the transaction processor. That is, how to execute the transaction will be mentioned in the transaction processor. Then coming to the validator. Validator is the main component, like which actually validates the transaction and will also block creation and all will be done by this validator. Then come to the sawtooth network. That is, if there are multiple nodes in the network, then it will form a sawtooth network. Now let us look at an architecture, or we can say it as a workflow. So here at the top, we can see an expanded figure of a single node. So at the bottom, it actually shows a sawtooth network with about 5 nodes, and a sawtooth network with 5 nodes is actually shown at the bottom, and one such node is actually expanded at the top to view the components of this components of that sawtooth node. So here you can see that there will be client, and the user will be submitting a request to this client, and the client will be create the transactions, and it will submit the transaction to the validator through REST API. REST API actually acts as an interface between the client and the validator. So the client will be submitting the transaction to the validator through REST API. Then validator will initially validates the transaction. That is, it will check whether it is having a valid signature and all. And if it is valid, it will give the transaction to the particular transaction processor for processing or executing the transaction. There will be multiple transaction processors will be there for various functionalities. So based on the type of the transaction, or we can say as based on the transaction family of the transaction, it will send the transaction to that particular transaction processor, and the transaction processor will validate and execute the transaction. And based on the consensus, this block will be created using the various transactions, and the block will be added to the blockchain. So this is the basic workflow about this sawtooth. I'm not going to more technical details because some of you may be new to this concept. So that's all about sawtooth. Now let us look at a sample application using sawtooth. So for that, I will show you a simple sawtooth application. We have an application named as Simple Wallet. It is actually a simple or basic simple sawtooth application with the functionality that a user can deposit money, can transfer money, can view the balance and all. A simple application with minimal functionalities. So in order to demonstrate a sawtooth, this application, this is Simple Wallet. Its name is Simple Wallet, and this application is available in GitHub. You can clone it if needed. I will share the link. So this is the command. So this is the, I have shared a chat. I have shared it in the chat. So this is where we can access, from where you can access the simple ballot application. So git clone is the command for downloading this project from the GitHub. It takes time, so those who are interested, they can do it later. I will post all the commands that are needed for running this application in this chat. So for running this application, first go into that folder and run a command called. For running this application, we actually need Docker. Docker is actually a software platform that is needed for Docker is actually a software platform that is needed for running or deploying or shipping various software applications. So it actually packages the various libraries or various dependencies that are needed for running the application into a single package or into a container, and we can run it easily. Like a separate environment will be created for running our application. So we are using Docker for running this particular application. So here is the you can install Docker from this website. I will share the link. This is the link for the first link is for installing Docker engine, and the next one is for installing the Docker Compose. So both are needed for running a Docker application. So here, let me open this application. And here you can see that there is a file called simple ballot build client by YAML. That is a YAML file is there, where actually we will be defining all the containers. That is, in the case of sawtooth applications, we need a transaction processor, we need a client, and there will be a REST API will be there, and then a validator is there, and also one more transaction processor is there, that is settings transaction processor, which is actually needed for doing all settings. In order to change settings and all, we need a settings transaction processor. So all the separate containers are created for all these components, and when we are running it using Docker. So the command used for running this file is so this is the command sudo docker compose -f and the file name, that is simple wallet build client.js, and up, which is the command. This is the command for running that YAML file. So the password is, since I have used sudo. So now it has started creating all the containers that are needed for running this sawtooth applications. So you can see that the validator, processor, settings transaction processor, REST API, all are starting. So if you are running it for the first time, it will take some time to run all the containers. Let me post the command there in the chat. This is the command for running the YAML file. I think now it has started all the containers, that is client, validator. Then you can also see that Genesis, in the terminal, you can also see that Genesis block is created. So when we are creating the blockchain network, it actually, initially there will be no blocks. So the first block created in the blockchain network is called as Genesis block. So for starting the network, it actually created a Genesis block, and this is the block number, and its block number is 0. And here you can see that there is a previous block ID. In the case of Genesis block, there is no previous block. So hence we can see the value 000 as the previous block ID. And so many other details are also there. So after studying the main sawtooth concepts, you will understand that what all are displayed over here. And you can also check that what all containers are running there using a command called docker ps. So let me open another terminal. And give the command sudo docker ps. This command actually gives all the containers that are running now. So here you can see that there will be a simple wallet client is there, REST API, then settings TP, then transaction processor, validator. So all our containers are running down now. Now, as I said before, this simple wallet application is actually a simple application, simple sawtooth application, mainly with functionalities such as a user can deposit money to his account, and also he can transfer money to another account and can also view the balance. So, in order to, since it is a permissioned network, we have to create an identity, that is in blockchain applications. Normally for managing identity, they are using a public private key pair is used. That is, every user will be having a public key and a private key. Like public key private key is almost similar to the concept of username and password. So username is similar to the public key and private key is similar to the password. So first we have to create so before that, I need to enter the client container. Then only I can create the users. So this is the command for entering the client. And now we can create a user. Let me create two users named Jack and Jill. So this is the command for generating the public key and private key for the user. That is, sawtooth keygen is the command used for creating key pairs for. So now you can see that a private key and a public key file has been created. Localhost 3000. So now you can see that our application is running. So we have just now we have created two users, that is Jack and Jill. So give the name of Jack. So you have loading. Before that, let me show you some details about blockchain. For that, let me open my Mozilla and give the localhost. So in order to view the details about the block, there is a URL called localhost 8008/block. Actually, this is actually the endpoint of REST API, which we are using here. blocks is the endpoint used for accessing the block details. And here you can see that we have only created one, there will be inside this block, we can see only one single block, that is block 0. So this is actually the Genesis block, that is only one block has been created. So now we are going to do some transaction, that is in our application, let us deposit some money. Let me deposit 500 rupees. So we can see that a transaction has been happened. So now let us look into the, just refresh it, and you can see that now there are two blocks have been created. That is, the first one is the one which is listed at the bottom will be the Genesis block, and the last one, the one which is at listed top will be the current block which has been created. So since we have done a transaction, it has created a block. By looking at the terminal also, we can see that like you can see that another block number 1 has been created, and there is a previous block ID is there. That is, it is actually the hash of the Genesis block. So previous block ID, then so many other details are also there. I am not going to much detail. So this is how a Sawtooth application running, and this is how we can view the blogs, and this is how the blogs are created. Now I think the time is getting over, so let me stop. So in order to stop this network, just press Ctrl C. So these containers will be stopping, and after completing, you should give the command. After everything, every container has been shut down, let us give the command docker compose down command is given. So once giving this command, it will stop the network. So this is the last command which need to be given. So once you are free, you can try it out. You will get the code from the GitHub, and you can clone it and try out these commands. So that's all about the demo. And thank you. If you are having any questions, you can post it there in the chat.
Thank you, Lakshmi, for a good presentation. Audience, if you have any questions, please drop in the Q&A. Okay, thanks, Lakshmi. I think we don't have any questions. Yeah. Okay, thank you once again for sharing the Hyperledger sorted session. Thank you. Thank you. Next, we have with us a very beautiful, talented blockchain developer, Adinushree. She's a next graduate of the Kerala Blockchain Academy. Anushree is currently working as a blockchain developer analyst at ULTS. On behalf of KB and KB Women Connect, I extend my warm greetings to Anushree and thank you for joining us, for sharing your experience being a blockchain woman. Over to you, Anushree.
Hi everyone, very good evening. First of all, I would like to thank the entire team, uh, the bootcamp team for giving me such a wonderful opportunity to share my experience as a blockchain professional. So if I look back now, the path was not that much easy. There was a lot of challenges, obstacles, and so on. But I'm happy, like I gained a lot of tremendous experience and a vast knowledge. I actually started my career as a Java developer after completing my BTech in electronics and communication. But I was not satisfied. There was no job satisfaction, and I really want a job change. So as a beginner, it was really hard for me to determine exactly what career prospect will be interesting for me. So it was all about a confused state. So I shared the same with my dad also. My dad, he is the one who actually introduced me blockchain. So he was like, Anira, why can't you try blockchain? So blockchain itself, like that terminology itself was new for me. I never had any contacts who was working in blockchain. I completely had no idea what's a blockchain was. So he himself shared me the ABCD program link, that accelerated blockchain competency development program. He shared me. Then he was like, okay, it's up to you. You can choose your career. So actually, I really take a chance. I thought, then I resigned my previous job, and I enrolled myself in ABCD program. Then I done my basic full stack developer course from ICT Academy, Calicut, and later I joined KBA for my blockchain certifications. So when I joined KBA, my knowledge level in blockchain was zero. I never had any idea about blockchain. Yeah, it's true that I have googled about blockchain. I have came across some YouTube videos, but if I it was, I was in a point zero. It was in a point zero level. I started from KBA. So in each and every sections in KPA, I learned a lot of things. I learned a lot actually. Even I confused a lot. Even I wanted a lot. Maybe it will be same for all the batchmates in, I mean, my KBA batchmates also, because we never had a previous idea about blockchain, because I was talking this maybe 2 years ago. No, it was in 2018 time. So in each section, but one thing I would really appreciate is like all the KBA mentors, they had a lot, no, they had put a lot of effort, explaining each concept clearly. They were always helpful. They were really patient. They had a lot of patience level. I should really appreciate them. They were really calm, composed, and they were crystal clear about the concept when they were dealing with the students. And we used to have that practice sections, just like Lakshmi ma'am was explaining you. We used to have that practice sections. So the main headache during that practice section was bug. There was a lot of bugs actually, because we were doing it in the first time. So definitely we will be getting a lot of bugs, and we had a couple of mentors assisting us, but I never saw them hesitating to extend their helping hands, and they were always there with us. So gradually we all came into a track. We started enjoying the sessions, the discussions, the works. Even we started enjoying the bug fixing also. So I think my KBA days have given me a lot of confidence and contacts. Thanks to my KBA mentors for that. After my certification in Hyperledger O2 and Ethereum, I joined the UL Technology Solution. From there, one thing was like I was the only female member in that in the ULTS blockchain team. So actually, I started dealing with real industry from there. I started attending, client discussion with business analysts, then technical discussions with the architects. So I was getting a lot of exposure there, truly speaking. But one thing was really hard was like with dealing with blockchain thought leaders. Because when it comes to thought leaders, they think that everything is possible in blockchain, but we know we have some limitations. So convincing them which is the best blockchain use cases, which is not. It was really hard, and it have taken a lot of efforts, both blockchain developer efforts and even business analysts were working hard to convince them. And the second issue was like, maybe our clients know a particular blockchain. So for example, maybe they know Hyperledger, or either they know Ethereum. So what they do is like they started comparing Hyperledger with Ethereum. It's like misconception. So clearing that misconception also was a little bit, we actually need a lot of effort for that. So as a developer point of view, after a few discussions, I came to know that, okay, our company, UL Technology Solutions, all the clients are preferring Corda for blockchain projects. So I started learning Corda. It was self-learning. So I was thinking, okay, it will be better if KBA will announce at least one blockchain Corda certification. Why they are not announcing? Thank God, luckily, KBA announced their first batch without any delay. I joined the roles also. For me, actually, my hometown is in Calicut, and my work location was also in Calicut. So it was really difficult for me. It was really difficult for me to, travel to Trandrum, because KBA was conducting the sessions at Trandrum. At that time, there was no online sessions. So I used to travel from Calicut to Trandrum every weekends. Friday and Saturday, I used to attend the sessions here. Then again, Monday, I used to join my company. So it was hard, but it was my need, and I had to do it. I have done it. During the development phase, both difficulties was like, for us there was no good project for reference. It's our first production project is all about the R&D works we have done. It's like we have googled a lot. We have followed the official documentation. Since our first production project was in Corda, we followed R3 Corda official documentation. Then whenever we got stuck, we used to ask our doubts in Corda official Slack group. Many times, we left with no reference. Even we tried, we tried multiple POCs just to find which is the better way of implementation. So during that time, the R&D time was really hard. But but every day we had something new to break. So once we break the challenges, we have a self-satisfaction kind of thing. And the other important, difficult case was like production deployment. Usually for a production projects, we used to have four environment. One will be dev environment for developers, then one will be QA, quality assurance, then UIT, and production. So usually we have to host our projects in these four environments. Uh, on all other projects other than blockchain, DevOps team used to take care of this. But what happens is like, since our DevOps team was not much aware of that Corda deployment or blockchain deployment, we developers was in charge of doing the DevOps also. So and it again came to me. So I never had any idea about how to work in Azure or AWS. So I learned that DevOps part also. Then for first production project, I have done my Corda deployment in this four environment. Thankfully, the all team I worked with was very supportive. My manager was so supportive. So when we went to the second project, we had a very good discussions with the manager, and a manager assigned me to DevOps guys. So we worked together. We actually worked day and night, because there was he suggested us like, why can't you try CIC? Why can't you create a CI/CD pipeline to do Corda deployment? So it was hard actually, because we never had any reference for that. But we three was there, so we worked hard day and night, round the clock, but we achieved it. So it actually reduced my developer effort or deployment effort to 5% actually. It was a huge achievement. So one thing I would like to tell you, like, first you should have you need a very good base. If your base is good, you can construct. So I really got that very good base from KBA. I'm very thankful for all my members and the mentors in KPA. I really got a good base from here. Then you should have a very passionate team. If you have a good team to work with, you can achieve. It is, I'm not telling like you can achieve in your first try. Maybe you have to do 10 times or maybe 50 times, but you are definitely going to achieve it. So the balance, first base, then a team, the balance part, it's all up to you. How hard you work, how smart you work, how much you are ready to extend yourself, how much you are ready to come out of your comfort zone. So it's all up to you. If you are ready to do it, definitely you can. If I can, definitely you can. uh, so so from my experience, I would like to convey that initially, uh, all the tasks, I'm not talking about the blockchain type, any task, it will be difficult because we have never done it, so it will be difficult. But once you find the solution for the particular task, it will become very easy. You please keep learning, you please keep trying, you keep trying until you crack it. You achieve your dreams, whenever if you get it, self satisfaction. Self satisfaction is very important. And once you get it, it's good. So I think, thank you so much for listening to me. There is nothing more that I can convey from my experience. Thank you so much. I'm concluding my words. Thank you.
Thank you, Anishashri. That was a beautiful, motivating talk. And thank you for joining us on this 2-day free blockchain bootcamp organized by KB. Apart from what you said, do you have any piece of advice to our aspiring blockchain audience who are attending this session? Would you like to say something more? Any hacks or something which can be helpful for them in pursuing their blockchain career?
Yeah, I do. Actually, when it comes to a blockchain project, it is not completely, it will not be a completely blockchain project. You will have an ADM or application development team also. You will have either UI UX team, or you have a middle layer working on Java, Python, etc. So you should have a very good contact with these people. Maybe you may don't know who is going to help you, because when I was telling you, the deployment part, DevOps part, there was a lot of things I learned from them, which I was not aware. Because usually, for my case, we never had a tech lead on blockchain, but actually my application development tech lead helped me a lot. So it is not like we are focused on blockchain. It is nothing like you have to learn everything. You only have to learn everything in blockchain. You should have to learn Java. If you get an opportunity to learn new things, please do. Please do grab the opportunity. Make sure you have a very good understanding about the industry, what is going on. As I told you, initially when I joined that company, I was supposed to assist business analyst, which is not my, as a developer, I'm not supposed to do, but it actually gives you a lot of confidence. So if you are getting an opportunity to work with business analyst, you should, you will learn things from them. Then I actually business analysts used to do BRDs, so I actually assisted them to develop BRDs, TDDs and all. So if you get a chance, you work with them. It is better you will first become a full stack developer, and you shine in blockchain. So better first become a full stack, then you can shine in blockchain also.
Thank you, Anishri. That
Thank
was
you.
a great thing. Okay, thank you once again for joining us on this auspicious day. Okay, wish you all the very best from KBA on your future endeavors. Thank you once again. Bye-bye. Take care. Next, we have with us Lakshmi R. Devi. She is a former research engineer at Kerala Blockchain Academy and has been active participant in the research and development activities of KBA during her tenure with the organization. She has been a trainer at the Hyperledger blockchain framework for the past 2 years. Also, she has over 6+ years of experience in social media handling and blockchain domain, adoring different hats, including blockchain developer, JavaScript developer, blockchain consultant, full stack developer, and digital strategist. It's a great honor to have Lakshmi Devi today with us on this 2-day blockchain bootcamp organized by KBA. On behalf of KBA and KBA Women Connect, I extend my warm greeting to Lakshmi for joining us today online. Lakshmi, am I audible to you?
Hi, Anju. Am I audible?
Audible. I'm sorry for the technical glitches and sorry for keeping you waited for long.
It's fine. It's fine.
Yeah. Thank you. Thank you
Yeah,
once
is
again
it
for
audible
joining.
now?
Yes, it's
Yeah, or
yes.
my fan making a lot of noise.
There seems to be a little echo, but still,
Okay.
yeah.
I will switch off the fan. Okay. Okay. So can you hear me now?
Yes, absolutely. Go ahead, Lakshmi. Thank you.
Okay. So I'll start sharing my screen. So thank you, KBA and Anju, for this wonderful opportunity. So I'm glad to be a part of the team and to share you guys something on Hyperledger Fabric. So let me share my screen first and so are you guys able to see my screen?
Yes, absolutely. We can see your screen. You may please go ahead.
Okay. So today I'm here to explain on Hyperledger Fabric. So you guys have seen all the projects under Hyperledger umbrella, just like Hyperledger Indie, all those Hyperledger Sawtooth. You have seen Lakshmi explaining Hyperledger Sawtooth, right? So I'm just going a little bit brief into the Hyperledger Fabric. So so we have a time limit, I think. So I'll go quickly. Okay. So you guys may know that the Hyperledger Fabric as a DLT framework implementation, that is a distributed ledger technology framework implementation. So you might know that this Hyperledger Fabric is basically used in business scenarios, mostly used in business scenarios successfully. And it is initially contributed by the Digital Asset and IBM. So the Hyperledger Fabric is initially developed by IBM and it is contributed under the Hyperledger umbrella under Linux Foundation. So it is now open source and it is a well-maintained project under this Hyperledger Foundation. So let's move on to the features of the Hyperledger fabric. So unlike private networks, unlike public networks, the Hyperledger fabric is a permission blockchain network. So what is meant by this permission blockchain network? So there should be some permission mechanism, right? So that you can get into that network. Unlike the public network where everyone is a participant, everyone shares the ledger and everyone shares the same copy of the ledger and everyone can easily jump into the network. The permission blockchain network or the Hyperledger fabric, which is a permission blockchain network, needs some permission to join the network. You cannot directly jump into the network and make some transactions. So it is a permission blockchain network, and there should be some authority which can give the permission, which is dependent upon who who deploys the network and how the configuration settings are. So that is a permission blockchain network. That is the first point or the first feature of the fabric network. And next one is chain code can be written in standard programming languages, Go, Node, and Java. So you guys might be familiar with the Ethereum network, and where there are a lot of dApps developed using the Solidity language. So the idea is to create such a platform so that people can go around and write applications using all these languages like Go, Node, and Node.js and Java. So the Hyperledger fabric gives this ability to write applications using Go, Node.js, Java, etc. So the next feature is no cryptocurrency and no mining. You have heard that it in the previous session by Lakshmi, that there is no cryptocurrency in a private blockchain network, and hence there is no mining. So why is it happening? Let us just go inside a little bit. So it's like there is no cryptocurrency, right? So why there is no cryptocurrency? Why there is no mining? So what happens in a public network? If you're considering Ethereum or any other public network, what happens is the miners are managing the network, right? So they are mining some transactions. So they are getting rewarded for that transaction, for mining that transaction. And this in this way, that network is like managed. So in private network, there is no cryptocurrency associated with. So there is no mining. So what if there is some miners in the private network? So if there are some miners in the network, they should be, if we are going to reward them in cryptocurrency. So is there any value for that cryptocurrency outside that network? Let's think that way. So there is no value for that, it might be invalid outside that network. So there is no cryptocurrency associated with any permission blockchain network, and like there is no mining. And the next one is offers the ability to create channels. So that is a major feature of permission blockchain network or the Hyperledger fabric here. The ability to create channels. So what is a channel? We know that it can be a path, right? So a channel is basically a connection or a way in which you communicate. So let's consider an example. So there are, we are considering an example of manufacturers and dealers. So if you consider there is a manufacturer M1 and dealers D1 and D2. So you are giving some product to the dealer, you are the manufacturer, you are M1, and you're giving some product to D1 at a value like maybe $500. And you want to give the same product to D2 at $400. So what if it is in a permission, public network? All the participants in that network can see what the amount is, or you are giving it to 500 for that D2, D1, and they are giving it for D2 at a reduced rate, right? You don't want that. And a manufacturer will know, like they won't be wanting that to be seen by other dealers. So by creating this channels, the feature of privacy is included in the permission blockchain network. So it is like creating a channel between M1 and D2 so that the M1 can sell his product at a reduced rate without the dealer D1 knowing about this. So the D1 is in the same network, but he will not get to know that the M1 is giving at a reduced rate for D2. So that is the ability to create channels. So we'll see what is it in the next slides. The slide explains what is multiple channel. So just like I said, the channel is like a method of communication or a path of communication. So here, if you see, there are like 3 participants, A, B, and C, right? So the participant A and participant C are making a private channel, AC. So whatever happens in that particular channel will stay on that channel only. The other participant in that network, like B or D, they will not know anything about what happened inside that private channel between A and C. So there is confidentiality in the transaction between the members of a particular channel. If A and B are making a separate channel for their communication also, the C, who is not a part of that communication or that channel, will not be knowing anything about that communication that happened in that channel between A and B. So there is confidentiality and privacy of data using channels, private channels in the network, which is a good feature of the private permissioned blockchain networks. So I hope you guys got the idea of channels, and we have seen some features of the blockchain, of the private or permission blockchain. So I just forgot to mention something like these, the facility to create private channels between A and C or A and B, or like create multiple channels. The ability to create that makes the Hyperledger Fabric app for a business scenario, and that's why like most of the blockchain adoptions in business scenarios is on Hyperledger Fabric nowadays. And let's move on to the components of a Fabric network. So there are like mainly 3 components, that is a membership service provider, peers, orderers. So as you can see in the slide, there are membership service providers, that is in this part, and there is the orderers and the peers here. So what is a membership service provider? A membership service provider, you guys will understand it from the name itself, right? The membership service provider. To be a part of the network, just like I said, nobody can jump onto the network directly without having a permission in the permission network. So for having a membership, for getting into that network, they should be having some proper membership. So they should be a part of the network by some identity. So the membership service provider will help the user to get the permission to join the network. So that's about the membership service provider. And then we have the peers. There is, in bracket, you can see endorser and committer. Those are like 2 roles of a peer. What is a peer? A peer is just like a node in the Ethereum network. So just like a node in the public network, we call the nodes here peer. So It has two roles, endorser and committer. We'll get back to that at a later point of time. So peers are just like notes on, it is nothing but used to, sync your ledgers. Then you have the orderer. So next one is the orderer or the ordering service. So the job of the orderer is to mine your transaction. As we said earlier, we don't have a miner in a permission blockchain system. So the orderer is doing that job. So you guys can just look into this diagram. You have the client application or the client SDK and the membership service provider here, and the ordering service and the endorser committer peers here. So every identity that participates in the network should every entity that participates in the network should identify itself, right? So the membership service provider, what it does, there is a term called certification authority in Hyperledger Fabric, which is, we call it CA, or the certification authority. So the certification authority, what it will give is some identities. What the MSP does is to associate that identities with some entities in the network. So I hope you guys got the point. So there is a certification authority in the network, and the certification authority will provide some certificates, or they will provide some identities, and the membership service provider or the MSP will associate those identities with some entities in the network. So this can be some digital credentials. Basically, it provides, the CA provides some digital credentials that you can use to identify yourself in the network, and this thing is associated with some entity in that particular network, and they must be well associate these certificates or the identities that is provided by the CA with that particular entity in the network. So that is basically the MSP does is like associating the identities with the entities in the network. So it is, the MSP is just like some kind of folder, and when you have access to the folder or directory, you can consider it as a directory, and when you can access to that directory, you can associate these credentials with all the components that is part of the network. So you can go through the slide points. I'm not going through all this. I'm just giving a brief about the the architecture of the Fabric network and how the transaction is flowing through the network. So that is MSP plus CA. And next we have the peers. So what this peer does is, the peer manages the ledger which consists of the transaction log and the world state. So as we have seen earlier, like in this slide, we have seen like endorser and committer, right? So there are two roles for a peer. So every peer in a network is a committer. So consider a network where there are 15 peers. So all these peers are committers, and there should be some endorsers. So what the endorser does is, they execute the transaction and generate a RW set, and endorsement policy describes the condition by which a transaction can be. Oh, okay, sorry, okay. So I'll explain it like in simple words what an endorser does. So there should be, just like we are getting endorsing in LinkedIn networks and other things, we for a transaction to get committed, there should be some proper kind of endorsement that is given by the peers in the network. So the entire set of peers is called the committer, and some of these are called endorsers. So some of these are configured as endorsers, and these peers should endorse some transaction to get it committed to committed by the committer. So that is here the committer, it commits transaction. That is the thing that the committer does. So the endorser, which will endorse the transaction. So which will be having an endorsement policy as well. So there will be some policy, and the endorser will endorse with that policy, and the committer will commit the transaction if it is properly endorsed by the endorser. So that is a peer, and that is the roles of a peer, the endorser and the committer, which is like some important roles in the transaction flow. So just like I said, consider that you have 15 peers in the network, and there should be at least like some of the peers, consider 7 peers configured as endorsers, and all these peers are committers, and 7 should be configured as endorsers. Like whenever a transaction is made, this endorsers will make sure that it is having this, it is endorsed properly. So yeah, that is what a peer and the endorser and the committer, those terms. The next one is the order. So you might have seen in public networks, the entire computation, then transaction of the blocks, etc. Everything is done by the nodes or peers, right? So the peers are responsible for all these computations and transferring of blocks, etc. But there is a difference in the private or permission network or the Hyperledger Fabric here, because in Fabric they have divided these loads into multiple entities, just like they have the peers, they are executing the transaction and creating the adding the transaction to the ledgers. So the peers, all the peers will, what they will do is they will execute the transaction, they will add the transaction to the ledgers. And then we have the orders. What the order will do is the order will take the transaction and they will make a block out of it and broadcast this to the peers in the network or the other entities in the network. So basically the order is what the order is doing is they will get the transactions, they will create a block out of the transaction, and they will distribute the transactions in the entire network. So basically the order helps to broadcast the blocks, just like in a public network. So in public networks, it is done by the peers, all the peers in the network or the nodes in the network. And here we have divided the load between the peers and the orders. Okay, I hope you guys understood these components of the fabric, that is Hyperledger Fabric components, that is the membership service provider, the peers, which has 2 roles, the endorsers and the committer. The committers, which is the common role of a peer, and endorser, which is like will provide an endorsement for the transaction coming through and which is getting committed by the committer. And there is the orderer or the ordering service, which makes blocks out of the incoming transactions, and they will distribute the blocks among the peers. So those are the components. Let's have a look at the transaction flow of the Hyperledger Fabric. Okay, so there is the client application or the SDK where the end user interact with the network. So there is the membership service provider plus CA, and there is the peers where the 2 roles, endorsers are there, the committers are they're also there, the ledger, chain code events that are all resides here, and there is the order or ordering service. So the client application, which is the like we we are using a lot of applications, right? So that is just like the client application, which is used to interact with the network. So there is this MSP plus CA, which makes sure that the user has the identity to participate in that network. So what it does is, first this will get the entity will get enrolled, and then a transaction proposal is sent to the endorser. So what this endorser does is, one second, okay. So there is the endorser. A transaction proposal is sent to this endorser. What this endorser does is, the endorser will execute the transaction, and it will reply with the endorsed response along with the transaction. So they will execute the transaction. There is a transaction proposal which is sent from the client application to the endorser peers, and the endorser will execute the transaction, and along with this endorsed response, it will respond. So the transaction proposal is created from the client application or the SDK, and the endorsed response is received back at the client end, right? So along with this endorsed transaction details, the transaction is submitted to the orderer. So that is what this says, submit transaction. So along with this endorsed response, the transaction is submitted to the orderer. And what the orderer will do is, just like we have heard earlier, the orderer will take out the transaction, makes some blocks out of the transaction, and distribute it with the peers. So the orderer is responsible for building the blocks out of the transaction. Then it will distribute it to the network in the form of blocks. Take the transaction and distribute it in the form of blocks. So what the committer will do is, it will commit the transaction. But for committing the transaction, for that particular transaction, or for getting that block to commit, they need a proper endorsement. So it will check whether it has a proper endorsement done from the endorser side. So the endorsed response is there. So it will check for the proper endorsement, and these transactions have, if the transactions have endorsement, proper endorsement, and they will verify it before committing the transaction, and it will get committed or committed to the ledger. So that is the entire transaction flow in that network. First, there is an enrollment that is happening, and there is the transaction proposal that is sent from the client application end to the endorser. So it will respond with, it will execute the transaction, and then it will respond with the endorsed response. And the client application will receive it. It will submit the transaction along with the endorsed response to the orderer. The orderer will create blocks out of the transaction, and these blocks will get sent to this committer, and the committer will make sure that there is proper endorsement from the endorser side for this, and the commit is done to the ledger. So that is the entire transaction flow in a Hyperledger Fabric network. So if you guys have any doubts, you can ask in the chat box. I'll be like, you have a demo just after this. Let me check the time. Sorry.
Lakshmi, don't worry about the time. We have like buffer time of 15 minutes.
All right, Anju.
Thank you.
So, yeah, this is the, I hope you guys got a basic knowledge about the membership service provider, the peers, the orders, all are the participants in the network. and the transaction flow in the network. So we have a demo just after this, like explaining how this actually works in the real time. So Anju, that's it from my side. I hope you guys got the idea. I hope you got the basics of Hyperledger Fabric.
Thank you, Lakshmi.
Yeah.
That was an absolutely brilliant presentation of basic tool on Hyperledger Fabric. I think we have a question in the Q&A.
Yeah, sure.
From Aparajita.
Can I take it offline? I'll definitely take it offline. You guys can go ahead and for the demo part, I'm not able to see the chat.
Okay, I'll read the question for you if you want.
Okay, all right. Okay.
The question is from Aparajita Pandey. She's asking like, can we use a Hyperledger Fabric for peer-to-peer trading for the exchange of energy and money?
Oh, okay, I got the question. I got the chat box. Okay. Can we use the Hyperledger Fabric for peer-to-peer energy trading for exchange of energy and money? Definitely. We actually the Fabric, the use case of Fabric or the business scenario of Fabric is like a wide range. You can use a private network for this if you want. Like I think there are some examples that is in the real-time projects that is done by KBA, not on this exchange of energy and money, but there are some real-time projects done by KBA on this, and you can definitely have a look at the projects done by KBA team, and you can definitely go to GitHub and look for some examples for business cases or business scenarios, just like the trading of things, and definitely like I'll just explain some examples that I have recently gone through, like the auction networks, the private auction networks. That is the recent one I have gone through, and wallets. Recent one is like for trading of something like exchange of money and energy, not energy in that case, something else. So all these can be used in the Hyperledger Fabric can be used for all these purposes. So if you want to have something like a channel or some permission, that is that is where the Hyperledger Fabric can be adopted. Like if you are like open to all, and just like a public network, you're open to the ledger is open to all, and you don't have a problem with that. Like there is no like higher authority thing or some confidential data between some people. In that case, you can use public networks. Otherwise, if there is just like the financial business, where just like Anjashree said, the CODA is adopted, we can use Hyperledger Fabric as well. Like in that kind of cases, I'm not saying instead of CODA you should use Hyperledger Fabric. It is like a different scenario. But in the cases where you want to create some private channels between the people participating or the entities participating or the peers participating, you can use Hyperledger Fabric.
Okay, there are two more questions, Lakshmi.
Yeah.
One question is there any scalability issue with respect to transaction in Hyperledger Fabric?
Yeah, there is. I won't say scalability issue. It is there, but so the basic problem, I'll explain what are the problems that is related to, or the problems that is coming when you adopt a private blockchain or the Hyperledger Fabric. The first thing comes into picture is the implementation cost itself. So when so in nowadays it's like a show off, like to show that you have added blockchain or the Hyperledger Fabric in your project, so that you get a hype. So it is, you can say that it is developed in blockchain, and all these things I've done is in blockchain, you can say that. But the problem here is when it comes to the adoption, if it is not the proper use case, if there is no need for blockchain, you don't have to use the blockchain. That's it. So it's like you don't have to stuff that into the technology thing you are working on. You don't have to stuff that. You can use the normal database, just like other MySQL or any other database you use. You don't have to stuff this Hyperledger Fabric or any other thing to the use case. So the implementation cost is a problem. It is a problem in the case of, and what maybe like in the transaction per second is a case, and the the cost of implementation, just I said, the Azure, the cost of blockchain platforms in Azure or the IBM blockchain or the Oracle is a little bit high, like maybe $800 or $900. So it won't be like reasonable. So in the case of scalability, I'll say I won't say Hyperledger Fabric is not scalable, but there are definitely some issues. But it is an open source platform. But every other Hyperledger enthusiast is working on that issues, and they are like making it appropriate every day. They are increasing this, like trying to increase the scalability or trying to keep on to that open source platform thing every day. So everyone is contributing towards it, and hope we can like see in future the Fabric will be a huge thing in the case of private networks. I hope so. Anju?
Okay, yeah, the next question is there any consensus mechanism in endorsing process?
Yeah, surely. There is some consensus mechanism associated with the endorsements. So basically the PVFTs, or you might have heard about all the consensus mechanism, RAFT, PVFT, all other proof of work or proof of stake, all these consensus mechanism. And in Hyperledger Fabric, PVFT or RAFT, all these things, all these consensus definitely contribute to the endorsement policy or the endorser section. So there is a consensus mechanism in the endorser section.
Okay, we have a last question. Is Hyperledger Fabric better than Sawtooth with respect to its security features?
I'm not like sure about this. Like in the case of security, definitely Hyperledger Fabric being the second one after Sawtooth it came. So it definitely has the advantage over the Hyperledger Sawtooth. In the case of the architecture or the complications in the network itself. So I guess it has an advantage, but Sawtooth is also a good development, a good contribution in the case of private networks. But I will say in the case of business scenarios, or in the case of real-time adoption, it is better to use the Hyperledger Fabric. Anju?
Yeah, thanks, Lakshmi. Thank you for sharing your precious time with us on this today Blockchain Bootcamp. Audience, I guess if all of your questions have been answered by Lakshmi.
Anju, if there is any question, I can definitely take it offline. You can, connect with me on LinkedIn. I'll be there to answer your questions, and you can definitely connect to my email ID as well. If you want to, you can get this recordings or the slides from Anju. You can share the slides, right?
Yes, we will share the slides for the participants.
Yeah. So if you have any doubts or anything, you can definitely contact me. Okay.
Thank you. Thank you,
Okay, Anshu.
Lakshmi.
Thank you
And
for the
audience, if you have
opportunity.
any questions, please continue posting in the chat. We'll take them offline. Okay. Thank you once again, Lakshmi, for joining us
Thank you,
today.
Anshu. Thank you,
Take
Anshu
care.
and
Bye.
KK
All
for
the
the
best.
opportunity.
All the best.
Thank you,
Bye.
Anshu. Thank you. Bye.
Audience, stay tuned to the small demo on the Hyperledger sorted. Sorry, the fabric.
Hello, am I audible?
Yes, Sandeep, you're audible.
So, hi all. Hope you have all like gone through this brief introduction of Hyperledger Fabric. So we'll just go to a small video of, sorry, a demo of this Hyperledger Fabric. So basically, I would be explaining you the demo of a generic supply chain application. So as you all know, I'll just make it short because we have some time constraints. So basically, we have the major roles in this section, that is producer, shipper, retailer, and customer. And we have a regulator who is able to control all these things, like just to see whether things are all like going right. So so this is basically our application. So first, a retailer will order a product from a farm, like just say a mango farm. Once the order is received in the producer side, they just confirm the order and they just assign a shipper to the for the product, and the shipper would ship this item to the retailer. And once the item is received to the retailer confirms it from their side. So in this application, a customer can view the history of the products that he or she has bought using a unique order ID. And we have a regulator who can see all the transactions and orders that has happened in the chain, so that he could regulate and see things what's happening over there. So we'll just go to a quick demo of the application. So basically, I'll first log in as a retailer who is Walmart over here. So I'll just log in. So the retailer has the privilege to create an order. So we'll create an order from Mango with price 10, quantity 10, and we'll assign the order to GH Farm. So it's a farm that produces mangoes. So I just created the order. Okay, so we can see the order over here. Now I'll just go to the producer's login page. So once the order is placed, a producer can accept the order, and after accepting the order, it's a little slow. Yeah. So after accepting the order, the producer can assign a shipper. So in our case, we have a shipper with a name DHL. So I'll just assign the shipper over here. Yeah. Once we have the ship and package, now we have to log in back as the Walmart or the retailer and just accept the order. Sorry, shipper. Yeah. So the shipper has the privilege to create the shipment and transport the shipment. So I'll first create the shipment. So when the shipment is created, I'll just transport the shipment. So as you can see, the order has been order is in transit. Now we can go to the retailer's dashboard and we can just accept the order and we can change the status to delivered or received. So we can see the receive shipment option. So as you can see, the complete life cycle of the supply chain, Manco supply chain. So I'll just log in as a customer. So before that, I'll just copy that. I'll first log in as a regulator. So a regulator can view the complete history of the order. Uh, so, as you can see, the complete history of the order. So a customer can only view the history once he had this order ID, which should basically be uh, attached to the product that he buys. So, yeah, so you can see once the customer searches for the product with the order ID, he can see the complete history of the product that he got from the retailer. So, so that was a short demo on Hyperledger Fabric. So, yeah, so that's it.
Thank you, Sandeep. Thank you for the beautiful demo. Audience, if you have any questions, can you please type in the Q&A. Hope you have got a real overview of how a Hyperledger Fabric will be in a use case. Hi everyone, now we are moving to the last session of the 2-day free blockchain bootcamp for women organized by KBE. To conclude the event, we have with us an eminent spokesperson of Hyperledger Blockchain, a futurist technology transformation leader, none other than Marta Piazza. She's a director of ecosystem at Hyperledger. As her role at Hyperledger, Martha has evangelized the technology and open source at the conferences around the world, helping enterprises in applying the technology of the permission blockchains in their different use cases. She has early served as a head of the enterprise collaboration at the Cambridge Blockchain Society, also the member of the technical governing body Board of Trustees at Sovereign Foundation. It's a great honor to have Martha on the 2-day International Blockchain Bootcamp for Women organized by KBA. On behalf of KBA and KBA Women Connect, I extend my warm greeting to you on this day, ma'am.
Thank you so much.
Thank you. Thank you for joining. She'll be keynoting on Hyperledger. I think you have come in the right time because in the previous session, we had a lot of questions running on the Hyperledger. I think the audience will be benefited from your talk too. Okay, so with no further ado, over to you, Martha. Go ahead.
Wonderful. Thank you for having me. Thank you for this honor. I wish I could be with you in India right now, although, as you can see, there is sun outside, at least a bit. For me. I will share my screen and show you a couple of slides. I would like to make this session as interactive as possible. I have no ambition of going through all of my slides. So if you'd like to interrupt me and ask questions, you are able to raise your hand, as I believe, and you can type in your questions in the Q&A. So if it's possible to get people that will want to ask questions to kind of enable them to speak so that we can have some kind of a more human interaction than just reading questions, that would be amazing. But with having said that, let me just start with my slides. Can you see my slides?
Yes, we can see your slide. Go ahead now. Thank you.
Wonderful. Yeah, so, I was asked to talk to you a bit about Hyperledger and how to get involved with Hyperledger. And my main mission here today is to have you walk away with understanding that everybody's welcome in Hyperledger, and this is a very inclusive community. And speaking of, International Women's Day and empowerment and all that, I think that I am proud to be part of this community because it's such a focused on exactly those values, exactly on that. As a matter of fact, we have far more female employees on Hyperledger staff than we have male. So Brian Bellender, our executive director, definitely puts his actions where his words are and really tries to embrace the empowerment and equality and all those virtues. So we have the statement or the motto that all are welcome in Hyperledger, and we try to not only say it but also make it happen. And that means that we want you. And if there is a tiny itch of you wanting to get involved, understand how to be part of Hyperledger, and I'm guessing that's one of the reasons why you were listening to this presentation, that is a good itch, and you should be making it less or scratch it and get engaged and see that there is a space for you no matter what you're doing, no matter what's your background, your knowledge. Feel confident that your help is needed and your contributions will be welcome. What does it mean actually to be inclusive? If you look at the dictionary, inclusive means including everyone. What does it mean to include? It means to take or comprise as a part of a whole or group, right? It means that every single individual becomes part of a bigger group, a bigger structure. And we do think of everybody that's participating in Hyperledger as those individuals and as people that have their unique experiences, backgrounds, and so on, but also have an amazing way of building a community that is much bigger and much stronger, and that united we do build something much better than individually working on our little projects. But the truth is that people do not stay in the community unless they feel empowered, engaged, and included. Uh, and that is a big challenge of building open source communities. How do you make sure that participants, or passers-by that just want to wander in and see what a project is about, in our case what Hyperledger is about, how do they actually stay involved and feel that they are part of this community? In Hyperledger, we have very strong principles. First and foremost, we are 100% open source. This means that our community is not pay to play. You can contribute, you can participate, you can join any of the special interest groups or working groups without paying anything, without being an official member. As a matter of fact, we didn't even build an individual membership status in Hyperledger because we believe that anybody that just brushes against Hyperledger, comes to a single event, should consider themselves a member of Hyperledger community. Hyperledger is also led by technical contributors. So while we have a lot of opportunities to get engaged and learn how to further contribute on the technical level for non-technical people, the final part, the way to become a leader in this community is to contribute in technical ways. That doesn't necessarily mean building code. Quite often it is just writing out specifications or helping with documentation, but there has to be some kind of technology aspect to your work. A great example here is Bobby Muscara, who is on our technical steering committee. And I don't think Bobby ever written a single line of code in her life. She runs a training company, but she's been very actively helping create training material and leading the learning materials working group to the point where we recognize, or the community recognized, that she would be a very valuable addition, a human addition to the technical steering committee. But it's only those who do are the ones who get a leadership position in Hyperledger. There is no way of buying yourself a spot on the technical steering committee. There is no way that you can just come in and throw money at developers and say, now from now on you'll be working on these or that feature. It's all about who you are, what's your merit, and how does community recognize you as an individual. So why get involved? Well, what would be the reason why any one of you here would want to be involved? First, you can shape the direction of a project to fit your needs and use cases. Very often, I talk to people and I hear, oh gosh, I wish Hyperledger sort of supported something, PBFT. And all I can say, well, if you don't work on that support, why would you expect other people to? You have the power to shape the direction of the project, but it's also your responsibility to come up with features and to come up with direction if you want to shape the project. You also, from a company perspective, decrease time to market and accelerate the work of the project and what you want sooner. Because there are so many people working on the same thing together, and you get a beautiful collaboration of companies that might even be competitive in outside world. They all work together to support the development of the code base that then becomes the base of their products. And that's a very important part of open source. It's the concept of increased return on investment, because there's always a certain level of initial work that has to be done for every company. Now, if we work together, everyone can work on a slightly different piece of that puzzle, and together create the final solution. If we work separately, you know, maybe there is a bit of competitiveness, so we put more pressure on each other. But at the end of the day, it's very wasteful, very resource consuming, and just pointless. Why would I work on the same thing as a colleague of mine as you do if we can work together and just together come up with a better solution? There's this very nice saying that with enough eyes, all bags are shallow, meaning that the more people look at the code, the more people actually try to pressure test it, the easier it gets to build a code that is actually flawless or as close to flawless as possible. And I must say, we see that every day with our bug bounty program. We have a very liberal, very rich bug bounty program where you can actually find bugs in your code, in Hyperledger code bases, and get paid for it. So if you really want to have a fun side hustle, you can just analyze the code and get paid for bugs you find. But as it turns out, there are not many bugs that people find, because there are so many people who test the code, that work on it together, that do all of the audits and so on before it sees the daylight. That there are not many bugs to be found. And if there are bugs that people find, they are usually quite minor, thankfully. And you know, it can change. Maybe it's not enough people or not enough incentive for people to pressure test the code, but for now it seems to be working. Also, you get to learn a lot. It is very different when you work alone on a code, and I'm sure that having studied or having been students, you know that very well, that it's different to sit there on your own and try to solve a problem, even with the best workbook. And it's different to have a study circle and to work together on the project and learn from each other and get support from others that might have a slightly different background. And that's the best way to learn, especially when it comes to technology. You can also gain experience that will look great on your resume, and that's more maybe for people who are slightly earlier in their career. But you know, getting a job at a big open source project is usually quite hard. I mean, you know, there are only as many jobs out there, and usually they have various requirements, and nobody will hire you as a freshman if you haven't never worked on a code. But when you have big open source projects, nobody's asking for your resume. They're asking you to start working on the code and start helping. And the more you help, the more you learn, the bigger portfolio you build. And especially today, you know, it's been a very interesting journey for me, because I'm 33, almost 33 years old. So even for me, when I was studying, it was very clear that I have to get my master's degree, get my PhD if I ever want to get a good job. But by the time I was already finishing my PhD, the feeling and the kind of appreciation for experience over just, you know, good grades in school has changed dramatically. So, you know, I have a PhD and nobody really ever asks me about it, other than maybe, you know, as I can tell an anecdote, how once I was a PhD student and how I hated it. But when I talked to people, when I had all of my job interviews, nobody really cared. They cared much more about the projects that I worked on and the volunteer work that I've done, both in technology and outside of technology. So yeah, open source is a great way to do this. And you get a group of people that are interested in the things that you are, which is also great, because especially, you know, when you are a minority of sorts, or you don't have people around you that are passionate about the same things, building that community or getting into that community of people that are already passionate, and internet is helping us tremendously with connecting with others, right? So you really get to get involved and meet friends that you normally never meet. I mean, I was one of two women studying computer science in Poland. In my year, we had 120 men and two women. And it was only when I started looking outside of my year, when I started participating in various activities, and then especially that I was fascinated by security, which wasn't a very popular or domain. I would say most of my friends wanted to go into networking and administration and things like that. So it was only when I started looking around and participating in open source projects and focused on security, being part of the free open source software foundation, that's when I found people that are as passionate as I am about the same things. And we were able to start things like social hacks or random hacks of kindness, which is a very cool initiative. If you haven't heard about them, I highly recommend it. It's a very nice way of bringing the technology and social impact together. But all of that came through me being involved with projects that didn't pay anything. I just wanted to learn something and to find friends. And yes, it's sad to say that I needed to find friends, but I guess, it's hard sometimes. So how to participate in the open source community? I think that the three things that are very good to start with, or the principles that you should take with you, is first, feel free to lurk. There is no good or bad, right or wrong when it comes to interacting with an open source community. We all have appreciation for being different and having different backgrounds, different cultures, different languages. So nobody will judge you for asking questions. If you ask questions and then don't really read the material that you've been pointed at, then probably they will start judging you, but for being lazy, not for not knowing things. But every newcomer is always welcome. And if anything, we, the more, experienced open sourcers, we will feel bad that your question has been left unattended for too long. But don't feel discouraged either, because we are all humans and we all get very, very busy. So if you're not getting an answer, maybe it's worth prodding again, or maybe it's worth reformulating your question a bit to see if you get an answer then. And most importantly, don't wait for an invitation. The open source community is, as I said, a democracy. Only those who do get a voice in the room. And so this is your invitation. Here you go. I personally invite each and every one of you to participate in an open source project. And you can ask me for an email if you want, and I can email you an invitation if that makes you feel more comfortable. But honestly, just show up and it'll be fun. It'll be good. It is worth reading the code of conduct, and I think that every healthy open source community should have a code of conduct, because while we are all nice to each other and should be nice, it's always good to have some kind of a rule book or a guidance on how to behave, especially in a situation where we often don't see each other, can't read each other's emotions. And that's where a lot of the challenges of open source community happen or come from, is that lack of face-to-face communication, which I mean, after a year of sitting in the same room and looking out the same window, I can tell you I'm missing human connections, and I'm sure all of you do as well. And everyone has a different story. It's worth remembering that no two open source journeys are the same, and no two open source contributors are the same. You will have people who want to just fix bugs. They are coders. They want to come in and improve the code. There are people that want to just use the project, and that's also fine. You do contribute by using. You just contribute by using and promoting the code, by helping it become the most prevailing or the most popular code out there. That is as well very important. So don't disqualify or don't underestimate the contributions that you're making to the community if you're not coding. And I do want to make sure that you remember this, because not all of us are coders. Not all of us can help with fixing or building new features. But there is a tremendous amount of work that has to be done, that in some ways sometimes is even more important, because we can always hire developers, or developers can be hired to fix the code. It's much harder to find people who will have the time to test, to work, to write the documentation, to translate things. All of this fairly minor in some ways, but very hard and much less rewarding tasks, I would even say. Then there are just people who are at the beginning of their journey, and they want to understand what the projects do and how to use them. And finally, there are people who want to contribute new features. So they are not interested in fixing what's not working. They want to build new code. And for those of you who want to build new things, I would suggest that you first engage in the community, and show up and help fixing a couple of bugs, or at least participate in the mailing list or discussion forums before you propose new features. It's just like, imagine that you're building your own thing, or I cook a lot, so I like to make a lot of comparisons to cooking. So you're making your own cake, and you're working on it, you came up with the recipe, you bought the ingredients, and then somebody comes through the kitchen door and says, oh no, I would do it completely different, like try adding 5 eggs instead of 6. If I don't know that person, if I don't have a certain trust in their abilities, I just feel like they are an intruder. And it's just a natural human reaction. It has nothing to do with that person or with me. It's just the way that things go. So try first engaging with the community and showing your interest and interest in learning from others before you start pushing for new features. Before I dive into certain elements of Hyperledger and designing for inclusivity, I see that there's a question here. I have heard about BAF, Blockchain Automation Framework, which automates the Hyperledger Fabric setup and gives much more scalability. Does Hyperledger plan on such kinds of automation frameworks for the easy deployment of Hyperledger Fabric? I'm not sure if I understand the question 100%, but in general, there is a lot of push from the community to automate a lot of the work or deployments. So I would imagine so. There is. It's a hard question when you ask, does Hyperledger plan to do something? Because it's literally a collection of people who don't even know each other, and they know each other's nicknames on chat or mailing list. So they sit and they plan for things, and then someone else comes and proposes a completely different project, and that project may be complementary to Hyperledger Fabric in that case, but it is not driven by the same group of people. So Hyperledger Fabric is being currently contributed, being developed by over, I think, 500 or 600 developers around the world that contribute on a daily basis. These people work for various companies, and sometimes just are passionate and volunteer. And because Hyperledger Fabric is so widely used, quite often people come in and say, well, we would like to do this or that. And so in this case, the Blockchain Automation Framework was a project that developers in Accenture were building, and they just suggested that they would like to build it out as a Hyperledger lab. Labs being like an R&D space for Hyperledger, where you can just come in with your idea and host a project. And it's not an official Hyperledger project as such, but we help with building the community and give you the GitHub repository and mailing lists and things like that. So that had nothing to do with core Hyperledger Fabric. It was just a side project of someone, similarly to the BIF, Blockchain Integration Framework, which is now Hyperledger Cactus. And as BIF shows, this kind of project that is just as, you know, someone's R&D little experiment can then turn into full-fledged part of the greenhouse, but it doesn't have to. So I don't know if there is much planning around it. I don't think that it's on the roadmap of Hyperledger Fabric. There might be some work being done by other Hyperledger Fabric users. So I would take a look at Hyperledger Labs and see if there's something in there that you're looking for, or simply just join the mailing list of BAF and ask there if that's something they're planning. Is there any scope of integrating IoT with existing projects in Hyperledger? Would you be able to expand a bit more on that? Because maybe that's something that's as I'm waiting for the wider explanation, I'll clarify this. Hyperledger code bases are, going back to my culinary comparisons, are like a pre-made puff pastry or sponge that you buy in a shop, and then you put a layer of the cream and jam and whatever and make a cake out of it that you can, you know, serve to your guests. Nobody really will eat the pure sponge. They want the additional things on it, but baking the sponge is what takes the most time and more effort. And what we do in Hyperledger is we provide that sponge. Now, you can use that sponge to make it into a Victoria sponge or a red velvet or a brownie or whatever else, right? Or a chocolate cake. And so integrating IoT with existing Hyperledger projects, there are a lot of solutions out there that are using Hyperledger code bases Hyperledger code bases to build IoT solutions. So for instance, they use the blockchain, say Hyperledger Besu, as a layer for IoT devices to upload their measurements from the sensors and to use the blockchain as a source of provenance or a proof of provenance. There are projects around supply chain and tracking where the blockchain is used for tracking, and IoT devices are used in containers to measure the the conditions in which food is being transported, and that's also uploaded to the blockchain. So we don't really build industry specific blockchains because we think of blockchain as or distributed ledger as a technology that is an enabler for virtually anything. So in some ways, you know, Hyperledger India is very much focused on identity, but it doesn't matter if it's an identity system for animals, for things like an IoT identity system, or for humans, or for COVID credentials. It can be anything. Hyperledger Fabric is being used, you know, in the fashion industry, in supply chain, in food, in even actually there is a project that allows you to find find fraudulent whiskeys, where you can analyze the visual aspects of a liquid that is supposed to be a, say, 10-year-old Japanese whiskey, and use the blockchain to verify if that kind of liquid could be a 10-year-old Japanese whiskey or it's something else. I'm not sure if that answers your question, but if not, then feel free to pop into the chat, or if we can unmute you, then that would be great. Does Hyperledger Fabric support archival of data in its upcoming releases? Do you mean like revocation, or do you mean like offloading information from blockchain to an off-chain storage? In general, once something is on a blockchain, it stays there forever. So there is no plan in introducing deletion or anything like that. There are some efforts towards sharding and kind of batching things so that you can kind of never get rid of the data, but keep the metadata rather than just every single detail. on the blockchain, meaning that it reduces the size. It's similar to what public blockchains are doing. The real issue is that with permission blockchains, the idea is that there won't be ever as much data as on a public blockchain, so it should have that big of an impact on it. Okay, any more questions for now? Okay,
We have answered the questions. Please go ahead. They may pop in between.
Yeah. So what do we do in Hyperledger to support this inclusivity? First of all, we work on documentation. We make sure that it's up to date. We prioritize documentation tasks and update it based on FAQs. So if you have questions, one of the reasons why it's important for you to ask questions is that it means that there wasn't an answer in the documentation, or there is, and we'll then point you at reading the documentation. But it's a very good feedback loop on how good our onboarding process is. We have introductory tutorials to help you learn more, and making sure that basically everything works together. We try to have a good contribution process, or well-documented the contribution process, with guides and understanding that there are many ways of contributing, what I discussed earlier. And we're actually about to release another kind of guide on contribution pathways and ways for everyone to contribute, no matter if you're a coder or not. We also try to be as transparent and open as possible. Almost all of our conversations, well, no, all of our conversations are held online. We use wiki and mailing for this, and all of the decisions are made publicly. So if you don't know where to find this information of why a certain decision was made, or how do you get into a meeting, then I suggest going to wiki.hyperledger.org, where all of it is described. And all of the meetings, like even if it's something is called a maintainer meeting, you're more than welcome to join and speak up. It's not even a webinar style, it's a regular call. So you can just unmute yourself and speak. And we do try and encourage projects, although it varies from project to project, to label good first issues or good first bugs, where if you go into GitHub or Jira, you will find that a certain bug was tagged as a good first bug, so one that you might want to take up if you're new to the community and you want to do like a minor easy fix to ease yourself into it. As I mentioned, this is your invitation, and I will hammer it into you. Please get involved. There are certain guidelines and guides for getting started. I encourage you to read those 4 very good resources. We have how to contribute to open source. We have getting involved in open source projects, 10 entry points to tech for girls, women, and everyone, and a beginner's guide to contributing to open source. These are very, very good open source resources. I'm happy to share my slides or the links with you afterwards, or you can just Google for the titles and you'll find it. It's all publicly available. There is a very good website called opensource.guide that also will give you a lot of hints on how to work with open source projects. Oh, and now we get into, sorry. Always happens, doesn't it? There we go. So if you haven't, please do take a look at our meetups. Currently, in the COVID world, they all happen online, so you actually don't have to participate only in your local meetup. You could participate in one that is happening in anywhere in the world, as long as you are okay with the time slot it's happening in. And we have a massive community. Meetups are a great way to start interacting and collaborating with community members, because by default, people that show up to meetups are those who are as interested in participating as you are. And we have over 70,000 meetup members, over 170 groups in 80 countries. As a matter of fact, in India, we have an amazing India chapter. So not only do we have local meetups in major cities in India, we also have just a chapter that is collecting all of the meetup groups from various cities into one. It's incredible work, and I know that Sangits and other universities in India have been doing a wonderful job at facilitating it and bringing everyone together and encouraging more collaboration. So thank you for that. There are many ways in which you could participate in a meetup. You could attend one, of course. You could speak at one at a meetup, and I know that all the meetups are always looking for new speakers. So it's a great way for an opportunity to introduce yourself and make it so that you're just get to know the community better and show what you're doing. You can also support a meetup either by providing space and food. That's when we are allowed to meet in person again, or by helping with organization of a meetup in your area. If you have any questions or would want to get involved, you can always email us. And David Boswell, my colleague, is a very experienced community builder, and will definitely be happy to get you involved with meetups. There's some basic tools that every Hyperledger project uses. First, you should set up yourself an account on a Linux Foundation account. It's free of charge. It's very simple, but it will allow you to just get access to all of the collaboration tools and kind of be identified across various Linux Foundation projects. And one thing that maybe I should mention here is that while I'm representing Hyperledger and that's my favorite project, Linux Foundation has over 80 different projects in every major industry. There is one on energy, one on AI, one of edge computing, one of cloud native computing, networking, automotive, drone, media, film, basically anything. And so if you are interested in participating in an open source community, but blockchain isn't necessarily your thing, I promise you that there is something that you will find interesting. And what I'm talking here about is not specific to Hyperledger so much as to the Linux Foundation and how we work. So do feel free to Google for or search for Linux Foundation project and see if there's something that you'd find interesting and exciting. If you want to join the discussion, we have a chat. The chat is kind of a way for us to communicate in a more real-time manner. We also have a mailing list, which allows you to ask questions and communicate with other participants. It's not as, let's say, as real-time, but it will give you will get you answers, and will probably be a very good way, especially when you have more complicated issues or questions. GitHub is where we store our code. We have a bug reporting system, and every project has that described. And then we have Wiki, where we keep the kind of living, it's like a living book where we constantly update information about all the projects, all the working groups, special interest groups, and so on. So you can contribute code to our existing projects by getting a copy of the repository, finding an issue to work on, making the changes, creating a pull request, then expect comments. And please don't feel offended if there are comments. It only means that people care, and that's great. And then you will have to address those comments before your pull request can be merged. You can also start a new Hyperledger lab. I mentioned that, which is a way, if like you have a project, and I know that there is a hackathon that is happening right now. So if you are working on a hackathon or a hackathon project right now, and afterwards feel like actually you'd want to continue working on it and you'd like to build a community around it, then proposing a new Hyperledger lab is a very good idea. And it's a very simple process that is described on our GitHub. And if you have any questions, I'm happy to answer them now. We are aiming to work on bringing Hyperledger to many more languages. This work has started with translating Hyperledger Fabric documentation into several languages, including Portuguese, Japanese, Malayalam, Spanish, French, and Russian. And currently we have even more work and more contributions happening. So even more languages to come, including Italian. We will hope, or we have now managed to make information about Hyperledger Fabric available to more than 1 billion people who speak those languages, which I'm very proud of, and it's been an amazing work. And again, thank you guys from Kerala for helping out with this, because it wouldn't have happened if it wasn't for you. If you'd like to translate to a language of your choice, there is a contributing documentation guide, which will help you with this. Finally, if you'd like to join something that's slightly less technical, we have special interest group and working groups. Special interest groups are sector specific, so they focus on a special industry and how does distributed ledger technology help in that specific industry, being healthcare, social impact, supply chain, trade finance, climate action. I don't have a slide here, but we just launched media and entertainment special interest group as well. So that might be something that is interesting to you. And then on the other side, we have community working groups, which are focused on technical aspects of an industry. So, various aspects of technology. So things like architecture working group or identity. We have a diversity, civility, and inclusion working group, which I'm very happy to have and to support. It's one that is focusing on how can we make the distributed ledger space more inclusive and diverse. And then finally, once you are an experienced hyperledgerian, if that's a word, you can take on some leadership roles. As a technical person who is contributing code, you can help set the direction and future of any of the Hyperledger projects by taking a leadership position and by contributing to a project over a period of time with obviously high quality contributions, you can become a maintainer. And that means that you will not only contribute new code, but also vet others people's code and decide on the direction of the project. There are very, very different ways to that projects manage their maintainer submissions. So if you're interested in a particular project, you probably should read the guide for that particular project. If you just contribute, and it doesn't have to be code, you could contribute to one of the working groups, not special interest groups, just working groups. You can be part of the technical steering committee voting process. So anybody who has contributed in the past year to the code, the documentation, or other technical artifacts to the Hyperledger code bases is eligible to run and vote in the TSC election. And out of everyone that is eligible, 15 people are chosen to be the TSC for the following year. All of the meetings of TSC are open to public, so you can absolutely join the meetings and see how TSC is working. And then we have all sort of other leadership roles. We always actively look for people to contribute and also lead special interest groups and working groups. And also, of course, we have the regional chapters. You can either participate in the India regional chapter, or if you're outside of India, we can work on establishing a regional chapter in your country. And then finally, of course, if you want to take on a thought leadership role, then we always welcome writing blog posts, guides, tutorials, and all sort of other things. And with that, I'm happy to answer any questions you might have. Thank you again for having me. It was a pleasure to be able to talk to you.
Thanks, Martha. Thank you so much. Thank you for guiding the participants to get into the Hyperledger community and build themselves into successful Hyperledgerian. Okay, audience, if you have any questions, please drop them in the Q&A. Meanwhile, I have a question before you conclude. Would you like to recommend any book or any reference tool that inspired you about your work?
That's a good question. So I find our courses, the free Hyperledger courses, very good. I think that they really help to get started and learn more about blockchain in general and Hyperledger. And then I can't really recommend a particular book or resource. I would say that what I find very invigorating is looking at what the various special interest groups do. And although, it's not part of my job description, and I definitely have more than enough things to do in my life, I do try to show up to at least one meeting of every SIG a month, so that I know what there is happening, and I'm subscribed to all of the mailing lists, which means that I see the presentations. So each of the special interest groups has usually a speaker during each of the calls. So you get exposure to a ton of very interesting work and projects that people are working on.
Thanks, Martha. Any more questions from the audience?
Well, you're always welcome to email me or email info@hyperledger.org. My email is marta@linuxfoundation.org as well. So I'll pop that into the chat for those of you who want to contact me directly. Oh, how to be part of community. Oh, I would hope that I covered that with all of the information that I provided. I guess you should just show up to one of the calls, the special interest group calls or working group calls. It really depends on how do you want to get involved? Do you want to get involved on the technical level or more on the kind of business level? All of the things that I talked about, so the contributing code, being part of special interest groups, working groups, being part of meetups, it's all community, and it's all just show up, and that's it. So if you want to learn more about Hyperledger, please go to edX.org, which is a platform. I'll just go and show it to you directly. Just bear with me. So there are 3 courses that we offer that are free of charge, and I apologize, I should have definitely put that into the my slide deck, but I think that you can still see my screen, so I'll show you. If you just Google edX Hyperledger, you will see the courses, and it's a series of courses. Some of them are completely free, some of them are require a little payment. You can just don't be fooled, because here you can say that it's free, but you can add a certificate, a verified certificate for $200. That certificate is not necessary at all. It's just, it's not even, the course with or without certificate doesn't have a difference. There's no final exam if you paid it $200. It's just an official certificate that says that you participate and finish the course. And as you can see here, the syllabus is quite extensive. This particular, it's Introduction to Hyperledger Business Technology. This is the most high level one. You will find also a much more technical course that is called Introduction to Hyperledger and its technologies, I think. And then there is a course on Hyperledger, Ursa, Aries, and Indy, which is Introduction to Self-Sovereign Identity. So all of those 3 courses are definitely worth taking. And then once you're done with that and you would want some more kind of official professional certification, there is an official Hyperledger certified developer and certified administrator course and exam. That one is there is a charge and there is a very hard exam that you have to pass at the end, but it is a professional certification recognized around the world. So you can just do that. So you can see here, we have the Introduction to Hyperledger Blockchain Technologies, Introduction to Hyperledger Sovereign Identity Blockchain. So that's the one. And then Blockchain for Business and Developing Blockchain-Based Identity Applications. So all of those. I hope that provides the answers to that question. I lost my chat, so let me just go back. Yeah, so that was the only question we had. I'm just popping in my email. Okay, so this is my email. Feel free to reach out to me if you'd like to ask any more questions.
Okay, thanks, Martha. Thanks once again for joining us live today. Hope we can associate with you in similar events in the future.
Absolutely. Yeah. Looking forward to it.
Yeah, thank you. It was brilliant. It was a wonderful session. I believe that it has really motivated the audience who are like planning to kickstart their blockchain career, especially who are like very much interested in the Hyperledger framework. Okay, so thank you for guiding them. Thank you once again on behalf of KBA. Have a great day ahead.
Thank you.
Bye. Thank you, participants, for joining the 2-day free blockchain bootcamp for women. You'll be accredited with a blockchain path certificate in a day or 2. Appreciating your participation. Once again, on behalf of KBA and KBA Women Connect, thank you for joining the 2-day free blockchain bootcamp. For the complete video recording of the 2-day event, you may subscribe the KBA video channel. The link will be provided in the chat. Okay, thank you. Thank you.